Good sir. Good morning. I'm connected, dear. So, yeah, okay. I'm sharing my slides. Yeah.
Hello.
Hello, sir.
Hello.
Yes.
Hello,
Good afternoon.
Professor.
Yeah.
Good morning.
Good morning. Can you
Yeah,
hear me?
yeah. Yes, yes.
Okay, good.
The
Very
voice
good.
is clear.
Yeah. Okay.
Yeah,
So
yeah, yeah.
I will join you in 5 minutes.
Yeah, yeah. Okay, yeah. Yes, yes. हम्म, हम्म, छोडून
मुलांना 3 ह्याच्यात विभागायचे असतात ते आम्ही काढून
Hello, hello, good morning, sir.
Hello. Uh, am I audible?
Yes, 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 sir. Hello.
Yeah, yeah. Thank you. Thank you, sir.
A very good afternoon to one and all present here. Good morning, everyone. I, Professor Kiran from Department of Computer Science, welcome you all for the second technical session of today. International Conference of Innovation in Science Sustainable Development 2025. I humbly request the Honorable Professor Dr. Manoj Gawande sir, Institute of Chemical Technology, Jalna, India, to kindly join the session as a chairperson. Now, I request Dr. Sanjay Shamkuar sir, please come on the dais and please take your seat. Thank you, sir. And I request Dr. Dinesh Kumar Sasangi sir, please come on the dais. And I request Power sir, please come on the dais. Now, thank you, sir. Now, I request Honorable Couplet for Energy and Environmental PVT Ltd, Kathmandu, Nepal, to kindly join the session online as a speaker. Now, I request Dr. Sanjay Shampur sir.
Well, thank you, ma'am. I am very much thankful to the organizers for giving me this opportunity to introduce chairperson of this session, Dr. Manoj Gawande. Professor Manoj Gawande, sir, Fellow of Royal Chemical Society, FICS, Dr. Habil, received his PhD degree in chemistry in 2008 from the Department of Chemistry, Institute of Chemical Technology, which is formerly known as UTCT, one of the premier institution in chemical technology in India. Under the supervision of Professor R.V. Jairam, during his research tenure, he has been awarded several prestigious fellowships, including Senior Research Fellowship from CSIR New Delhi, Brain Korea 21 Research Fellowship from Ministry of Science, South Korea, and FCT Research Fellowship from MCTES Lisbon, Portugal. In 2013, he worked as a visiting professor at Division of Chemistry and Biological Chemistry, Nanyang Technological University, Singapore. In 2015 and 2016, he received Dean's Award from Palaki University, alum of Czech Republic, for best publications output. In the year 2019 to 2023, he is selected as top 2% scientist in the world, published by Stanford University. Presently, he is working as an associate professor at Institute of Chemical Technology, Mumbai.
Queries complete नाही होत ना जोपर्यंत तुम्हाला रिस्पॉन्स भेटत नाही
Professor at VSP, Ostrava, Czech Republic. During his stay at RCPTM, Palaki University, he has several visiting professor scientist positions, including Professor Steve Lane from Cambridge University, United Kingdom, Professor Dunwei Wang, Boston College, Boston, USA, and Professor Rajendra Yaswarma, EPA, Cincinnati, USA. His research interests are in the development of greener raw materials and synthesis of nanomaterials and their applications in sustainable chemistry. He has published more than 170 scientific publications, including reviews, patents, papers, editorials, and commentary articles. He has more than 80,000 citations. He published his work in top-tier journals, including American Chemical Society Catalysis, Applied Catalysis B, Energy and Environment, Chemical Science, Chemical Engineering Journal, Green Chemistry, Account of Chemical Research, Chemical Social Review, Chemical Reviews, and Nature Catalysis, etc. Recently, he has elected as Life Fellow of the Indian Chemical Society. Also, Professor Gawande has been awarded the prestigious Royal Chemical Society Research Fund Grant 2021 by the Royal Society of Chemistry, Cambridge, United Kingdom. Also in 2021, he is nominated as Fellow of Maharashtra Academy of Sciences. Dr. Gawande is an editor of several leading journals, including Executive Advisory Member by American Chemical Society Sustainable Chemistry and Engineering, that is from Publications, Current Chemistry from Bentham Publications, Associate Editor for Current Catalysis, Regional Editor of Europe Zone for Current Organic Synthesis, which is from Bentham Publications, and Editorial Board Member of Scientific Research from Nature Publications. Recently, he invited to edit a virtual issue as a guest editor on N-doped carbon materials, synthesis and applications by ACS Sustainable Chemistry and Engineering from American Chemical Society Publications, and a special issue on single atom catalyst by Small and Advanced Material Interfaces, which is from J Publications. So this is a short introduction of Chairperson Dr. Manoj Gawande. Now I request Chairperson Dr. Manoj Gawande to initiate the session. Thank you.
Hello. Good morning, everyone. Am I audible? Am I audible?
त्याच्या मनगटात दम होता म्हणे म्हणून
Yes,
तो
yes.
बोलून गेला म्हणे एवढा
Okay. So good morning, everyone. Thank you for kind introduction. Allow me to introduce our today's speaker, Dr. Beam Kapli. About Dr. Kapli, he has completed MSc in Chemistry in 1998 from Tribune University, Kathmandu, Nepal. He has also completed MSc in 2004 in Solar Energy from Ben Gurion University of Israel, and he has completed this PhD in Physics 2008 from Graduate University Advanced Studies in Japan, and he has also completed his postdoc in 2011 in Physics from Wisden Institute of Science and Israel. So on his credit, he has published 2 books, and he has published 1 book chapter, more than 35 scientific research publications. He has also 2 patents in his credit, and he is also awarded 2 important grants. One of the grant is Young Scientist Award in 2013 by TWAS, and Best Award by the ESTD 2011 US Polychor 2019 organized by ICISSD conference. And he has also received the research grant, which includes 1.1 thousand USD research grant for establish the nanomaterials and solar tech lab at KU. And he has also supervised more than 20 graduate students, including MSc, PS, MPhil, and PhD in more than 30 UG students. Okay, so who are pursuing the higher studies in US, UK, and Korea. So he is working in the research area of solar thermal technologies, nanomaterials for solar energy technologies. So without taking much time, I would like to request Dr. Beam Prasad Kaple to start his lecture. Thank you so much. Dr. Kaple? Dr. Kaple, are you there?
Yes, I'm there. Can you hear
Yeah,
me?
yeah, I can hear you. Please go ahead.
The video because it disabled. Would you? My video is disabled somehow.
Okay, anyway, you can share your screen and you can
Yeah.
start.
Yeah. Okay. Okay. Am I audible and visible?
Yes, you are audible and I can see your screen.
Okay. Okay. Nice. Thank you so much. I thank you for the organizing committee for inviting me in this prestigious international conference, ICISSD 2025. I have been, and I especially thanks to Professor Gurnule and his team. He has been a very good friend of mine, and we have a collaboration. Nice collaboration has been going on after 5 years. Today, actually, I'm focusing on nanomaterials, basically that can be applied to solar cells and also solar thermal collectors. Here, I will be discussing my findings focused on solar cell applications, nanomaterials for solar cell applications. So my title of my talk is Impact of Dopant Concentration, Calcination, and Thickness on Optical Properties of Tissue Thin Films. So would you help me? Okay, now it's okay. I think the slide is moving. Okay, here is my outline. I will be briefly discussing about new technology on solar cells, especially thin film based solar cell, and its components, and where we are working on. And mostly transparent conducting oxide and controlling the preparation of the transparent conducting oxide. Then I will be discussing on synthesizing and characterizing these very thin films required for solar cells, and then I will be discussing what currently we are doing from our side on this preparing and characterizing on transparent conducting oxide. That was one of the important layers of the solar cells. And then I will be discussing these controlling parameters for thin film preparation. Just give me a moment for I will select um, some. 1 minute, okay? I will just okay. Slide is not moving somehow. Slide is somehow not moving. Could you help me? Okay, now it's okay. I wanted to just a minute, okay? I wanted to anyways, no, cursor is not. I wanted to highlight the and the pointer. But,
You can do the right click
okay, now,
on the
now.
yeah,
Can
we
you see
can
the
see.
okay, thank you,
Yes,
thank you.
yes.
So I think all of us know about the new technology on solar cells. The silicon solar based solar cells have demerits. Well, it is very stable. We know it, but it has some theoretical limits to about 33% above which we cannot go, how hard we try. So the cost of the reduction of this technology is very difficult. However, scientists now are working on organic based solar cell technology. That is one of the emerging technology is the perovskite solar cell. Here I will be discussing, and this is one of the panel recently produced by different companies. Here this is the photo of the solar cell produced by NREL, National Renewable Energy Laboratory in US, and this is one of the flexible, very fine, very nice flexible solar panel by Pulse Force. You can see it's already this solar cell technology has already been in market, but it has some issues to be addressed that I will be discussing later. But at the moment, its current efficiency is about 27%, which is already above or very close to the silicon based solar cell. But in even in the when it comes to the panel, the solar cell efficiency of the silicon is much less, of 15 to even less than 20% when it comes to market in the panel scale. So in this context, the efficiency that we are achieving in case of perovskite solar cells already marvelous. So this technology has a promise, high promise for future use. Yes, you can see I'm showing again the other examples, like how you bend this. Again, you bend in this kind of solar cells, and you can also use this kind of solar cells in backpack. You can charge your mobile phone or other electronic devices while walking and putting in the backpack, and also small devices like this. And he is the pioneer. We must acknowledge him. Hello. Yes. Yes. For his technology, for his contribution in science, his name is Michael Grazel. Yes. We are also, making effort from our side to produce this kind of solar cells, and this is one of the solar cells we produced in Nepal. Here you can see these are very fine, small solar cells. We combine here 5 solar cells to get photocurrent and photovoltage. Yeah, this is we showed in one of the national exhibition in 2015 in Nepal. So that was actually very nice experience to make a small solar cell devices like this, and like this, and connect like this and get at least to demonstrate students, graduate students, and other interesting scientists to show that it is feasible and it is workable. we can also work on this and produce solar cells. Yes, here I will briefly mention what are the components of this kind of solar cells and what is its working principle. Here you can see multiple layers of solar cells. Multiple layers in this perovskite solar cell. One of the most important component is the this red one that absorb solar radiation when we shine from the top. And after absorption of the solar cell, it produces electron that goes to electron transport layer, this layer, and hole goes to opposite direction to this layer, hole transport layer. And then once this electron goes to this is passed through this transparent conducting oxide layer, and which finally goes to the circuit to complete this survey. So my point here is my work. I will be explaining. We are working on this layer here. How can we optimize to get to collect the electron, photo-generated electron, for better efficiency of the solar cells. So basically, we are working on this green layer. Yeah, so here I will explain here what is its working mechanism. After absorption of the solar, after we sunshine the solar radiation from top, this layer is transparent and this also transparent. This red layer gets solar energy. Once the solar energy is absorbed, the electron is transported to the electron transport layer called they're mostly titanium oxide layer, or there are other layers as well, but mostly scientists use titanium oxide. This is more favorable. And also the hole goes to this hole transport layer here, and then this electron comes to this fluorine doptein oxide or other transparent conducting oxide. This is the working principle of this kind of solar cell. Here one should note that the photoelectron produced here after photoillumination, yes, must have very nice electron transport, this layer must facilitate, this FTO layer must facilitate to grab this electron, photogenerated electron, and allow to pass through the circuit. If it's not, for example, here, if this layer is somehow has high defects, is not good, then we will get less voltage and less electric current. So it means that it should have very good optical properties and also electrical properties. Here in also other picture, this shows, this is this green line here, this FTO here in this picture is here in the top. You can see we sunshine the solar radiation from here. Yeah, that is what called transparent, because it is transparent and highly conductive also, therefore it is called transparent conducting oxide. And its application besides solar cell, as I discussed here, it has also application in display and touch screen as well. How we synthesize, what are the conventional synthesis methods of the transparent conducting oxide or other layers of the solar cells are described here. For example, this fluorine doptein oxide or indium doptein oxide are the commonly used thin films for transparent conducting oxide, and mostly are prepared by spin coating, deep coating, or spray pyrolysis, or also vapor deposition. Vapor deposition is a little bit costly, so mostly in developing countries like Nepal or other, like even some labs in India, or even other parts of the world, mostly people, if they prepare low cost techniques, they prepare this kind of low cost technique. How do they put substrate, for example glass substrate, on top of the spinner, and they cast the solution in the glass substrate, and then we rotate it up to 5,000 or 10,000 cycles, so that a very thin layer of this material is deposited on top of that, and then you heat it up to a certain degree for evaporation. Other technique is just you prepare solution of your precursor which you want to dope, and you put substrate on this solution, like here you can see here, and then after waiting some time, a thin layer will be deposited, or you can that is also way, or you can back and forth take out and take out and put it, so that a thin layer will be deposited, and then you have to heat it up to certain degrees centigrade. And another way is you put your substrate like this, and you make a jet of your precursor. Like precursor, if you are preparing fluorine to tin oxide, you prepare tin oxide, tin chloride or tin nitrate solution, and then you put in this nozzle, and this is the precursor solution. Here you have a air jet coming through here, and a solution is pumped from here. A jet will be splashed here. A thin layer will be deposited, but one should note that this should be heated up to 400 degrees centigrade to be a thin film. So this is how thin films are prepared. After preparation film, this one should make sure that this conductivity of thin electrical conductivity should be of the resistance should be of this order, and transparent usually prepared above 90%. So this is a bit challenging to get this kind of conductivity and transparency. So again, please, if you do not understand anything, you may ask me in the middle, or if hearing is poor, you can also mention me. So I hope I'm audible and visible.
Yes, yes.
Okay.
Go ahead.
Okay. So here is again, I think I should not repeat it. This slide give you overview of how thin films of tin oxide thin films are prepared. Fluorine, this is the precursor of the FTO thin film, and you prepare one of the methods, and you after you deposit the thin film, you heat it up to 400 degrees centigrade in oven, or you can also heat in presence of air, or without presence of air, or you can also mix other gas like nitrogen or argon. You can do that, and you can control the actually there are reports that you can control the electrical and optical properties, and then we characterize their properties, physical properties and optical properties, and so on. Yeah, while characterizing, we have challenges, like in maybe in developing countries it's not a challenge, but for a developing country like us, we have a challenge to characterize optical properties and also surface properties, for example. Here I will be discussing challenges on optical properties, characterizing optical properties, and what we have done so far. Okay. So after you prepare the film, the thickness of the film and the band gap and refractive indices makes the film whether it is good for using solar cell or not. And to optimize that, you need to have analytical facility for that. So is here this also before going that, I will again show a very small setup that we built at Kathmandu University in Nepal. This is a spray system, spray pyrolysis system. Here we prepare our solution precursor nickel oxide, this tin oxide, tin chloride solution here, and pumped and passed through this blue pipe and sprayed here in this oven. This is the here we have glass. Maybe you can see here. This is the heater where you are constantly heating to up to 400 degrees centigrade, and you spray from this pipe, and a thin, nice film is prepared. And this is the gas control system. And you can see here we have a this glass, thin white thin film deposited on the glass substrate. This is the control system for the deposition. You can control the thickness, you can control the control the height also, height of this nozzle, so that you can have a better films. And how do you now, after preparation of this kind of films, how do we characterize is by
ସବୁ ସେପଟେ
by
actually
measuring
heartbeat ଟା ଏତେ slow ହେଇଯାଏ
by measuring the optical transmittance. Optical transmittance is measured by following this kind of protocols, like this is one of the tool that we generally use for thickness determination. This is ellipsometer, but however, this is very costly and you don't have frequently available in most of the laboratories in Nepal. Maybe in India you have a lot of this kind of facilities, but Nepal we have very less. So we wanted a very easy method to determine film thickness very accurately, as equal to as this ellipsometer gives us. So my role here is to develop a theoretical method that I will be discussing here. For example, here what happens that when we shine a light, it light is reflected by the multiple layers, and you can collect the detector from the reflected light. You can analyze how thick the film is. Here you can see the very nice thin film prepared on glass substrate in our laboratory. This is produced in our laboratory. This is of ZNO thin film. Okay, and if you have you can also measure the optical properties by two methods. One is this optical properties. In optical properties, you have a light source. Through this optical fiber, you get light, and you shine to on top of your sample, like this is a glass substrate. Okay, and from here you can measure transmittance or reflectance. Similarly, you can also use UV visible. I think you are familiar with this kind of spectrophotometers. From this, you have both transmittance as well as reflectance curve. From that, you can estimate film thickness, absorption coefficient, band gap, and refractive indices. Okay, so here I will be showing some examples how we do it. For example, this is the reflectance measurement of the reflectance of the samples prepared without any heat treatment, after treatment of the 275, 375, and so temperature dependent study of the thin film. You can see very nicely, if we do not heat treat the sample, the film thickness seems to be more homogeneous, but after heat treatment, maybe there are defects are produced. So the reflectance from the surface of this film is decreased very nicely. You can see very nice trend of this temperature dependence. So now challenge is there, how we estimate the thickness of this film. That is the challenge. And also you can other way, as I said here, you can measure the optical transmittance by using these two spectrophotometers. This is the transmittance measurement. Okay, you can see the transmittance in the UV region, very nice absorption by the FTO film. And after 400 nanometer light, you can see almost 85% transmittance. Almost all the light is transmitted. This is of the zinc oxide film, this dead dotted line of the zinc oxide, and this blue one is the fluorine oxide. And pure glass has a black color. You can see about 90% transmittance from these films. This is also measured in our laboratory. So this we published in Ceramics International journal, and we also use for estimating film thickness the well-known Cauchy model. But we found there are several problems with this model, and fitting and estimating this require very a set of parameters like refractive index, absorption spectrometer. You need to input an initial guess for the thickness, and the parameters given is not that sufficient. So we wanted to develop a very easy method, and that was problematic because as I said here, you can see the absorption increment in the absorption region when it goes to very close to the 400 nanometer. Okay, you can see very sharp decrease in the absorption, or this decrease in the absorption is called absorption edge. Okay, this decrease in absorption means increase in the transmittance is because of the is materials fluorine metal oxide films inherent property. Okay, so because the film thickness estimated to estimate this thickness of this kind of film, there are several theoretical models besides the experimental isometric measurements. The well-known is very well-known is Swanepoel method that uses transmittance measurement from this kind of measurement, or another one is Cauchy model that can you apply for reflectance measurement, and another one is Kusev model. The latest one is Kusev model that estimates very nicely. And the idea is if you have a for Swanepoel method or for Swanepoel model, if you can apply that model if you have very nice this kind of interference pattern on the film thickness. But if you do not have this kind of interference pattern, then it is very difficult to apply Swanepoel model. So the film thickness you estimate by this method is almost off, is not accurate. So for to address this problem, Kusev developed reflectance based model, but this model also has some problem because this estimates film thickness very nicely, but when it because this model does not consider the absorption decrease in the transmittance or increase in the absorption rate, the film thickness is inappropriate. The estimated thickness is inappropriate because this has an assumption. Assumption is that in higher wavelength, it has a negligible absorption solar absorption. Sorry, absorption that is okay for when you have after 400 nanometer. But if you are considering whole spectrum, you also need to consider this part, this sharp decrease in the transmittance. So because of that, that yields larger error in the estimation of the thickness and other optical properties like refractive indexes. Okay, so to address this, we further reevaluated Kusev's model by incorporating in the absorption cross section in the model. Okay, how we do it is like this. You have when this is a thin film deposited on glass substrate. Glass substrate is usually very high, thick, and the thin film is almost very thin. And once you irradiate radiation, it is reflected. The light is reflected by multiple layers, and you get a interference pattern like this, and you detect that in the detector. Okay, and yeah, this can be shown here like this, and you have, for example, ear. It passes through the ear, and refractive index of the of ear and thin film and also glass is considered in this calculation, and from that we could calculate very accurately the thin film thickness. For those who are not much familiar with this formula, so please forget it about that. But I would just here quickly mention here that this is the reflectance. This is the reflectance, this kind of measurement from the surface of the thin film. Okay, just it's a reflectance, and this reflectance curve is shown by the red line. Okay, this red line we measure from 400 to 800 nanometer, and you can see very nice interference pattern in our measurement. You can see this. Just check this measured this diamond shape spheres, and then we applied this model. That model is followed this equation. This is reflectance of the reflectance from the surface. It can be theoretically approximated using this formula. This has, this consider the refractive index of the refractive index of the material and also the glass. Okay, so this is the what I'm not going very much in detail about this equation. And most importantly, I would say, yeah, we must need two parameters. One is RM and another is small rm. That is means that once you know the maxima of this red points, all the maxima and all the minima of this interference pattern, you can make an envelope on that like this. Maybe I will show you an envelope, how we draw envelope, and then you can make a fit of these expressions. Like for example, here this is this red line is Cauchy fit in our data of these red lines. You can see the Cauchy fit is very nicely fitted up to 600 nanometer. After that, it is going a little bit up, but this cubic spline by Kushev model that I discussed before is completely off, and is the phase is completely off. You can see this is our experimental data, red one, and this is here. This peak is here, so almost 90%, 90 degree phase shift. So this Kushev model that is based on the reflectance has to be revised and upgraded. So we updated. We use a model that considering this absorption line here, absorption spectrum here, we took among the several parameters, we use statistical parameter called t-test for avoiding the avoiding the outliers of the experimental measurements, so that we can nicely fit experimental data. Okay, so for example, here I will show you how we do it. This is the experimentally measured this red line. Please look carefully here. This red line is experimentally measured reflectance curve in our laboratory, and this dash RM is capital RM is the envelope that we are drawing for estimating the film thickness and other optical properties. And here you can see this lower points are also very nicely fitted. This whole spectrum is nicely enveloped inside this dotted blue line and the green line. Okay, and then we estimated estimated and make a fit and produce from this envelope. We derived a refractive index and optical absorption and other parameters, and then use that parameters for estimating the film thickness. And you can see this is the this red line is the measured thickness, and up to let's say up to 900, you can see this dash this blue line is the fit. From there you can estimate the film thickness very nicely, and from this model we can get the film thickness of about 945. I think it's already a little bit covered with this yes, 944.5 nanometer. That was estimated by our theory. And by Swanepoel, you can see it's already largely overestimated. And we for testing with experimental, this is optical methods, and this is theoretical method. We wanted to test if it is correct from the ellipsometric measurement. We had a collaboration with US partner, one of the professor in Binghamton University, and he took our sample from Nepal and measured the ellipsometric measurement, and we found that the film has thickness of 933, which is almost 1% variation, 1.2% variation. It's a very nice corroboration between ellipsometric measurement in our theory that validates our method. And that allow us to publish in this journal, village journal, recently. So then we also applied our method to fluorine oxide at different prepared at different condition. We prepared film by calcinating at different conditions. Like we calcinated, we heat treated the sample at only air, and then after treating at air, we then treated introducing nitrogen, then check what is its optical and electrical properties. Then we also introduce plasma to check if it makes really the difference in the optical and electrical properties. Okay, so for plasma treatment, we have this facility, plasma generation facility. You can see plasma here, very nice plasma. This is low temperature plasma. We put sample here in this in here, and you treat the exposed to this radiation here, you put it here. Okay, so this is the conditions for producing this plasma. And then we also checked at different thickness, what would be the optical and optical properties if we vary the film thickness. You can see we varied from 5 minutes to 20 minutes. Then this red line, for example, this red line is deposited at 5 minutes, only 5 minutes in the proprietary setup. And this 20 this line is with 20-minute deposition. You can see 5 minutes, 10 and 10 minutes, they are completely different. You can see for the red line and blue line, they are completely, phase is completely different. So we see the temperature trend in the film thickness transmittance. Therefore, we also got once you deposit longer time, we expect a longer higher film thickness. That is what we observed actually. You can see here after depositing 5 minutes, 10 minutes, 20 minutes, and we produce these envelopes. For example, for 5 minutes, you have a red line. This is the measured spectrum, and this is the associated envelope on this red line. You can see all the top points are connected and lower points are also connected, and you estimate the thickness. And before estimating thickness, you have to estimate the refractive index and absorption coefficient, and you can calculate the band gap using tau clock. Here you can see, yes, this is you can see refractive index also depends on the film thickness. 5 minutes, this is the refractive index as a function of wavelength at 5 minutes, and similarly this is for the 10 minutes, and this is for the 20 minutes. You can see at higher energy side, they don't so much vary, but with increasing the wavelength, they vary. And the similar trend also observed in the absorption coefficient. And also you can see a band gap. This is the value of the band gap. You can see you can clearly see the band gap is about for the blue one for 10 minutes deposition is about 3.4, and here you have about 3.25, something like this, with 5 minutes. So it's we can also observe the variation in band gap with year variation under year after different diffusion time. Similarly, we also tested as a function of gas under treatment under nitrogen gas, or only in the presence of nitrogen. We saw it actually, very nice train is there, as shown here. I would only mention here this is the refractive index. That is one of the most important parameter. You can see with 5 minutes, this is the refractive index, while with other time they does not vary so much. As a result, you can see for 5 minutes the band gap is about 3.25. For others, it is a bit higher. Again, similarly, after we also tested, as I said before, we treated plasma, and after treatment of the plasma, you can see and this refractive index changed. Only mainly 20-minute deposition and other two are quite distinct, and absorption coefficient has also trend. For example, here with the 5 minutes, it has low absorption. With increasing the film thickness, the absorption coefficient is also increases. It is more drastic than before. This is less drastic. Here, after treatment of the plasma, it is more drastic change and very clear dependence on the plasma. Okay, the plasma has much more has influence. Unlike here, not much clear, but here you can see much clearly. Here also much clearly, and the band gap also can be seen very clearly. So this is thus final slide of mine, and in summary, I would summarize of my talk is that we successfully successfully developed a theoretical model to estimate the optical properties like band gap, refractive index, and other absorption coefficient like this, and that can be applied for all kinds of transparent and semi-transparent films. Now we are using this model in collaboration with other scientists in Nepal, and those whoever would like to use this model, very simple model. We will be very glad to collaborate or share model. There's no problem for us. And with this regards, I would like to stress that this model has been tested. I had a data from the 10 years measurement. And we applied this model, and we are now on the way of publishing this data. So this model also fits and gives very nice, accurate results. So with these notes, I would like to thank organizers very much, and also I would like to thank Professor Lee of NCKU. I'm in Taiwan now, and he helped me to provide this seminar hall for delivering this talk. And I also thank you very much, ICISSD organizing team, and Professor Gurnule, who is the very best friend of mine. Thank you so much.
Okay.
Yeah.
Thank
Yes,
you,
any
Dr.
question or
Kaple.
any queries, you are welcome.
Yeah. So feel free to ask if there is a question for him.
Hello, Kapil sir.
Yeah.
Just I want to make clear that you have synthesized the TCO and FTO
Yeah.
film. Na? So
Yeah.
what is thickness of that, and is any effect of this thickness?
Yes. Let me share one more time.
Just thickness is very important.
Yeah, thickness, it was about 900 is about 1 micron, but we can apply this to 300 nanometer also. We applied actually. So
Okay.
while testing, we also produced film of the 200 nanometer in US, and they use ellipsometric measurement, and we had a film of about this thickness, and we found very, very much good agreement.
And how you measured in your?
Okay, just a minute. I will share you one more time this slide. How we you mean experimental measurement or theoretical measurement? Theoretical evaluation.
Okay.
Yeah. You mean, for example, first we measure 1 minute, okay? I will show you the here. Yeah. First, we measure this reflectance.
Yeah.
Yeah, and in this red square is the measurement, experimental measurement.
Mm-hmm.
Yeah, and then we fitted our model like the model here is this blue line is our fit present
Okay.
work. You can
Yes.
see
Yes.
here.
Okay.
Yeah, you can see very nice fit. This
Yeah.
black
Yeah.
line is cubic spline by Kusep that was
Yes.
developed in 1986. That is
Okay.
completely
It
off.
is clear. Yeah. Yeah. Okay.
Yeah, yeah, yeah.
It's okay. Okay. Yeah.
That was the biggest achievement of our work. Yeah,
Doctor, nice
yeah,
presentation you have
yeah,
given. Yeah.
yeah, yeah.
And nice work.
Thank you so much.
Okay. Yeah.
Yeah,
Yeah.
I would be very delighted to collaborate, Professor. Good
Yeah.
morning.
Yeah. 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 We are doing both the thing.
Yeah,
Yeah.
yeah,
Yes.
yeah.
Any other question for him?
I thank one and all for the technical session 3 of this.
I think there is no question,
I
right?
thank one and all for the technical session 3 of this international conference, Innovation in Science of Sustainable Development 2025. I thank the chairperson, Professor Dr. Manoj Gavande sir, for the joining the session online. I thank today's session speaker, Professor Dr. Bhim Prasad Kapile, for joining the session online from Nepal. I thank station recorder Dr. Sanjay Chamkuvar sir. Thank you.
Yes, sir. You can do now. Okay. Yeah.
Lagi tekan parang.
Good morning, everyone. I, Dr. Srikant Varekar, Department of Environmental Science. Welcome you all. Today, we are going to conduct oral presentation session on behalf of college and ACT. I welcome you all to the oral presentation session of research papers at the International Conference on Innovation in Science for Sustainable Development. We are honored to have with us Professor Dr. Santosh Gostar sir as the chairperson of this session. He is professor at School of Chemical Sciences, SRDM University, Nagar. Welcome, sir. We also have Dr. Jagruti Bharatde, madam, as a jury for this session. She is a professor at PG Department of Chemistry, Sant Gadge Baba, Amravati University, Amravati, and Senate member. Welcome, madam. Also, we have Dr. Nandakishore Gawale sir as a jury for this session. He is a professor at GS Tompe College, Chandur Bazar. Welcome, sir. Both the judges are going to evaluate the session. Let's give them a warm welcome. The session will feature total 16 oral presentations each lasting for 6 minutes. After each presentation, there will be a 2 minutes question answer session where our judges and audience members can ask questions. Our judges will evaluate the presentation based on their technical content, presentation skills, overall. With the permission of chair, I would like to invite our first speaker, Miss Aishwarya Tarwani.
Hello, am I audible, sir?
Yes.
Yes, yes.
Hello.
Yes, you are audible.
This is Dr. Devsarkar from Nanded.
Yes, sir.
Yes, sir. Sir, okay. First of all, I welcome the juries of today's oral presentation, Dr. Jagruti Barabde madam and Dr. Nandakishore Gawane sir. And I would like to thank the organizing committee of the International Conference on Innovation in Science for Sustainable Development. And especially I am thankful to Professor Dr. Ashish Maldure for inviting me over here as a chairperson of this particular oral presentation. I am also thankful to Narsamma ACS College for organizing such a great event for the scientific community. So please, first presenter, they can start.
Tarwani, you may proceed.
Good morning to one and all present here. Myself, Aishwarya Tarwani. Today I am here to present my seminar on topic sustainable agriculture. Before moving towards the topic, first I would like to tell what is a sustainable. Sustainable means something that can last for a long time without harm. In the contents of food, we can say it refers to ensuring the food we eat today can also be available for a future generation in better condition. Do we need literally a sustainable agriculture? Yes, because of the growing population, continues in climatic changes, depletion of natural resources, and various challenges in agriculture make sustainable essential. One of the biggest challenges we face today is climatic change. Is it true that climate has always been the same? No, climate has changed over time, but its current rapid transformation is large due to we human beings. Because as we heard nowadays, the floods, volcanoes, and rising temperature is increasing day by day. Pollution is increasing day by day. Population is also increasing day by day. So because of that, the agriculture is getting damaged or harmed day by day because of a human being's comfort. Because of comfort, we are damaging our ecosystem. We are damaging our agriculture also. So to tackle these challenges, innovation in agriculture is essential. One prominent solution is precision agriculture. As we all know that it's now AI time, or we can say the AI flag is going on. So why not to go for such type of things like in the precision agriculture we can use of drones. ड्रोन्स हमें किस काम आएगी, जैसे कि हमें खेत में मिट्टी की जरूरत हो या फसल की जरूरत हो, हम ड्रोन के माध्यम से वहां पे मिट्टी या फसल की जरूरतें पूरी कर सकते हैं. जीपीएस सिस्टम हो गया. जीपीएस के थ्रू हम जगह जगह पर जहां पर पानी की जरूरत हो, खाद की जरूरत हो, हम वहां तक पहुंचने की पूरी कोशिश कर सकते हैं. जैसे स्मार्ट सेंसर हो गया. स्मार्ट सेंसर के थ्रू हम पूरे एग्रीकल्चर की निगरानी कर सकते हैं. इससे हमारे काम को भी आसानी होगी और एग्रीकल्चर को भी बहुत फायदा होगा. जैसे कि इसके अलावा वी कैन गो फॉर हाइड्रोपोनिक्स टेक्निक ऑल्सो. इन दिस the crops are grown in nutrient rich water solution instead of soil. Such innovation will also help for a better agriculture. We can go for organic farming, that we will use less amount of chemicals to do the farm for a better future and for a better agriculture. Now many people think Now, many people think that why to do the sustainable thing for agriculture, but I will tell you that in nature, all living beings are dependent or independent on nature only. As आप लोग many people think that we can eat a meat and or egg or we can eat chicken and we can live our life. But I will tell you कि आप लोगों ने कभी सोचा है जो 10 किलो की मीट या 10 किलो का मीट हम खाते हैं तो जो 10 किलो की बकरी वो हमें मीट प्रोवाइड करती है उसको भी कहीं ना कहीं 10 किलो की ग्रास की नीड होगी अगर उसको उसकी नीड पूरी नहीं होगी तो क्या वो हमारी नीड पूरी कर सकेगी indirectly I want to say that everyone is dependent on nature only like we human beings or animals anyone is there that dependent on nature only so as we move forward with the conclusion of this the agriculture innovation aware and education plays an important role in this if people are not aware of sustainable agriculture, they cannot implement them effectively. Therefore, it's crucial to educate farmers about a new agriculture technique. Additionally, I can say one more thing also the patience because in today's fast-paced world, we accept instant results, however, for everything. But however, sustainable agriculture and innovation take time to show their full impact fully. By staying patient, we can achieve long-term agriculture and a sustainable agriculture. So I would also like to say that with the end of this topic that support agriculture system and support a sustainable agriculture and save our environment and save our agriculture. I would like to end my topic here only. Thank you.
Hello.
Yes, sir.
What is your output behind to present this work or this sustainable development in agriculture?
The main output is like that nowadays we can't use we can use the for innovation like we can use precision agriculture in that drones and the AI system is going on. So with the help of drones and GPS we can make our agriculture more better. इन farms में अगर drones लगाए दिए जाए तो हमें किस जगह पे कब कौन सी नीड हो वो हमें इंस्टेंट और जल्दी पता चलेगा.
Okay, thank you.
Welcome, sir.
Next participant.
Amit Kumar Behra.
Am I audible?
Yes, you.
Behra.
Sir, is my screen visible?
Yes.
It is visible.
Please.
Okay. So, good morning, everyone. The topic for my presentation is degradation of rhodamine blue dye using biochar and synthesized Zedano biochar photocatalyst to study the synergistic effect of photocatalysis and adsorption. So, the presentation plan is as follows. Basically, it starts with abstract, then followed by introduction, materials and experimental procedure, results and discussion, outcomes and work to be done. So this is the abstract. So now coming to introduction. So basically, due to industrialization and urbanization, large amount of synthetic dyes like rhodamine blue are dispersed into wastewater, which leads to many carcinogenic diseases, which affects many aquatic animals and human beings. So, in order to eradicate this dyes from wastewater, many traditional methods have been used. However, adsorption and photocatalysis are cost efficient and environment friendly compared to other methods. So that's why the topic of interest is adsorption along with photocatalyst. So that's why I have chosen a waste biomaterial that is Pulanga seed biochar
which is the byproduct of pyrolysis of Pulong acid. Using that biochar, I have used it as an adsorbent and photocatalyst. So these are my materials and methods. And these are some of the characterization techniques. So basically, Pulonga seeds were used for pyrolysis. So biochar was used. Biochar was produced at the end of the pyrolysis procedure, and it was a byproduct. So that biochar was further modified by sonication in nitric acid. Further, it was stirred at reflux conditions, and further by using co-precipitation method, its surface activation has been done, and finally it was heated in hot air oven, and Zedano zinc nitrate was zinc nitrate was absorbed onto Pulong acid biochar. So in order to produce Zedano Pulong acid biochar. So generally in the Zedano Pulong acid biochar, which is used as a photocatalyst, the photodegradation process of rhodamine blue dye was performed in a batch reactor, where the photodegradation reaction took place under the sunlight, and after degradation it was studied for parametric studied and other kinetics and thermodynamic study. So after photodegradation, the samples were sent for UV spectrophotometer analysis to find out the concentration of the rhodamine blue dye. So the biochar that was obtained and the Jadano biochar that was modified, the XRD patterns are these. Generally, the Jadano Pulong acid biochar that was modified showed a crystalline pattern, whereas showed certain crystalline peaks, and whereas the unmodified Pulong acid biochar did not show any crystalline peaks. So due to which we can say that Jadano PSB can be utilized as a better photocatalyst. Also from the same analysis, we can see that Pulong acid biochar can be used as a good adsorbent due to the pores present, and also Zedano Pulong acid biochar that was modified. We can also use Zedano Pulong acid biochar as a good photocatalyst. So when DRS was performed for Pulong acid Zedano PSB, so Zedano Pulong acid biochar obtained higher absorbance in the visible light range, whereas Pulong acid biochar did not show any observance in the in visible light range. So, however, the band gap of after modification, the band gap of Zedano Pulong acid biochar was reduced to 3.1 electron volt, and Pulong acid biochar was nearly 3.4 electron volt. So when BET analysis was performed, so both Pulong acid biochar and Zedano Pulong acid biochar showed type 4 adsorption isotherm, which tells us that they belong to mesoporous structure, which can be used as a good adsorbent and photocatalyst. So when parametric study was performed by using both Zedano Pulong acid biochar and Pulong acid biochar, more degradation was obtained for rhodamine blue dye using Zedano Pulong acid biochar compared to Pulong acid biochar. Similarly, when the effect of photocatalyst was studied, more degradation was obtained using ZNO pulling acid biochar compared to pulling acid biochar. Similarly, more degradation was obtained using pulling acid biochar compared to pulling acid biochar when contact time was varied. So I can, so these are some of the outcomes that, so 99% rhodamine blue degradation was achieved using ZNO pulling acid biochar at different, optimal conditions, that is at contact time, pH and catalyst dose, whereas only 63% removal of rhodamine blue was obtained using pulling acid biochar. And the surface area of ZNO pulling acid was also more compared to pulling acid biochar. These are some of my references. Thank you.
Madam, any question?
Yes, yes. You have compared, that is the ZNO, not ZNO, that is the ZNO pollen acid and that of the only the pollen acid. Why not you have compared it with the zinc oxide? Because whatever you have shown, that is the XRD, it is just like that of the nanoparticles of the zinc oxides. So
Okay.
my
That
suggestion
part
is also
also
that
just now I have done, ma'am. That I'll incorporate. Means its characterization results I have obtained, but I have not yet added in the. So I'll compare with ZNO also.
okay. So that is also important here.
Yes, ma'am.
My question is that you have studied the degradation of rhodamine B dye.
Yes, sir.
Have you studied any other dyes degradation with this photocatalyst?
No, sir. So I'm in. Sir, I'll do that part also, sir. So.
Okay. Okay. It can be used at a macro level.
Pardon, sir?
Can this process can be used at a large scalar dye degradation?
No, no, sir. I don't think it can be used.
Okay. Okay.
Cannot scale it.
Thank you.
Okay.
Excuse me, sir, I have a question.
Okay, ma'am.
Sir, I want to know about the mechanism behind the photo degradation. A little bit explain, please.
Pardon, ma'am?
Degradation
Madam,
mechanism.
I have not yet found out. Generally, whatever the electrons and holes that are produced from electron band and valence band,
okay, sir,
they will act as oxidizing agent, reducing agent. Based on that, I have to frame the mechanism.
Okay, sir.
Basically, it is taking place in visible light or sunlight. So that.
Okay, sir. Thank you.
Thank you.
Next participant.
Next.
Miss Archana Borde.
Yes, sir. Sir, am I audible?
Yes, yes, clearly audible.
Is my screen visible?
Yes. Proceed.
Good morning to one and all. I am Dr. Archana Borde from Shri Shivaji Science College, Amravati. The topic of my presentation is AC conductivity and dielectric properties of peroxide type LaMNO3 nanobase LaMNO3 synthesized by soldier citrate method. The contents of my presentation are extract, introduction, method of synthesis, result and discussion, conclusion. In the extract, as you can see, the peroxide type nanocrystalline LaMNO3 was prepared by soldier citrate method. The nanoparticles were then characterized by XRD and TEM, and the AC conductivity and the dielectric properties of these nanoparticles was studied from room temperature to 700 degrees 700 degrees centigrade in the range of 42 to 50 kilohertz. Introduction. As you all know that the nanoscale metal oxide are of great interest due to their several applications such as electrode in lithium-ion batteries, in photocatalysis, in higher density data storage recording. As far as nanomaterials are concerned, aluminum-3 thick film is one of the candidates which has been attracting due to its numerous interesting properties such as photovoltaic, photocatalytic activity, gas sensors, etc. Material synthesis. The flowchart shows the material synthesis. Taken lanthanum nitrate, manganese nitrate, and citric acid were dissolved in ethylene glycol, and the mixture was then stirred on a magnetic stirrer at 80 degrees Celsius for 3 hours, which gave a homogeneous and transparent solution. This solution was then further heated at 130 degrees for 12 hours. During this reaction, the transparent solution was transferred into a gel with a very high viscosity. The material was then heated again in a muffled furnace at 350 degrees Celsius for 3 hours and so as to obtain a loose powder. This powder was then mined into a fine powder. And in order to improve the crystallinity of the material, the dried powder was then calcined in the range of 450 to 750 degrees Celsius for 6 hours. Result and discussion. In order to investigate the various properties of the prepared sample, we have studied the structural and electrical characterization. To study the phase and crystal structure of the prepared sample, X-ray diffraction technique was employed. The figure shows the XRD pattern of LaMNO3 calcinide at 550 degrees Celsius. The phase formation of the synthesized sample by sol gel method calcinide at 500 degrees Celsius was confined by the X-ray diffraction study. The intensity data was also collected at a range of 10 to 70 degrees Celsius, and the XRD measurement shows the peak of LaMNO3 were considered with the LaMNO3 JCPDS data having a orthorhombic structure. As you can see in the figure, the main characteristic reflex are located at twice theta at 23 degrees Celsius, 32, 40.2, 70, 52.6, 58, 68, which are being indexed to 012, 110, 202, 024, 122, 214, and 208 diffraction peaks respectively. Using this XRD data, it was possible to estimate the crystalline size of the material. And for this, we have used the Scherrer equation. And the crystalline size of the sample was found to be in the range of 21 nanometer. The second slide shows the transmission electron analysis. The transmission electron analysis was used to evaluate the nanostructure of the sample. The figure shows the TEM image of LaMNO3 calcinide at 550 degrees Celsius. And this image revealed that the probe consists of the spherical particles whose average size was 21 nanometer, which was in close agreement with that obtained from the Scherrer formula based on the XRD pattern. Now, we have studied the electrical characterization, and electrical characterization, we have studied the dielectric properties. To study the dielectric properties, the prepared sample was first mined into a thick powder was made, and we have added polyvinyl alcohol as a binder, and we have pressed it in a pellet to form a pellet, and after removing the radius and the thickness of the pellet, we have made a silver coating on both the sides of the pellet, leading to a transparent parallel plate capacitor structure. and the dielectric measurement of the nanocomposite material was performed by holding this pallet between the two electrodes made of brass over a wide range of temperature from room temperature to 700 degrees centigrade and a frequency range of 42 hertz to 500 kilohertz using an LCR meter. And we have calculated the dielectric constant, dielectric loss, and the tangent loss by using the formula that are on the screen. After that, I have we have plotted a graph of frequency and temperature dependent of dielectric constant, and the second graph of frequency and temperature dependence of dielectric loss. The first graph, that is the frequency and temperature dependent of dielectric constant, was analyzed using this complex permittivity analysis, and the response of dielectric constant at different temperature, as shown in the figure, shows that on decreasing the frequency, the applied AC signals of the corresponding values of the dielectric constant increases, and the dielectric constant further increases on rising the sample temperature up to 700 degrees centigrade. And it was also noted that there is a temperature dispersion in the dielectric constant, and it was found to be larger in the low frequency region as compared to that of the higher frequency region. The second graph shows the frequency and temperature dependence of the dielectric loss. The frequency difference of the dielectric loss at different temperature shows that it varies monotonously, and no clear relaxation peak, as you can see, is not observed in the measured frequency range. After that, we have studied the conductivity. To study the AC conductivity was carried out to get a better understanding of the frequency dependence of this electrical transport properties on the material. And we have used the formula to find out the electrical conductivity, that is sigma AC is equal to omega epsilon R into epsilon delta, epsilon 0 into 10 of your delta, the 10 delta is the tangent loss. And we have seen from the figure, the increasing trend of sigma AC with rise in frequency, it may be attributed to the disordering of the cations between neighboring site and the presence of the space charge, and the dispersion is narrowed at high frequency. In the second graph, we have plotted the Arrhenius plot of AC conductivity of LaMNO3 at various frequency. And it was observed that the sigma AC increases with increasing temperature, further confirming that it is the negative temperature coefficient of resistance behavior. Conclusion. This synthesized LaMNO3 particles using the sol gel citrate method was characterized by transmission electron microscopy and X-ray technique. The structural characterization shows that the prepared particles have a peroxide type orthorhombic crystal structure with an average size of 21 nanometer, which was in close agreement with the estimated by the Sharad formula based on the XR detector. Sample showed dielectric relaxation, which was found to be non-dy type, and relaxation frequencies shifted to the higher side with the increase of temperature. Also, the conductivity study shows that the sample had a negative temperature coefficient of resistance, and the frequency dependence of AC conductivity at different temperature indicate that the process is thermally activated process. Thank you, sir. Hello.
Madam, any question?
Yes, where you use this particular material, or please comment on the application part of this.
I have applied this for using the gas sensors. I have taken a dopant. I have not given here, but I have doped SR in it in 1103, and I have used it for the application of the gas sensor.
Okay, ma'am. Any other question from the audience?
Madam, one question.
Yes.
You have studied the conductivity property.
Yeah.
What is its practical use in that you have studied the conductivity property of LN LA3 O3?
I have used this conductivity so that it can be used, how the AC conductivity can be used, whether it has an application to find out where it can be applied.
Okay, madam. Thank you.
Thank you.
Next participant. Next participant. Dr. Chetna Rana. Chetna Rana.
Unmute your mic.
Hello. Chetna Rana madam, mic please. Rana madam, unmute your mic please.
Is screen visible, sir?
Yes, you are audible.
The PowerPoint. Good morning, everyone. I am Chetna Rana, and I am going to present my paper here entitled Kinetic Study of the Oxidation Rates of 1-hexanol and cyclohexanol using N-chlorosuccinimide in alkaline medium. Oxidation is a reaction where there's a loss of electron and gain of oxygen or loss of hydrogen. I have carried out oxidation of 1-hexanol and cyclohexanol for using an organic oxidant, that is N-chlorosuccinimide. Oxidation is a very important reaction. It gives several important reactions which are industrially very important. Now in literature, many organic and inorganic oxidants have been used. Now in my work, I have used organic oxidants for the oxidation. Now after the work, I have found out that oxidation sequence of 1-hexanol and cyclohexanol. And to support the reaction mechanism is given. 2-alcohol, that is 1-hexanol and cyclohexanol is used, and organic oxidant, that is N-chlorosuccinimide, is used for the reaction. Now 1-hexanol is used in flavoring material. It is used sometimes it is used in the antiseptics. It is used largely in the perfume and plasticizer industry. In India has a very large manufacturer of perfumes and of deodorant. So these are the chemicals which are generally used in the perfumery industry. Cyclohexanol is also used in a preparation of soaps, dry cleaning agent, and it is used in the plasticizers. The methodology I have used is a chemical kinetics method, and it is a first order kinetic condition. And reaction is regulated after reaction is seized using ice, and then the unreacted oxidant is titrated using iodine, sodium thiosulfate in presence of iodine. Rate of reaction is then found out using slopes of linear plots of log A minus X versus time. And from the Arrhenius plot of log K versus 1 upon time, energy of activation is also determined. We all know that primary alcohol is oxidized to aldehyde, and secondary alcohol is oxidized ketone. The presence of ketone in aldehyde is identified by using 2,4-dinitrophenyl hydrazone test. That is a simple organic chemistry test that we have used for the identification. Now this is the table, this is a main table which shows the result of all the sets. Now over here, this first 6 sets is used where alcohol concentration is kept constant, and NCS, that is N-chlorosuccinamide concentration, is increasing. And in the other half, other 6 sets is carried out where concentration of alcohol has been increased and the concentration of oxidant is kept constant. So it has been observed that this is the rate of reaction. So it has been observed that as the amount of alcohol increases, rate of reaction increases. This graph shows that 1-hexenol has a faster rate of reaction. It is a faster reacting, and then the cyclohexenol. This is the graph shows the rate constant comparison. Now the reaction proceeds by the formation of a complex between active species of oxidant and the alcohol, and then the complex is decomposed to give corresponding aldehyde and the ketone. 1-hexenol, this is the N-chlorosuccinamide. It reacts with the solvent molecule to give succinamide, and then the succinamide then further gives activated complex, and this activated complex reacts with alcohol, and you get the final aldehyde, or the for secondary alcohol it gives a ketone. Now one more parameter is found out, that is the effect of ionic strength. Now, effect of ionic strength is calculated, or it is measured using very, very dilute solution of potassium sulfate for both the alcohols. And it has been found that the rate of oxidation for both the alcohol is independent when it is plotted. Log K is plotted against under root of mu. So these both lines are parallel to each other. It is parallel to x-axis. So it proves that ionic strength it is independent on the rate of oxidation. The other important work is carried out is the thermodynamic activation parameters we have calculated at different temperature. So all the other reactions are carried out at room temperature, and these reactions, this oxidation process are carried out at different temperature. Temperature of 303, then increasing temperature 308, 3013, and 3018. That is 35 degree, 40 degree, up to 45 degrees we have carried out. And rate is found to be increased for 1-hexenol, and it is found to be increased for cyclohexenol. So using Arrhenius plot, we have found out energy of activation, and all the thermodynamic other parameters and entropy, free energy change, enthalpy, and all these parameters have been calculated. The inference drawn from the work is that for both the alcohols, oxidation rate increases with increase in the alcohol concentration, and it is decreases with decrease in oxidant concentration. Ionic strength has no effect on the oxidation rate of alcohol, and oxidation of alcohol is accompanied by the decrease in entropy of the activation. Now, the sequence has found out that primary alcohol, 1-hexenol, is more susceptible to reaction. It reacts faster, and it is more reactive than the cyclohexenol. These are the few references. Thank you.
Thank you. Hello. Krupa Kushniega. Video on the
Hello.
माझे टॉपिकचं नाव आणि तिच्या पीपीटीचं नाव पण अमरावती पीपीटी आहे. कळत होतं एवढं.
Hello, madam, any question?
Sir. No, sir.
Okay, thank you.
Next.
Next participant is Monali Pai. Next participant is Monali Pai.
Am I audible to you, sir?
Yes, yes. Continue. Please share your screen.
Good morning, everyone. First of all, thank you so much for giving me this opportunity to present my
Please
work in front of you.
Please share your screen.
Zoom open. Is screen visible, sir?
No, it is uploading. Yes, yes. Now it is visible.
Okay.
Please continue.
Good morning, everyone. First of all, thank you so much for giving me this opportunity to present my work in front of you. I am Monali Arvind Bari, going to present my topic, that is vinegar, environmentally benign and efficient catalyst for acetylation of aromatic amines. Now, first introduction part, acetylation reaction is the very important reaction, and it has industrially important applications like in the protection of amino group, which used for the synthesis of proteins as well as in the amino acid sequences. Now, in acetylation reaction or acetylation of amines, in which acetyl group, that is CH3CO group, is added to a nitrogen atom of amine molecule, essentially replacing one or more hydrogen atoms attached to nitrogen with acetyl group. Now, this reaction typically involves use of reagents like acetyl chloride or acetic anhydride with the amine compound. But in my work, I have used acetic anhydride as an acetylating reagent. Reaction and mechanism for the reaction, like aniline, when reacts with acetic anhydride in presence of acidic catalyst like vinegar, it forms acetanilide with the removal of acetic acid. Now here the mechanism for this reaction. So first, lone pair of oxygen abstract this H plus proton and it forms OH plus group. Then lone pair of nitrogen attacks on electron deficient carbonyl carbon, and after that we get the acetanilide as a product. Now, applications of acetylation. Acetylation is primarily used in organic synthesis as a protective group for amino functionalities. Okay. Now, here, if it is used as protecting group in the synthesis, now if we want glycine alanine sequence, then first we have to protect the NH2 group of glycine. So, this NH2 group will not interfere with the alanine NH2 group. So we get the correct sequence of glycine alanine amino acid sequence. Also, it can be of amines, whether it is primary amines or tertiary amines. Now, different acetylating reagents were used like acetic anhydride, acetyl chloride, or ketene. Here in my work, I have used acetic anhydride as an acetylating reagent. Now, vinegar in acetylation, which is a green approach, and we have used vinegar as a catalyst, which is environmentally benign and efficient catalyst for the acetylation of aromatic amines. It requires lesser time for the formation of product because conventional method requires heating and it takes some time to formation for the formation of product. So reaction takes place at room temperature. Vinegar is typically 4 to 6% acetic acid by volume, but the amount can vary depending on the type of vinegar. Vinegar is made by fermenting simple sugars into ethanol and then fermenting the ethanol into acetic acid. Material used and methodology for the formation of or for the reaction of acetylation. So here we mixed aromatic amine and vinegar in a beaker and then add acetic anhydride to it with constant stirring. So at room temperature, we get the acetylated product in presence of active weak water soluble catalyst like vinegar. Now here I have performed some acetylation reactions of aromatic amines. The product and their percentage yield as well as their melting points are given. I have used aniline, orthonitroaniline, metanitroaniline, paranitroaniline, paratoluidine, alpha-naphthylamine, parachloroaniline, and parabromoaniline. Here, their product formation, structures, and percentage yield as well as their melting points are given. Now conclusion, so we have developed a convenient and general method for the acetylation of amines in absence of solvent. Now experimental conditions were milder and the reactions were completed in shorter reaction times and at room temperature. So by using vinegar as a catalyst, we can do the reaction at room temperature and under solvent-free conditions. So this is the greener approach for the acetylation reactions. These are the references which I have referred for this project work. Now I would like to thank my principal, Professor Dr. P.K. Gogare sir from NB Mehta Science College Body. I also would like to thank my HOD, Dr. Anti Nirgude sir. I would like to give my special thanks to my teacher, Dr. Mrs. Chetna Rana, who helped me out to finalize my work in short time of span. Also would like to thank Ajay Patil sir, who is the senior clerk from NB Mehta Science College Bordi, who has helped to make out the presentation nicely. Thank you.
Okay, what's new in this particular work? Because there is a use of that is dilute acetic acid, I can say, that is the vinegar. Okay,
Yes.
and it's the regular practice to use the acetic acid. And again, during conclusion, you said that it is the solvent free. How you can say that?
In a conventional method, we use glacial acetic acid and it requires heating.
But whenever, suppose if you are using the aromatic amines,
yes, ma'am.
Then what about the solubility and other issues?
We get the final product, madam.
And you are using the acetylating agent, that is the acetic anhydride.
Yes, ma'am.
Whenever you are using the vinegar as a catalyst, and what about the acetic anhydride? That is, it's the anhydride. Whenever it gets the medium, that is aqueous medium. What happens with the acetic anhydride?
But we get the product because in high yield. I have performed this in our laboratory.
No, madam is asking why you are using this. This is a conventional metal because we are using acetic anhydride and
Yes.
acetic acid. It is conventional method. But
Yes, I only replaced glacial
conclusion?
acetic acid instead of glacial acetic acid. I have used vinegar here.
How it is an environment friendly then?
So, hello.
Hello. How are you? Hello.
Hello.
Please.
Sir, vinegar we can use as a dilute solutions of acetic acid.
Okay. Any other question, madam?
No, sir. Next.
Next.
Okay, thank you, sir.
Next participant, Pratik Ganguly. Pratik Gamburi.
किसी में बाल जाते हैं लेकिन बहुत ज्यादा नहीं जाते अभी। मुंह का भी कैसे।
Yeah, hello, sir. Is it visible screen?
Yes, continue.
Good morning to everyone. I'm Pratik Gangurde. I'm doing my master's at Department of Chemistry, Savitribai Phule Pune University. Today, I'm going to present my work that is dual mode of detection of iron using carbon dots conjugated ratiometric and colorimetric sensors. Significance of my study is application in iron sensing, environmental monitoring, that is detection of iron in water to assess pollution levels. Biomedical application, that is monitoring iron sensing, is crucial for diagnosing conditions like anemia or hematochromatosis. Industrial application, that is quality control in process where iron concentration need to be regulated. So first, what is carbon dot? Carbon dot is a carbon-based nanoparticles having the 10 nanometer in size and exhibit fluorescence properties. It is primarily composed of oxygen, nitrogen, and hydrogen often present on their surface. So we have synthesized carbon dust via hydrothermal method by using terephthalic acid and orthophenylene diamine as a precursors using 25 ml of water transferred in autoclave at 180 degrees Celsius for 8 hours and resultant carbon dot is synthesized. When it is checked in the UV chamber, it shows yellow emissive in nature and the same carbon dot is functionalized via ADC-NHS method and using 2-amino terephthalic acid as a monomer for 4 hours. And the resultant modified carbon dot is synthesized. And the modified carbon dot is characterized by using different methods like UV visible spectra, fluorescence spectra, XRD, and TEM images. In UV visible spectra, we can see that the notable changes is the shift is observed due to the two ATA conjugations where when it compare with the carbon dots. In fluorescence spectra, we can see the first peak of the carbon dot is and second for the 2-amino terephthalic acid, and when it checked the surface modified carbon dot, it was shows the ratiometric peaks. In FTIR spectra, it shows the notable changes in the ADC NHS, that is modified carbon dots, due to the introduction of functional group. The TEM images was shows that the 7 nanometer particle size of the carbon dots, and this is the XRD image. The iron sensing was done with the help of this modified carbon dots. It was shown that the concentration-based study that fluorescence intensity is decreased with a shift at 442 nanometers and Fe3 ion concentration with increases. The concentration-dependent behavior indicated that fluorescence intensity is inversely proportional to ion concentration. Also, it was shows that the colorimetric changes when it changes the concentration. The conclusion of this study is novel ratiometric sensor based on yellow emissive carbon dots conjugated with blue emissive 2-amino terephthalic acid were developed. The covalent conjugation is achieved through carbonimide bond formation. The surface functionalized carbon dots were evaluated for detection ion. Ion shows colorimetric changes and shift in the peak with increase in concentration. These are some of the references. Thank you.
What are the applications of this carbon dots? Have you used?
Yes, ma'am, for sensing. Hello.
Any other question?
No. From the audience?
Audience? What is this ratiometric method?
Where two peaks are observed.
In which what method it is? Ratiometric.
Ratiometric, like
It is based on UV visible or which technique?
with the help of fluorescence, like spectrophlorometer we have used.
Okay. With the help of fluorescence, ratiometric methods you are using to detect
Yes, sir.
to detect what?
Iron.
Iron. Okay.
Yes. Iron in plus 3 oxidation state.
Okay. Thank you.
Okay, thank you, sir.
Next participant, Rahul Ting. Next participant, Rahul Ting.
Sir, he's not responding, so please take the next.
Next is Satendra Sontakki. Next participant, Satendra Sontakki. Satendra Sontakki.
Yeah. Am I audible, sir?
Yes. You are audible. Please share the screen.
Sir, बंद हो सर तो ये शेयरिंग आने के बाद मेरा हाँ डेस्कटॉप पे है ओपन करूँ हाँ नहीं पीपीटी ओपन करूँ
Yes, continue.
Sir, is it visible?
Yes.
Elections, free and fair elections and peaceful elections. And I believe
Technical assistant, please mute this. Anurag Pandey, please mute yourself. Satendra Sontakke. Hello. Satendra Sontakke, you are there? Shikha Mishra is there?
Sir, am I audible?
Yes, you are audible.
Okay.
Please share the screen. Screen is not shared.
Is it okay, sir?
It is
PPT.
PPT is not visible.
PPT not. एक minute, just minute.
Yes, yes, yes. Yes, now it is sharing. No. What you have done earlier, that is visible. Screen is visible there.
Earlier. PPT नहीं दिखा नहीं व्हॉट्सअपला शेअर करून त्याच्याकडे ऑलरेडी आहे तशी करा म्हणून
याच्या अगोदर सर काय केलं होतं तेव्हा शेअर झाली होती स्क्रीन.
स्क्रीन झाली होती का सर? एक मिनिट.
याच्या अगोदर जी प्रोसेस केली होती ती करा.
अच्छा अच्छा आधी आता हे कॅन्सल करता येईल. स्क्रीन आता शेअर.
Yes, yes. Yes. No. ती प्रोसेस कंटिन्यू करा आता जी
हाँ
केली.
सर आता शेअर होत आहे.
Yes, yes.
PPT PPT हाँ
Continue.
Okay sir, thank you. My topic of presentation is biocidal properties of copolymer derived from sulfonilic acid, semicarbazide, and formaldehyde. Myself Satyendra Sontakke and my supervisor is Dr. W.B. Gurnule. Sir, as my content, introductions, review of literature, objective of work, methodology, result and discussion, and references. All of us are very well known about the polymers. Polymers are nothing but these are the macromolecules which are formed by the repetitive linking of small units, that's called monomer. All of us are very well known the application of polymers. It has a various application in the different field, and therefore, uh, I review the literatures. From the literatures, I come to the point that such type of copolymers has been not synthesized earlier by using the monomers that I have selected here. My objective of work to synthesize sulfonilic acid semicarbazide formaldehyde copolymer by condensation techniques using different monomers ratio. In polymeric composite, have to prepare using the activated charcoals and synthesized copolymers. Synthesized copolymer was characterized by physicochemical, elemental, spectral studies, SEM and TGA analysis. Synthesized copolymer and their composite have been subjected to thermal, antimicrobials, and photoluminescence study. I use the methodology condensation methods in which sulfonilic acids, semicarbazide, and formaldehydes. It is in different ratio 1:1:2, 2:1:3, 3:1:5, 4:1:7 ratios. For that case, reflux for about the 5 hours at about 120 degrees Celsius using 1 molar HCl as a catalyst, and it is about 5 hours. Then it is kept overnight. Then brown color copolymer was obtained. It was filtered, washed with waters, methanol, and acetone. Whatever the unreacted monomers that has been removed by using the techniques, then dried in air, that copolymers are obtained. Reaction route of this SAF copolymer, sulfonilic acid, semicarbazide, formaldehyde. For that case, this is sulfonilic acid, semicarbazide, and formaldehyde. That SASF copolymer has been obtained in good yield. Result and discussion. Elemental analysis observe that SAF, that is empirical formula weight C13 S22 S12 N9O2S. Empirical formula weight is found to be 359, and that calculated and found percentage of each carbon, hydrogen, and nitrogen and sulfur is like this. Then conductometric titrations that was used for the polymers. It is observed that conductance is increases with respect to the change in that is with respect to the percentage of polymer. Then FTI spectra. In IR spectroscopy, different stretching frequency that observed, that is NH stretching at about 3465 centimeter inverse. That expected frequency that we all know about that. NH bending frequency that is about 1754, and CS stretching frequency 2854, and CS2 stretching frequency that is 3078 centimeter inverse. From that means that is using this FTIR techniques, we are trying to characterize that uh, polymers that we have synthesized. Then same technique is used for the surface morphology of the polymer, can be used can be studied by using this scanning electron microscopy. It is just in like this. Then thermochromatic analysis, it is used for the thermostability of polymers, can be analyzed using these TGA techniques, and it is observed that at about 200 to 390 degrees Celsius, that's one sharp peak is observed at that case, and at about 390 to 535 degree elimination of NH and CS2 group, percent weight loss at different temperature that is accommodated like this, that is 1.88 100 degrees Celsius at about 200 degrees Celsius, percent weight loss is about 3.96, and at 300 degrees Celsius it is about 43 weight loss of polymer has been found, and at 400 57%, then at 500 63%, and at about 600 almost 78% polymers copolymer has been uh, lost. Weight loss is observed in case of this TGA techniques of the copolymer. uh, Conclusion: SASF copolymer were synthesized with good yield. Copolymer was characterized on the basis of various analytical, spectral, morphological study, which characterize the structure of copolymers, and it has a biocidal property. It has good biocidal property, and thermostability of copolymer is very high. And these are the references of my topic related to that biocidal study of my copolymers. Thank you, sir.
Madam, question?
Okay, have you, that is, what about the mass of this particular copolymer? Average mass?
Average mass, it is
Yes.
calculated this
Hello. Any other question? Chalo, next.
Next participant is Shikha Mishra. Shikha Mishra. next participant, Ms. Shikha Mishra.
She is there, Shikha Mishra. Shikha Mishra is there.
Not responding.
Yes,
Yes,
yes.
she is there.
Okay. Okay. Please unmute yourself. Miss Shikha, you are not audible. Hello. Miss Shikha, you are not audible. Organizer, please convey the message.
Yes, sir. Am I audible, sir?
Yes, yes, you are audible. Please continue.
I am Shireen Shukla, sir.
Hello.
Hello, sir. I am the next candidate, Shireen Shukla. Shall I start my presentation?
Yes, yes, Shireen Shukla, you may continue.
Okay, sir. I hope my screen is visible, sir.
Yes, yes, you continue.
A very pleasant morning to everyone, all the dignitaries and the fellow online mates. I'm here to present my work in the international conference. My name is Shireen Shukla and my topic is graphene oxide and growing exigency. My guide is Dr. Meet Kamal and we are from Department of Chemistry, Christ Church College, Kanpur. Before starting with the topic that is graphene oxide and its growing exigency, I would like to introduce you to the world of graphene oxide. Graphene oxide is basically nothing else. It is an polymorph of carbon. It is purely made up of carbon. It does not have any other significant elements. It has oxygen and hydrogen in different bonding. So if you imagine graphite as a notebook, then graphene is like a single page of that notebook. Single one layer structure is graphene. And if it gets connected, it makes bonds with the, as you may see, oxygen, it makes hydroxy bonds, it makes epoxy bond, carboxylic bonds, then it is known as graphene oxide. So what is the importance of graphene oxide? The properties make it very useful and it is a futuristic material because as we are heading towards the digital world, we are using the laptops, we are using the touch screens and everything. Graphene oxide or graphene are the materials which are very, very common in these devices. They are very cheap. Graphene oxide is a cheap alternative for graphene. Graphene, as you, if anybody knows, then it is a very expensive material. Next property, that is hydrophilic in nature, means due to the presence of hydrogen bonding, graphene oxide can be soluble in water. And non-stoichiometric chemical composition means if, for example, carbon is 50%, oxygen is 50%, then the properties are different. But if the degree of oxidation varies, then the properties of graphene oxide can also vary. So the properties can be altered according to the use of the required use. Next in line, we have synthesis procedure. So graphene oxide, due to its oxidation, it is synthesized by an oxidation method known as Hammer's method, in which we use sodium nitrate, potassium permanganate, and HCl. Due to the fumes coming out of the method, the nitrate fumes, and the H2SO fumes, so that is why it was modified, and it is known as a modified Hammer's method, where we do not use NaNO3 we use some other milder acid or milder oxidizing agent. Applications, due to its phenomenal properties of electrical, mechanical, and optical properties, it is used in various fields. Biomedical, due to its because it is a very it is a carbon-based material. It is it may say it is friendly for the human body, so it can be used in the biomedical engineering for example, drug delivery, tissue engineering. Jahan pe bhi we need some material that can go inside the human body. Graphene oxide is a very promising material for that. Next, we have optoelectrical.
Punjab National Bank.
Optoelectrical, because we are seeing that graphene oxide has very much UV visible absorptions and reflectance. It can be used in solar energy harvesting plants. It can be used in energy storing devices and also in display materials. Next, we have electrical. It can be used for carbon dioxide absorption, semiconductors, and since we are moving towards a pollution-free environment, we are continuously working for pollution-free environment. It can also be used for removal of contaminants from water bodies. Next, we have future scope. Since graphene oxide is a very promising material and it helps us in various fields, it should be studied more, or graphene oxide can be used as an alternative, as a cheaper alternative for graphene. And for digital world, it is a very promising material. That's it. That's all for my presentation. These are the references, and thank you, everyone. Thank you.
Madam, question? Have you used this graphene oxide in optoelectrical properties? Have you any specified example?
Sir, this is a review article, but I have studied from the papers. Since it is a UV visible active material, it can be used as sensors, optoelectrical. Jahan pe where you can use light as a reference. If the light is there, then the sensor is working. If the light is shut, the sensor will not work. So it is basically a review, and I'm also working on graphene oxide in my PhD.
You are reviewing the graphene oxides applications and synthesis.
Yes, sir. Yes,
okay. Sir. What is about the photocatalyst property of graphene oxide? Have you go through the different reactions in which it is used as a photocatalyst?
I have not read much deeper into it, but since again it is a very like you can say it is reactive due to the oxygen bonding and oxygen and hydrogen and carboxylic acid bonding, it can be used as a catalyst under photomeans under the light reactions. That's all I have studied, sir.
Okay, okay. Thank you.
Thank you so much, sir.
Next.
Next participant. Jagan Singh. Shubhashri Jagan Singh.
Yes, sir. Yes, sir. Good morning, sir. Just give me a second. Sir, is it audible and visible also?
Yes, yes. Audible and visible.
Yes, sir. Yes, thank you, sir. Myself, Subhashri Jaganseni. I am a research scholar from GIT University. The title of my topic is Assessment of Genotoxic Potential of Carbendazim on Channa punctatus using micronucleus assay. This work is supervised by Dr. Y. Aparna and co-supervised by Dr. Satyanarayan Sahu. So, this will be the sequence of my presentation. This is the abstract. So, first I would like to explain the genotoxicity term. This term specifically refers to ability of certain agents to cause damage to the genetic material like DNA in the living organism. So that damage can be mutational or chromosomal abnormality or ultimately cancer or other diseases. So this genotoxicity can be classified into two types, or this type of damage can be classified to two types. That
Madam,
is,
madam. Subhashri, madam. Your
yes, sir.
screen is disappeared. Okay. Now
Sir, is
it
it
is
visible now?
Yes, yes. Now it is visible.
Okay, sir. Thank you. So this genotoxicity is classified to two types. One is mutagenicity, another one is clastogenicity. So generally mutagenicity refers to the changes in DNA and clastogenicity refers to any type of breakage or rearrangement in DNA. So there are different agents which can different categories of genotoxins, carcinogens or mutagens or teratogens. So there are different agents depending upon the type of damage or intensity of damage. The genotoxins can be classified into chemical agent, physical agent, and biological agent. These are some of type of classifications that I have given. So there are different tests through which we can calculate the genotoxicity. So one is AMIS test, next one is micronucleus assay and comet assay. So my research or my work is specifically on micronucleus assay. First, I would like to explain what is micronucleus. So the micronucleus or micronuclei are the sign of the action of some antigens or some broke part of the chromosome originated from the chromosome which fails to attach to the mitotic spindle during cell division. So in micronucleus assay, generally the assay is recognized as the most successful and reliable assay for genotoxic carcinogens or to find out the level of genotoxicity of different type of chemicals. So here my objective is to evaluate the genotoxicity of three different concentration of carbendazim in a specific fish called Channa punctatus, and I have studied the toxicity by making blood smear slides after 24 hours, 48 hours, and 72 hours of exposure of the specimen to the chemical. So generally, this is the Channa punctatus, the fish experimental specimen. But here I have used carbendazim as a test chemical. Carbendazim is a commonly used fungicide which is generally used in agriculture. for betterment of plant or to get rid of the different type of fungus which affect the plants. So here I have taken two type of routes. One is dermal exposure, another one is intraperitoneal exposure. So in intraperitoneal exposure, the experimental specimen have been injected with different concentration of the chemical carbendazim, and in dermal exposure, the fishes have been exposed to the laboratory aquaria, and the water of the aquarium is mixed with the chemical which is carbendazim. I have used different concentration in different routes. So after the exposure, the blood smear slides were prepared after 24, 48 and 72 hours of exposure. Micronucleus test has been conducted in this study to find out the level of chromosomal abnormality. So as a result, I find out in comparison to control medium, the appearance of micronucleus increase as I increase the concentration of doses in both intraperitoneal and dermal exposure. And the micronucleus was so significant along with the appearance of micronucleus. Along with the appearance of micronucleus, different type of deformities can be seen in blood, just like binucleated RBC, deformed nucleus, nuclear bird. So here are some of the slides or some of the micronucleus that I have find out during the experiment or during the study. So this is the comparison graph between the micronucleus exposure in comparison to the control medium and comparison to the time of exposure. So in conclusion, I would like to say there is significant increase in micronuclei frequency in fish exposed to carbendazim compared to the control group. And I observed the concentration dependent increase in micronucleated cells and binucleated cells during the exposure to the chemical. It has been highlighted that carbendazim disturbs the genetic balance by blocking cytokinesis of normal cell, which may lead to the carcinogenesis. It is concluded that the sublethal concentration of carbendazim induced genotoxicity in the fish Tana punctatus, which can have serious health implications for humans and other organisms that depend on aquatic ecosystem. So carbendazim showed long-lasting effect as toxicity persisted till the end of the recovery period. So further research is needed to evaluate the long-term effect of this chemical exposure on aquatic ecosystem and to develop effective strategies for the management and regulation. So these are my certain papers. I would like to thank the organizers and for giving me this opportunity to present my work in this prestigious platform. These are my certain references. Thank
you. Which control you have used?
Hello, Subhashri.
Hello.
Yes, sir.
Madam is asking something.
Yes, ma'am. Yes.
Madam, please ask.
Yes. Which control you have used?
Yes, ma'am.
Which control you have used?
Ma'am, control medium. Sorry, ma'am.
Yes, yes.
Ma'am, control medium, I expose the fish in a normal aquarium water first initially. The tap water. That is the control system and without exposure of fish into any chemicals.
Okay.
What is actually genotoxicity?
Sorry, sir.
What is genotoxicity? You have covered the topic genotoxicity. What is genotoxicity? Hello.
Sir, genotoxicity generally refers to damage to the genetic material, which is DNA or the chromosome. The specific, if I explain the specific abnormality, then that to know that specific abnormality, we have to refer to COMET assay. In COMET assay, we can specifically find out the different abnormalities in DNA. But micronucleus assay is the initial step to find out if there is any initial genetic abnormality which can be studied by appearance of small chromosomal fragment, which is micronucleus. So
Okay.
the
And
micronucleus assay is the
it is observed in your study, genotoxicity.
sir, as there is appearance of certain type of micronucleus is there, this refers to the primary appearance of genotoxicity in
Okay.
fishes due to carbonism.
Okay. Thank you.
Yes, sir. Thank you, sir.
Next one.
Next participant.
Swapnil Dhake.
Hello.
Swapnil Dhake.
Sir, next person me, sir, Subhasri Priyadarshini.
Yes. Yes, madam.
Good afternoon, sir. Myself, Subhasri Priyadarshini, and Mujisa Scholar from GIT University. And my guide is Y. Appanna, and co-guide is Satyanarayan Rao. So my topic is, so my slide is visible in your screen, right?
Yes.
Okay. My topic is analysis of microplastic in contaminated Mahanadi and its tributary Kashipiti river water at Kotak city and its effect on fish species by a micronucleus assay and hematological parameter. So basically the point is, what is microplastic? So in our day-to-day life, we are using lot of plastic products, including polythene, including our tiffin, water bottle, everything, including plastic. And we really just dissolve it in the river ecosystem or in environment. So in later stage, when the plastic disposed in the water or in the environment, is slowly the microplastic particles dissolve from it. And the microplastic contain synthetic polymer, polyethylene, polypropylenes, other chemical components. And the component have other characters like combined with other harmful substance present in the environment, and it going to into the organisms present in the water ecosystem. Just like fish is the most important bio indicator or most important ecosystem water ecosystem organism which we consume in our day-to-day life. And specifically, the fish like Labioreita, Catla, Reba crab, which is widely used by humans for their food. They are highly contaminated with microplastic. Like when we try to do the experiment and simply do the evaporation process, we got high amount of microplastics present in Mahanadi and Kathijodi river. So in later stage, when we are started our study, mostly we focused on Reba crab and Catla and Labioreita for our experiment. They indicate what is the level of harm microplastic hampering with them. And not only they are hampering somehow directly or indirectly, we are also hampering by the microplastic pressure. It affects their endocrine health, their brain management, and other body organs like liver, gallbladder, and other substance. So in first phase, we are try to get some fish from the normal direct condition in river and collect blood from them by a puncture method from the caudal fin region. We collect the blood, and in blood level also we get number of variation in hemoglobin, RBC, and WBC, which is not good for them, and somehow we are consuming them. So we are also hampering our own health. So my objective of the study is to study the degree of microplastic by finding the extent of pollution in water of river Mahanadi and Kathajodi. As Mahanadi and Kathajodi as almost one river, you can say that, because Kathajodi is a tributary river of Mahanadi, which covered the city surrounded the city both the sides. So both the rivers are connected by lot of points, and hematological study as well as micronucleus assay are carried out. So from this study, we got the so harmful and dangerous results. And for our study area, as you say that, I choose Mahanadi and Kathodi river of Kotak city, specifically Kotak city, because it have a lot of industrial area, lot of other drainage system which directly connected to the river. And these are the study outputs, study result, which got some hematological parameter study of Labia rohita. The hemoglobin content, RBC content, WBC, lymphocyte, monocyte, and neutrophil all are in hazardous condition and not in normal condition like a normal Labia rohita fish. And second table shows the hematological parameters of catla fish, which you collect in, again I repeat, in a normal condition from the river. The parameters are not calculated at the lab condition. They are just simply fish are collected from the river ecosystem and blood collected them, and it is the output and it is the result of the microplastic contaminated water. And second, we got lot of micronucleus which are formed due to the abnormal environment and stressful environment in case of organism. If an organism grows through stressful environment, including chemical stress, including heavy metal stress or micronuclear stress, they automatically form a deformation during the cell division. And the deformation is known as micronucleus. And we got number of micronucleus from both Labia and Catla, which indicate that they are going through a stressful condition, going through a highly contaminated environment, which is affecting them and force them to forming the deformation during the cell division, which is not absolutely normal in case of them, which hampering us. So in my conclusion, as we saw the hematological deformation and micronucleus formation in the both the feces and also in other organisms in the ecosystem, it affecting our environment. We are using the plastic for the smooth day-to-day life activity, but somehow we are destroying our future for ourselves also, because nowadays cancer in human being is quite common. Like 100 of the human out of 100 human beings, 80 are suffering from the cancer, majority of cancer. So it causes due to several causes, and microplastic contamination is one of them. We are consuming the water directly, that also affecting them. We are doing our day-to-day activity from the river water, it also affecting them. And secondly, we are consuming fish that is contaminated, completely contaminated with micronucleus and other substance, that is. So day by day, we are leading towards destruction due to fault of us. So it's the end, and thank you, Department of Chemistry, Narsamma Arts, Commerce, and Science College. Thank you for giving us a chance to present here. Thank you so much.
Anybody having question? Hello, anybody is having question? Shubhasri, can you explain the disadvantages of microplastics in other way?
Yes, sir.
Not what is the you can say that disadvantage of microplastic for the environment.
Yes, sir. Yes, sir.
Hello.
Yes, sir.
Yes, yes. What is the effect of microplastic on in the other way on the environment or human beings?
The negative effect, you were asking about negative effects.
Yes, yes, negative effect.
Sir, if you talk about environment, if there is a industry, plastic industry near your area or near your village, they are expanding a rotten gas in your area. The gas not only contain the gas, it also contains the small particles of some microplastic and plastic form, which is going into your nasal and your lungs. Later, you are slowly, or maybe your next generation, slowly developing asthma, skin allergy, and it may be host like some of form of cancer. And in second form, for our use daily and helpful, like a smooth life, we are consuming food in plastic foils, plastic bowls. We are okay with it that we don't have to wash it. But when a hot product, I like water or tea or anything, placed in a plastic container, it releases certain amount of gas which contain polyethylene PE and which you mix with our food, and we're consuming it happily, which later affecting us later affecting us by endocrine disease and other stone like kidney stone and other forms. So slowly it's affecting human being also, sir.
Okay, okay, thank you.
Thank you so much, sir, for the chance.
Okay. Next, Swapnil Dhake.
Yes, sir.
Yes, please share your screen and continue.
Yes, sir. Sir, is my screen visible, sir?
Yes, visible. Continue.
Yes, sir. Good afternoon, sir. Myself, Swapnil Dhake. I am here to present my work related to phytochemistry. The medicinal chemistry is very important aspect of our life. Currently, if we see overall account, near about 70 to 80% of the herbal or another remedies are there which are being employed in India or in other countries also. So I had selected one plant, Carcorus depressus lean, which belongs to the family Tiliaceae. This is my content which is I am presenting today. The abstract. For this study, I have collected the leaves of this Carcorus depressus lean from the Sakri village in the Dhule district. I authenticate it from the botanist, taxonomist, and then dried it and do the further extraction. So this is my overall overview of this work. So introduction, the family Tiliaceae comprises number of genus, of which genus Carcorus is having significant therapeutic importance. Compared to the other species of the Carcorus like Fascicularis and other species, they had been reported for number of activities, biological activities for their compound isolation. So I had selected the Carcorus depressus lean from this genus. So literature review, if you see the previous reported plant, the literature from this same plant, though other parts of these plants have been studied for their phytochemical activity, phytochemicals and biological screening. So they had used whole plant, roots, seeds. So these three are being studied a lot. So leaves have been studied. So I had selected the leaves. Only quercetin has been reported from the leaves. So I had selected the leaves of this plant for my study. Also, with respect to the biological activity, pharmacological activity, Carcorus depressus comprises analgesic, antioxidant, diuretic, and a number of wound healing properties are there, where the tribal area people, they are using the decoction, also the extract of this plant, various parts of this plant. So my objectives of my work, I had selected already. I had done the extraction with two low polarity solvent, PET ether and chloroform. That compounds isolated I had already reported. Now in continuation with that, I had done the extraction of this leaves of this plant with methanol and ethanol solvent and isolation of the way this filter isolation of compounds from this filtrate and structural elucidation. These are my objectives. So this is the methodology what I had followed. I had dried the leaves whatever collected and crush it to the fine powder, and I had used the extraction method, cold maceration. So for this, I had first used the solvent methanol. I had taken near about 2.5 kg of this leaves powder, and I had macerated in this solvent methanol near about 1.5 liter for 3 to 4 days. Throughout the 3 to 4 days, I had done the frequent stirring, and after 3 to 4 days, whatever the extract I had got, I had filtered it, the extract, and after the filtration, I had dried that filtrate on a rotary evaporator, and I got the methanol solvent extract, and that I had loaded on the column chromatography. So the big task was to separate the various phytoconstituents from this column chromatography by using various solvent. So I had done the number of trials. I had able to isolate only one pure compound in the solvent system, methanol as to acetylene, in this ratio 7.5 as to 2.5. That was about near about 50 mg, and that was of white solid. Second, the filtrate cake obtained from this first after methanol that I had next done the ethanol extraction. The same process I had followed. I had the filter the solid whatever obtained from the methanol. I had done subjected for ethanol cold maceration. I had soaked the filter in the ethanol solvent. Sorry, ethanol is there. Ethanol solvent for 3 to 4 days, and after that I had filtered that and done the drying on rotary evaporator. So the filtrate obtained from this was subjected to have more of these polar compounds. So I had loaded it again on the column chromatography, and I tried to separate more the compounds by using the solvent system. So I had tried the combination of polar as well as non-polar solvents. So I could able to isolate the two compounds in the solvent system, PET ether, ethanol, acetic acid, 4s to 4s to 2 ratio. Now about the result, one compound I got from the methanol extract of this carburet depresses lean. The structure of this compound I had isolated. Whatever compound isolated, I had elucidated the structure by using a number of methods, like first CHNS elemental analysis, then the IR, C13 and H1 NMR, and the mass. So these are the spectral data whatever I got. So from the CHN analysis, first I came to know about the empirical formula, and from the IR spectral data and from the mass, I came to know the compound whatever isolated that is found to be stigmasterol by comparing the data, spectral data, with the previous literature. The second solvent ethanol, which gave the two different compounds. So this is the first saturated fatty acid I could able to isolate, which is pentacoxylic acid, which is about 25 carbon species. The structure again I had isolated, whatever compound I had isolated, I had elucidated the structure by using the same four different analysis methods: CHNS, NMR, IR, and LCMS. And this is the third compound, that is the compound isolated from ethanol, the another 17 carbon saturated fatty acid, that is named margaric acid. The compound again I had isolated, whatever isolated, I had elucidated the structure from the H1 NMR spectrum mainly, because it contains only the four peaks, majorly the CS3 and the 2CS2, and remaining are the equivalent intermediate CS2 groups. So with respect to the conclusion, from the isolation, from the extraction of this carburet depresses lean, using the two different solvents, polarity, methanol and ethanol. Methanol, I could able to isolate only one compound, stigmasterol, and from ethanol, I had got the two compounds, pentacasonic acid or quasilic acid is the same, and second heptadiconic acid. Whatever this compound I have got, they had significant biological activity. If you see, I had seen the previous literature regarding these compounds. The stigmasterol had number of activities like anti-cancer, anti-inflammatory activity. The pentacosanic acid has the inhibitory activities for type 1 and type 2 diabetes. And second, the compound I have isolated, that is margaric acid or heptadiconic acid, it is found to be having the antimicrobial and antifungal activity. So this is from my side. Thank you, sir.
Any questions?
That's about the proportion of the methanol acetone.
Ma'am,
And
methanol
is it
and
the
acetone.
yes.
Yes, ma'am. 7.5 as to 2.5 ratio I had isolated in the solvent system, methanol and acetone.
It means it is about 20%. And is it
20%.
compatible with the column silica?
Yes, ma'am.
Because
Hmm.
because after 20%, there may be some dissolution, and so
The
generally,
yield at your guy had got that is less only, but
because generally we avoid the methanol more than 20% when we
madam,
are using the when we are using the silica
yes.
for a chromatography.
But as per the polarity, man, carboxylic acid.
Yes, that's why I'm asking that is whether it was compatible or not at that time. Whatever, what's your observation?
Yes, ma'am. I am able to isolate it, but it was less. The yield was less.
Okay.
Okay, sir.
There is.
Ma'am.
Hello.
Yes.
One question is there.
Yes, sir.
That how you determine the structure of this compound, such a large compound, with the help of NMR, IR, and mass only.
Sir, step by step, I had followed first from the mass. I got the carbon, hydrogen, and nitrogen percentage, and finally from that I had got the empirical formula CHN and OS. From that empirical formula I got the second thing from the mass, the peak, probable peak, whatever I got in the mass, I had compared the mass with that probable empirical formula. And from that I had came to know the compound formula with respect to the empirical and molecular weight. And from that compound I had compared the same mass. And second thing, IR spectrum I had followed. From the IR spectrum, I got the major carboxylic acid or OH functional group stretching frequency.
Okay. And what is the common name for this plant?
For the Bahufali from for India, in India it is named Bahufali.
Bahufali. Okay.
Bahufali. Yes, sir.
Okay. Okay. Thank you. Next participant, Shirbate.
Next participant, Miss Gauri Riskur and Miss Saili Kadge.
Vaishali Shirbate.
Gauri and Saili.
Vaishali Shirbate is there?
Next, Gauri.
Yes, ma'am.
Next participant.
Okay, please.
Gauri is there?
Neeta Shinde.
Yes,
Dr.
yes.
Neeta Shinde.
Okay. Okay.
Gauri.
Share your screen.
Is Gauri going?
Sir, myself, Gauri, and Saili will be presenting together. Yes.
Okay. Okay.
Good
Please
Share
share
your screen.
Yes.
share your screen.
Yes, sir.
Ah.
Can you see the slide, sir?
Yes. Other, please you mute your mic.
Is it visible, sir?
Yes,
we
yes.
audible?
Continue.
Yeah. Okay, so good afternoon, everyone. Myself, Saili, and my co-partner, Gauri, we both will be presenting this presentation. So the topic for our presentation work is GCMS phytochemical profiling of Moringa oleifera and Mucuna pruriens leaf extracts for revealing their antioxidant activity. Going ahead, these are the abstract details and introductory points for our presentations. So we will be basically focusing on, as I have mentioned, the two plants. These two plants are being selected as a part of our interest, and these two are commonly used plants because they have a lot of substitutes over modern drugs as well. Also, there are multiple therapeutical activity which are being derived in our present work, which includes phytoconstituents by GCMS analysis. The advantages of GCMS phytochemical screening is also being carried out and being mentioned in our whole screening work. Considering GCMS profiling, the justification of the use of GCMS as a sustainable option or as a greener approach towards the chemistry background is being also justified. And one more antioxidant activity, which is free radical scavenging activity of these plant extracts, is being focused in our present work. Going ahead with a few aims and objectives for the derived research work. So the first one is with respect to extracting the plant leaves by different approaches. Now when we are talking about extraction procedures, it includes various extraction procedures with various solvents. So on those basis, standardization of the same and plus standardization of the GCMS methods of these plant extracts which we have prepared. Further identifying these characteristics. Hello. Yeah, I'm continuing. As we have standardized the GCMS method for an analysis, later the major task is with respect to identifying the characteristic components or the phytoconstituent components, which is possible when we search with respect to a NIST library search spectra. And later, these identified characteristic components are being processed ahead for revealing their antioxidant activity. Few materials and methods are being specified here. So basically, we started with different extraction protocols. We wanted to standardize our extraction methods, some traditional approaches like maceration, which is soaking, soxylate, which uses heat, some specified at some specified temperature. And in maceration also, we had multiple variants. We exposed the extracts to different conditions of sonication for accelerating the process of extraction for our molecules of interest, which in our case are terpenoids. So for soxylate, we ran it for about 8 to 10 cycles, and then as we were using technique like GCMS, which is highly sensitive technique, we gave a good sample cleanup by syringe filtration for the same. As Saili mentioned, using this technique was the first motto for getting phytochemical profiling or a prima facie idea about the two plants and their constituents or their phytochemicals or the secondary metabolites that are currently present in the leaf samples per se. And obviously taking the extracts and their isolates ahead for two of the major activities, two of the major methods for assessing antioxidant or free radical scavenging activity. These are general parameters of GC and MS. Temperatures which play significant role, the temperature of MS, the ion source temperatures which play significant role in separation as well as isolation of the ions present in the sample. These are the spectrum, the overview of which I'll be coming to. These are the spectrum, the TIC, total ion chromatogram, as we say, for the samples of the two plants exposed to different methods. This is steady maceration, accelerated maceration for both the samples. This is a consolidated table of results showing the summary of what percentage of content we have got for these
identified or peculiar phytochemicals which show some significant activity like octadecanoic acid, hexadecanoic. These are precursors of majority of the therapeutic molecules which are in use in the emerging natural therapeutics. Amyrins, both the type of amyrins, cytosterols, beta, gamma, lupiol. Now per se, for both the extracts, we have run different methods and we have found different differentiative results for the same activities of which are being presented on your screen. Per se, if we see as per these results, as per the results shown on the screen, maceration is supposed to be the best method because it uses lesser amount of solvent. Also, it is an environment friendly approach. We are trying to focus on sustainability and hence we have used the technique also in the same aligned area, which is GCMS, which uses extremely small amount of sample. But the method of extraction also should matter because that also is going to lead out a lot of solvent in the environment. So trying to focus on that, looking at the results currently, we can definitely say that maceration can suit the perspective.
Further, as the GCMS profiling is being carried out, the samples were being isolated and those isolated samples were assessed for the antioxidant activity, where we have run two methods. One is the FRAP method, which is ferric reducing antioxidant power, and the other one is DPPH assay method. So DPPH is 2,2-diphenyl picryl hydrazine. Whenever we are talking about DPPH assay method, it is basically focusing upon our hydrogen ions, which are revealed more or been spelled more with respect to the free scavenging radicals. So those, keeping that into the mind, DPPH assay is being carried out. It generally has a potency that it shows reducing absorbance range as it goes from lower concentration to higher concentration. Going ahead with the same, and so is what we have observed. Also, with respect to FRAP assay basically focuses upon the dried material or the dried ingredient of our plant, which is the solid powder plant. Those in those ingredients, how much of the ferric to ferrous conversion has been taken place, which has more potency to show the antioxidant activity or antioxidant potential specimens in those particular dried ingredients. So cumulative values are being also mentioned in the table below, which clearly mentions that around 39% and 50% of the antioxidant activity and 56 and 77% of the antioxidant activity is being respectively shown by Mucuna pruriens leaves and Moringa oleifera leaves. With respect to the 100 ppm and 500 ppm concentration of the samples which we had taken, which we had procured from the isolates. And when we are talking about FRAP assay method, as I said, it is basically with respect to the dried ingredient or dried weight. So to derive those weights, 56 nanomolar per gram and 66 nanomolar per gram is the estimated amount of the dried weight which have been calculated by performing the FRAP assay method. Going ahead with the conclusion and discussions. So to sum up with our research work, as Gauri rightly mentioned, solvent standardization was also our major motto. So for that, the preferable solvent which was being studied and being formatted in the current research work is methanol. Later, the accelerated maceration technique has served the best suitable results or given us the best suitable more yield of the extraction of phytoconstituents, and so that is being mentioned as a standardized method. Major class of phytoconstituents which we had focused on and is being derived is triterpenoids, and because it is triterpenoids, it has major potency to reveal the antioxidant or free scavenging activity as well. So this has served as the major class of phytoconstituents. We had also found out that the impact of heat and sonication is being served as the best suitable part for our maceration extraction procedures. As rightly mentioned earlier, GCMS technique is being served as a greener approach, or it has given us those aspects or modes through which a perfect greener environmental friendly approach is we can give to our research work. Later, with respect to just focusing upon the antioxidant activity, a dried residue activity is also being carried out or is being concluded with respect to the concentration of how much antioxidant activity can be found in a specific concentration. So as antioxidant activity is known to be a major route or a major reason behind developing more pharmacotherapeutical or nutraceutical aspects, those avenues are also being reviewed. Few future prospects is what we have justified or mentioned here. We would like to go ahead with method development and validations of the secondary metabolites, which is triterpenoids, which we have founded with respect to using various sophisticated bioanalytical techniques, and that is HPTLC and HPLC. Further, as it also may develop different activities, because the result analysis which Gauri had mentioned with respect to every phytoconstituents which was being revealed by the NIST library of the GCMS profiling, it had different activities which may get developed or which may get assessed. So to reveal those activities, we are also going ahead with respect to some animal activities or animal studies, either in vitro or in vivo. If those activities are being able to found out, it can surely justify some nutraceutical importance for these specific plant extracts or plant leaves. Few acknowledgements which we would like to give is to Department of Bioanalytical Sciences, Ramnath Ruia Autonomous College, Mumbai, and PS Ramanathan Advanced Instrumentation Center of the same college. Some references. Thank you from our side. Any questions?
So please show the slide number 11.
Yeah.
I think it's 12.
Yeah.
Here you have shown that is the antiviral activity of the particular compound. Okay.
Yeah.
So have you isolated this and have you studied this?
Yes, ma'am. We have isolated, we are into process of isolation of some of the components from the list. So we are doing it by purification HPLC or by preparative HPLC.
Okay, because in your conclusion you have said that is you have tested the that particular activity for the plant extract, and here you have shown the for the particular compound. That's why I'm asking.
No, these compounds that we have screened, this is basically based on the literature survey, ma'am. The review of literature. These are all the activities that these components possess. They are supposed to show these activities because they belong to the class of, majority of them belong to the class of terpenoids. So this is a general scan. We are yet to prove these activities. As we said, it is in future prospects that we are yet to prove it in vivo or in vitro. This is just an instrumental analysis part that we are presenting, ma'am.
But here you have not cited the particular reference. That's why I'm asking.
Ma'am, actually, in the presentation we have not cited, but we have given the citations in the references in the bibliography.
Okay.
Yeah.
Any other questions? Okay, next participant.
Thank you, sir. Thank you,
My
ma'am.
friend, Dr. Neeta Shinde. Dr. Neeta Shinde.
Yes, sir. Good afternoon. Am I audible?
Yes, madam. Yes. Please share your screen.
Yes. Is it visible, sir?
Yes, madam, please.
Yeah, yes. Good afternoon. I'm Dr. Neeta Shinde from LAD and Srimati RK College for Women, Nagpur. I'm working as assistant professor in the Department of Physics. And today, topic for my oral presentation is carbon QDs for emerging biomedical applications. This is the abstract. These are overviews of my presentation, where in the 5 minutes, I'm going to discuss introduction of ICISSD, synthesis methods in short, and biomedical applications, challenges and future objectives. At the present time, humans are dealing with several newly developing diseases such as the cancers, many of which are exceeding hard to treat. The first step in diagnosing treating cancer is separating tumor cells from normal cells. And targeted cancer therapies minimize side effects and do not damage the healthy cells, which was the primary barrier to using the chemotherapy as the main therapeutic approach for the majority of the cancers. These carbon quantum dots are tiny particles made up of carbons.
मैं कर रही हूँ मेरे पास नहीं मैम का फोन आ गया मैं कर रही थी वो कह रही बताओ तो बहुत ही नाराज
less than 10 nanometer in size, which is much smaller than the width of a human hair. As you know, they are special because they can glow when the light hits them, which make them useful for the things like medical imaging and as well as electronic devices also. To keep these tiny dots safe and help them to work better, they are usually covered with a protective layer. This coating helps prevent damage and improve their ability to interact with the other materials. Some scientists also attach molecules from the plants or other living things to these dots. These organics or biomolecules can help CQDs perform specific tasks like targeting certain cells in the body for medical applications. The accidental discovery of the CQDs while isolating and purifying the single-wall carbon nanotubes by XU and other scientists in 2004 led to additional research on utilizing fluorescent properties of the CQDs and creating a new type of a fluorescent nanomaterials, functional fluorescent nanomaterials. And in 2006, that GAU identified fluorescent carbon nanomaterials as a carbon quantum dots. CQDs are used for their dimension less than 10 nanometer, comparatively intense fluorescence, rapid, straightforward production, and favorable solubility in water, compatibility with the biological system, resistance to chemical reactions, stability under light exposure, ability to simply adjust their optical properties. Because of their exceptional photoluminescence and optical properties, their manufacturing cost is also low again, so that these CQTs are allowed even in a situation where other carbon-based nanomaterial, such as those employed in a biomedical or bioimaging, have the restrictions. CQD possesses high potential for commercial applications. Also, when compared to the semiconductor equivalent of it, as these materials have the low toxicity, outstanding biocompatibility, superior solubility, robust, consistent photoluminescence, large surface area, and tunable band gap. Various approach have been employed to synthesize these CQDs. Significant amount of the research primarily concentrates on each synthesis scheme in order to identify the most efficient, environment-friendly, and high-yielding method. CQDs are produced by using the two methods, top-down approach and the bottom-up approach. The top-down methodology refers to process of the breaking down bigger carbonous materials or structure implying methods such as the chemical oxidation, discharge, electrochemical oxidation, ultrasonic treatments. But this strategy has several disadvantages, such as a necessity of a costly ingredients, stringent reaction conditions, extended reaction duration. In contrast to that, this bottom-up strategy, it involves the transforming tiny carbon structure into CQDs of the appropriate size, include hydrothermal treatment, ultrasonic treatment, thermal breakdown, pyrolysis, carbonization, microwave synthesis, and Salmos thermal approaches. In order to prepare this CQD, which are important to take into account preservation of the green environment and prevention of the increasing global warming and the use of these sustainable and renewable sources of energy. All while the cost effectiveness also, the bottom up approach is a superior as it control over size, higher yield, and environment friendly processes are also there. So the bottom up approach to produce or to synthesize the nanomaterial less than the 100 nanometer or 10 nanometer is also, or the for the particular applications, this methodology is used. The process of a surface functionalization and passivation, passivation that is by adding specific group such as a OH to the surface by chemical reaction or hydrogen bonding, etc. And functionalization that is by applying coating material to the surface to protect that metal. This functionalization of a security significantly impact their interaction with these organic molecules, ions or drugs or biological beings, hence influence the properties and can be used for the biomedicine or biomedical applications. The surface passivations, it is again crucial factor to examine relation to their biological applications, such as a cell localization. Doping of a security is again important with the doping with the different elements such as the nitrogen or sulfur, which can adjust electronic and optical properties, which increase the quantum yield and brightness of the securities, beneficial for the imaging applications. This doping can create active site, enhance the catalytic applications. Nanocomposites, combining these securities with other materials like the metal polymers, again can enhance mechanical, electrical, and thermal properties, enable the creation of a multifunctional materials for drug delivery, imaging, therapeutic applications, increase efficiency and performance in the biosensing and imaging due to these combined properties. Again, the core shell structure, as this is a review. So, Bhogal and other researchers, they developed the core shell structure utilizing these carbon dots as the core and molecularly imprinted polymer as a shell through the soil gel method. This was utilized for the detection of the pitrocoprene. Shell materials, they can be designed for the stimuli responsive drug release. Example, like the pH or temperature. This shell can shield securities from degradation or biological reaction while retaining functionality. Can modify the surface characteristics also for improve the targeting, reduce the homogeneity, and enhance the blood circulation also. This security have the unique physiochemical and catalytic features that make them potential for the several biomedical applications. They have the two features mainly, tiny size and biocompatibility. Biocompatibility, that how they react with the living cells, which allow them to employ as a drug delivery vehicles, we can, while also being monitored in the body because of their PL qualities, that is photoluminescence properties. Securities with a low toxicity, high hydrophilicity, and water solubility, excitation valence, dependence, PL emission, or chemical stability have several potential uses in this biomedical field. So let's review these applications one by one. Drug delivery, this security possesses high efficiency as a carrier for drugs and genes due to their biocompatibility, photoluminescence, and non-toxic nature. Additionally, their tiny size and wide surface area enable rapid cellular uptake without significantly impacting drug activity. Example of this is effective attachment of anti-cancer medication doxorubicin onto the surface of the composite material arginine glycine aspartic acid GQDs. These composite materials have been used for drug delivery and targeted imaging purposes. Again, these carbon quantum dots have the ability to be linked with the peptides, antibodies, or small molecules, enabling their application in the identification of the cancer cells and molecule biomarkers. These include iron oxides used for the MRIs and drug delivery, nanoparticles used for the drug delivery, and these CQDs used for the bioimaging and molecular diagnostics. They have as they have the strong luminescence property, they make them high desirable for use as a labels in the biomedical applications. The research is ongoing and it has been conducted on the utilization of these securities to detect malignant cells in the pathology investigation. This is achieved by labeling cells that possesses specific receptor types on their surfaces. The finding in this research may indicate that tumor is a susceptible to targeted therapy. Again, antimicrobial activity, CKDs have demonstrated effective interaction with several viruses, resulting in the inhibition of the infection. They have the potential to effective against one of the most significant pathogenic human illness currently prevalent, that is named coronavirus. From a mechanistic standpoint, this can be attributed to the inhibition of entry of a human coronavirus 229E. This inhibition caused by the contact between boronic acid activities of the CKDs and the HCOV 229E S protein through the interaction based on the pseudolectins. These findings provide evidence for the substitute of existing antiviral agents such as the interferons and ribavirin. These drugs exhibited various adverse effects, including short-term memory loss, that ribavirin or interference, impaired decision-making function, disorientation, and exacerbating effects. So these carbon CKDs can be substituted for these drugs or antiviral agents. Functional action can enhance the interaction with the microbial membranes, increasing toxicity towards the pathogens. Gene delivery, again, security plays significant role in this gene delivery or in the medical science by treating the diseases and correcting the expression of the genes on a DNA that are absent or faulty. Hence, the number of bacteria of a nanoparticle are employed in the gene therapy to transfer the gene to specific location inside the DNA. A study, it was conducted to produce and characterize theranostic and reproducible nanoagents called FCRPI secreties. Nanoagent possesses a high level biocompatibility and serve as effective carriers of delivering gene to cure the specific case of a lung cancer. Simulation of a cellular uptake, that is how efficiently that drug and other therapeutic agent can reach to the particular cells. So positively charged secretions that can enhance the cellular uptake through electrostatic interaction with the cell membranes. Now, CKDs are utilized in very biological application as a substitute for the harmful nanoparticles. There is an insufficient study on the effect of the CKDs on the hybridization of the peptides and proteins. The study is conducted where the CKD is synthesized by using carbon powder with a diameter around 4 nanometer. And it is found that the CKD can inhibit insulin fibrillation with the extent of the inversion depend on the concentration of the CKDs. These CKDs can be employed in the field of a biosensor and bioimaging and within the living organisms as well
Madam,
as
time is over. You are explaining more and more.
Yes, sir. This one.
Time is only 6 minutes, and you have gone through the above 6 minutes. So
Sir,
please conclude.
Yes, sir. Within 2 minutes. So we can look at this optical imaging for this image that CKD's water solution WS in a mouse with a tumor captured at a different time intervals. So when the CKDs were not injected into the mouse with a tumor, no fluorescent signal were detected in the animal body. And the manufacturing of a fluorescent signal commenced after 5 minutes subsequent to the administration of this CKD solution. So this experiment, it demonstrated that CKD can undergo the cyclic process in a mouse body and can also be gathered together in the desired location and achieve the state of a stability primarily at the site of a tumor. Again, the photothermal therapy and photodynamic therapy. Challenges. There is a necessity to enhance the brightness of fluorescence in the NI region, which are crucial for the specific biomedical uses, because in this process as the heat is emitted mostly, so the brightness should have to be increased. Impact of a surface chemistry and impurity doping again. If the large scale, in case of a large scale, if they are produced, then again the properties maybe get changed, or there is a tailoring the receptors. These are conclusions and opportunities for the future research. Thank you.
Madam, any question?
No, sir.
Okay.
From the audience?
Audience, anybody? Dr. Devsarkar is there?
Sir, Pranita Ashtankar.
Hello. Dr. Santosh Devsarkar is there?
Sir, Pranita Ashtankar.
Majay,
Sir, I have one
you are not
request.
in this list. In next.
Sir, Pranita Ashtankar.
Sir,
I have a
you
request.
You are not in this list. You are in the next session.
So now I would like to invite chairperson of today's session, Professor Dr. Devsarkar sir, to give the concluding
Excuse me, sir. Excuse me, sir. I, Dr. Hashim Shakil Iqbal.
Yes.
Let me know my presentation time because I am out of country from
Okay.
Saudi Arabia.
Okay. So you have not joined the group? In the
No,
group, there
I
is a
have joined
list.
the group. I am joined the group.
The list is
But,
given in the group.
But still, I have not received, sir, which my number is.
Okay. You may contact to the organizer and
Dr.
there is
Hashim
a
Shakil Iqbal.
Dr. Atish Maldure. You may contact them. Hello.
Okay, sir. Okay, sir.
Okay. Devsarkar sir. Devsarkar sir is there? Hello. So I think this session is over, madam,
Yes.
because all the participants has given their oral presentations. Thank you, all of you. And
Thank
best
you.
wishes. And best wishes to all.
Excuse me, sir. Sir, let me know my status.
Yes, you may contact to
Just
the convener.
Hello.
Hello, ma'am.
Myself, Sikha Mishra, sir.
No, Dr. Hashim Shakil Iqbal is calling.
Myself, Sikha Mishra speaking. I am audible, sir.
Yes, madam, please.
Sir, my presentation was now could not be done at that time. May I present now?
No, ma'am, you may contact to the convener because we are the jury and there are different sessions. So you contact to the convener, Dr. Atish Maldure, and his number is given, I think, in the brochure.
Okay, sir.
Or you may contact on the group. You may message them on group.
She was listed in this for this particular session, but you were absent during your that is
Yes, sir.
when
Yes, sir. I was
there
listed
was the
for
turn, and that's why with the permission of the chair only we will allow you. So organizer will guide in this set.
Okay, what is your name?
Mishra.
Shikha Mishra, sir.
Okay, Mishra. At that time,
Myself was listed in this session.
yes, but you are absent at that time. You are not
No, sir,
audible.
I was present, but there was some communication problem at that time.
Okay. Madam, काय करायचं? Hello.
Yes, sir.
Okay, finish within 4 minutes or
4 minutes. Shikha Mishra,
Okay,
please.
sir. Okay, sir. Okay.
Please finish within 4 minutes.
Thank you, sir. Thank you for giving me this opportunity. Sir, my PPT is visible there.
Yes, visible.
Okay,
Continue.
okay, okay. Uh, my topic for this presentation is graphene polyalpha methylstyrene based cross-linker polymers for highly water treatment. Next, this is the abstract question, whatever I have prepared so far. Coming to the introduction, firstly, I will take polymer, then its classification. Next, whatever the base material I have taken here, that is graphene and polyalpha methylstyrene. Now, the GPMS cross-link polymer I have prepared for its analysis. I have done scanning electron microscopy and contact angle measurement analysis. Now, final is the conclusion. Coming on to polymer, whatever is polymer, these are large molecules having large molecular mass made by together repeating units of molecules called monomers. These are basically classified on the basis of occurrence, structure, molecular force, and thermal behavior. On the basis of occurrence, these are basically natural polymer, synthetic polymer, and semi-synthetic polymer. And on the basis of structure, it is linear polymer, branch-chain polymer, and cross-link polymer. Based on molecular forces, it is called elastomer, fiber, thermoplastic, and thermosetting plastic. Now, last, that is almost the same category of the third one, that is thermoplastic and thermosetting plastic. I have prepared a cross-link polymer for which I have taken the base material graphene, which is a 2D nanomaterial and have hexagonal lattice structure, which is shown here at the bottom of the slide. In this history, it was discovered by Jim and Konstantin Noslow at the University of Manchester, and for which they got a Nobel Prize in 2010. It have enormous properties such as high strength, high conductivity, high thermal conductivity, flexibility, transparent, and chemical stability. Now, so coming to the synthesis of polymer, whatever I have synthesized here, I have taken graphene, which I have dissolved in dimethyl formamide which is taken as a solvent. In it, I have added alpha methylstyrene, taking benzoyl peroxide as initiator and dimethyl benzene as cross linker. These were set on a water bath at 70 degrees Celsius for up to 1 hour, and finally they were poured into petri dish containing methanol. This was dried and gone to further analysis. In further analysis, I have done two analysis. That is morphological analysis, and another is hydrophilic characterization I have done for it. In this, it's scanning electron microscopy, which whatever there are some images I have shown here. In which there is a homogeneous distribution of the network found in this polymer, and there are some pores on this surface. And in the last image I have shown, there is zero surface morphology and showing the interaction between graphene and polyalpha methylstyrene. So it has a good, it may be a good surface absorbent material. From here I can see, from here we can see. Now, there was another analysis I have done, that is contact angle measurement, and here the angle observed here is 70.2, that is left, and 70.8, that is on the right corner of the picture. So it comes in the hydrophilic range. Being less than 90, it comes in the hydrophilic range. So it might finally, in conclusion, it might have several applications, that it can be used as an adsorbent and water purification membrane. It can be used and in direct delivery, it's a system, etc. Finally, coming to thank you, I would like to thank you my supervisor, Professor Kamal ma'am, my co-supervisor, Professor Arkit Vedi ma'am, and IIT Kanpur for material characterization, and Christchurch College, the principal of Christchurch College, Kanpur, for giving me this opportunity. And finally, Srimati Narsamma College, Amravati, for presenting this work, for giving me opportunity to present this work here. Thank you.
Okay, thank you.
Oral presentation session is completed. Now I would like to invite chairperson of today's session, Professor Dr. Joseph Pastor, to conclude the concluding remarks.
Dr. Devsarkar sir. Hello. Dr. Devsarkar sir is not there. So
Sir, I'm Dr. Harpreet Kaur. If you allow me to present the first presentation, it is so nice of
Madam,
you because in Punjab,
second session
sir,
is not
actually,
started yet. Second session is not
okay,
started. Just first is overing and second is starting. Okay.
okay, sir.
So I
Okay.
think
So,
madam, our session is over.
yes, yes.
So please conclude
So,
the session by giving the remark. Chairperson is not available there.
yes, that's why just we will give the sheet to our organizer, and we are thankful to the organizer for inviting us and for giving the opportunity to judge, so that we have also listened the topics presented by the participants. So thank you to the organizing team. Thank you very much.
Thank you. This session is over.
Yes, yes.
Handed to the organizer for next session. Thank you.
Thank you all for your active participation in this session. We appreciate the hard work and dedication that has gone into each of these presentation. Our judges will now deliberate and select the best presentation, which will be announced during the closing ceremony. So I am very much thankful to Dr. Devsarkar sir, Dr. Bharati madam, and Dr. Gawade sir for their cooperation, and also I am very much thankful to all the speakers and the participants. Thank you very much. The next session will start immediately. Thank you so much.
Good afternoon, everyone. Myself, Professor Mumtaz Chaudhary. Today we are going to conduct oral presentation session on behalf of college and SCT. I welcome you all to the oral presentation session of research paper at an international conference on innovation in science for sustainable development. We are honored to have with us Principal Dr. Pradeep Tekade sir, the chairperson of this session. He is principal at Bajaj College of Science, Warda. Welcome, sir. We also have Dr. Siddharth Wagmare as a jury for this session. He is professor in chemistry at GNA College, Barchitakadi. Welcome, sir. We have Dr. Amit Yaul as a jury for this session. He is a professor at NKS Model College, Karanja. Welcome, sir. Both the judges are going to evaluate this session. Let's give them a warm welcome. This session will feature total 16 oral presentations, each lasting for 6 minutes. After his presentation, there will be 2 minute question answer session, where our judges and audience members can ask a question. Our judges will evaluate the presentation on the basis of their technical content, presentation skills, and overall impact. With the permission of chair, I would like to invite our first speaker, Dr. Indrani Jadhav madam, to present her research work.
Yes. First of all, yes, I'm Dr. Tekade. The outset, thanks to the convener of this particular international conference, my friend Dr. Atish Maldure, and whole team of Srimati Narsamma College to giving me this opportunity to chair this oral presentation in the International Conference on Innovations in Science for Sustainable Development. Thanks to Professor Gurnule, who is the Vice President of Association of Chemistry Teacher. And in this session, total 17 candidates have to present their research work. And so all the best to all the participants. Best wishes to juries also, because this is a big task. So if the juries are ready, let's start the session.
Yes, yes, sir. Good afternoon, sir.
Good afternoon. Good afternoon.
Yes, sir, we are ready.
Yeah. Thank you. So
Uh,
first participant is Ms. Pranit E. Ashtankar. She will present her presentation of
Excuse me, sir.
Yeah.
Just now it has been declared Dr. Indrani Jadhav will be the first presenter. So I have shared the screen.
just a second, sir. Wagmar sir is ready.
Yes, sir. Yes, sir. I am ready.
Okay, sir.
Thank you.
Sir, may I start now?
Yes, madam.
Okay, thank you so much, sir. This is my kind privilege to participate in this particular conference. My topic is biotechnology for the eco-friendly pest management. I'm talking from Jaipur National University. I'm the professor over here and the senior coordinator of the Department of Life and Basic Sciences. And today I'm going for the presentation on the biotechnology for the eco-friendly pest management. Organic bioinsecticides, plant-derived biopesticides, pheromones, and repellents. We know that basically this bioformulation, they are going for different type of pest management, which are actually going very importantly for the eco-friendly formulations. Basically, their main aim of this particular thing is protecting the crop yield, reducing the economic losses, preventing disease transmission, and involving food security and reducing economic losses. Now, what happened is that what are the main basic components for the eco-friendly pest management methods are organic bioinsecticides, plant-derived biopesticides, pheromones, and the repellents. Organic biopesticides, they are basically derived from that of different type of plants, animals, and bacterial formulations, and they are main responsible for the sustainable approach in this pest control. And there are a lot of microbial pesticides, for example, Bacillus thuringiensis and some of the other fungi, Brevura, and these microorganisms, they basically work on the targeted pest and the host. Trichoderma has been responsible or has been declared as one of the basic microorganisms which is actively participating for the target pest like Ralstonia, and their host is Solanum. So this biochemical pesticides, they are also helpful for controlling the pest. And one of the most important thing is plant incorporated protectants. These pesticidal substances, they are having the genetic material which is very much important for controlling of different type of pest formulations. And now the benefits of these organic pesticides is that it has reduced the environmental impact, targeted pest control, and finally they are going for the sustainable agriculture. Now this plant-derived biopesticides, we all know that these are basically the plants which is enlisted as for the biopesticides like neem, turmeric, garlic. They are antioxidants too, and they are very much used for different type of pest control because of their basic features, that is environmentally, they are environment friendly, they are sustainable agriculture, which is a basic demand for the today's world. And there are some formulations also with that of which is termed as bioformulations, and with the chemical formulations and bioformulations, sustainable agriculture can be emphasized and they can be established in a well manner. Finally, they are going for that of reduced health risk, and there is a lot of chances which we can have the resistant to that of the pest control. So these are some of the plant derivative biopesticides with their properties, which I've already told previously, that is neem, turmeric, garlic, and many other plants which is directly used for the bioformulations. This next is very interesting part. This is pheromones as a biopesticides, because these are the natural chemicals. Actually, what happened is that they used to target the reproduction cycles of this pheromones. If you will have a dispersed part, they will not able to establish as a paste. So these are used for their targeted action, reduce the chemical pesticides beneficial part and that of the environmental friendliness, a part of their compatibility for their biocontrol. Next is that these are some of the examples which are used basically in this today ICR world for different type of as a pest control. These are leptospirillin paste, fruit flies, weevils, and the cotton bollworms. They will help to control the biopests. Now, this is also some of the repellents can also be used as biopesticides. These are basically derived from that of natural resources like plants, animals, and microbes. And obviously, because they are derived from that of the living world, so they are eco-friendly, targeted control, and they may be having the less impact for the environmental pollution. Apart of that, we know that when we are using the chemical sprays for that of bioformulations and all, for that is a very difficult part because they can't be easily degraded in the natural environment. So these are having the targeted control apart of the natural environment conservation and sustainability. Now they will be rapidly degraded and there will be less likely to develop the resistance. Now, examples of these repellents are neem oil, glycerol oil, essential oil, microbial repellents, and there are some of the plant-based repellents. Now, what are the challenges basically we are facing? Because these are biological original part. They originate from the biological origin. So there is a challenge for the establishment. They are having a low efficacy and comparatively.
Madam, your time is over. Please conclude within 1 or 2 minutes.
I'm just concluding, sir.
Okay.
This is a slower control, shorter persistence, greater sustainability for the environment, higher environmental knowledge for the requirement of the growers because they are not skilled. Formulations and the shelf life has to be taken into account. A part of that, we are having the cost for the implementation in consideration to that of broad spectrum control and regulatory issues. And these are my selected references. Thank you so much for allowing me for the participation.
Okay, madam. Any question from audience side? Yes. Any question? If no, please next presentation.
Thank you.
No
so
question, sir. Please go for the next.
Miss Pranita Ashtankar.
Yes, ma'am.
Mr. Shailesh sir, Dr. Shailesh sir, you're not audible. Hello.
Actually, Miss Pranita Ashtankar is first in this list.
Okay. Oh, okay.
Yes,
Okay.
sir.
Okay.
Miss Pranita.
Yes.
Yes, sir.
Hello.
Good afternoon, everyone. Present over here. I'm Pranita Ashtankar and I'm research student of postgraduation teaching department of zoology, Rashtrasanta Tukdoji Maharaj, Nagpur University, Nagpur. My research guide is Ambedkar sir from Vidya Vikas College, Samudrapur. These are the introduction.
मैडम वो स्क्रीन जो है ना वो फुल कीजिए पूरा.
Okay, sir.
Publish your screen by pressing F5. Miss Pranita, press F5.
Yes, Miss Pranita.
Yes, sir.
हाँ हाँ वो स्क्रीन पूरा वो फुल कीजिए ना स्क्रीन वो। नहीं हो रहा।
नहीं सर।
फिर से एक बार शेयर कीजिए।
ओके।
नो सेम इशू।
सर एक मिनट।
Can you see the bucket symbol in your presentation? Just before the zoom out button.
हेलो।
यस सर।
हाँ जी क्या प्रॉब्लम है।
सर जूम नहीं हो रहा है।
Okay, continue then.
सर कंटिन्यू करें क्या?
Yes, continue.
Good afternoon, one and all present over here. I am Pranita Ashtankar, research student from postgraduate teaching department of zoology, Rashtrasanta Tukadoji Maharaj, Nagpur University, Nagpur, and my research guide is Ambedkar sir from Vidya Vikas College, Samudrapur, district Wardha from Maharashtra. My research topic is monitoring of heavy metals in 4 sites of Pena River water, Hinganghat, Maharashtra. Introduction. Hinganghat is one of the tehsils of Wardha district. The town is located on the bank of Pena River, a tributary of the Wardha River, which joins the big river Pranita, which ultimately merges into Godavari River. The river play a major role in transporting industrial and municipal wastewater and runoff from agriculture areas. Water is essential component of our day-to-day activities, but due to population growth, water resources have been polluted. An enormous amount of heavy metals are being discharged by anthropogenic activities at the same time. Natural processes like weathering and also contribute. contributes to metal contaminations in the aquatic environment. In this study, area, textiles, agro industries, pharmaceutical company, cotton mill, Swachai company, oil industry, paper mill, dal mill are located. Since these sampling sites receive a lot of agriculture and domestic sewage apart from industrial effluents. Therefore, monitoring heavy metal concentration is very important because of their toxicity and their bioaccumulation in living organisms. The table showing heavy metal concentration in four sampling site at different sampling locations. Sample 1 in which contain sampling sites 2, sites 3 and site 4 in which found that the concentration of heavy metals lead chromium, cadmium, zinc, ferrous, arsenic, abscess, nickel and copper is higher in two sites 3 and 4 due to nearby industries. Hence, monitoring of heavy metals is necessary and it is necessary to do proper treatment before removal of industrial effluents in river water. Conclusion, if heavy metals are consumed by water bodies, they can accumulate in aquatic organisms, leading to bioaccumulation and causing health risks to humans and other animals through the food chain and potentially causing damage to ecosystems. Therefore, it is necessary to do proper treatment before removal of industrial effluents in river water. Thank you. Thank you so much.
Any question from audience? Okay, no question. Okay, Ms. Pranita, have you published this work anywhere in the journal?
Yes, sir.
Have you published this work anywhere in the journals?
No, sir.
No. Okay,
Thank you, sir.
go for the next. Dr. Shailesh Mandavgade, you can share your screen.
Next one, Dr. Shailesh Mandavgade.
Sir, you are not audible.
No audio is there, sir.
Dr. Shailesh K. Mandavgade, please switch on your mic and start your presentation.
Am I audible, sir? Hello? Hello?
You are not audible at all.
Hello? Hello? Am I audible, sir? Hello?
Yes, you are audible, but your voice is very low.
Okay, sir. Yes. One minute. Hello? Now it's clear, sir? Voice? Hello? Hello? Sir, am I audible, sir? Now? Hello? 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 This is not clear on the Hello? I audible, sir? Hello? Hello? Hello?
Dr. Shailesh Mandavgade, sir.
Sir, am I audible, sir?
Your mic, actually your mic may have some trouble. Please try from another device. You are not audible at all. If you are hearing us, please do arrangement. Let us move for next. Excuse me.
Next
Is there anyone
presentation.
from organizing committee?
Hello. Next
Dr. Deval
presentation.
Deshmukh.
पाण्याची bottle आणून बघ.
Dr. Deval Deshmukh, are you here?
Dr. David
Hello.
Deshmukh.
Yeah, it's Deval Deshmukh, sir. Am I audible?
Yes, sir.
Yes,
Yes,
yes.
sir.
Okay. Just let me know whether my screen is visible or not.
No, sir.
Yeah, just wait, sir. Is it visible now?
Yes,
sir.
yes, sir.
Okay, thank you, sir. So good afternoon, all the jury members and participants and organizers of the International Conference on Innovations in Science for Sustainable Development. I'm Dr. Deval Deshmukh presenting my research work here, that is the synthesis of N-tosylhydrazone using synthesis of isoquinolines using N-tosylhydrazone as a directing group and the copper metal catalyst. So as we know that N-heterocyclic compounds having a tremendous importance in organic chemistry, as it is having the wide applications in the biomolecules as well as pharmaceutical compounds, also in the material science, and also it is having the huge synthetic utility as the precursors, chiral auxiliaries, organocatalysis, etc. And the specific topic on which I am working is the carbon hydrogen activation bond, that is which is widely known as the CH activation, which is one of the hot topic in the organic synthesis nowadays. So as we know that almost all of the organic compounds having the carbon hydrogen bond means it is widely present in the organic molecules, but also there are some challenges in this topic. Basically, the CH activation is activating the carbon hydrogen bond or the breaking carbon hydrogen bond and incorporating a new functional group, directly incorporating the functional group of there. Although there are some challenges for this area because the carbon hydrogen bond having the high bond dissociation energy, that's why it is thermodynamically unfavored. Also, because there are several carbon hydrogen bonds present in one single molecule, so the issue of selectivity is there. The catalytic processes development is another challenge in the CH activation area. Also, in some of the cases, products are typically more reactive than the reactants, so that is another challenge. Beside these challenges, there is some beauty or the characteristics of the CH activation reactions, because these are the fundamental linkages in the organic molecules. It avoids the additional pre-functionalization of the starting material. These steps are the atom, these processes are the atom and step economy. There are several new retrosynthetic possibilities by using these strategies, and this is considered as one of the most broadly applicable and powerful class of organic transformations. So basically, in carbon hydrogen bond activation or the CH functionalization, we use one directing group, which is one of the functional group we can consider, and there is one metal catalyst. So to the directing group, we bind the metal catalyst there, and so we bind the metal catalyst there, and after that there is incorporation of the metal to the functional group and followed by cyclometallation, and then we introduce the functional group to the basically our reactant molecule. So we will see the mechanisms in detail while discussing our own scheme.
Sir, you are not
I am
audible.
facing some issue with the. Hello.
Okay, okay. Hi.
Yeah.
Yes,
Am I
sir. Okay,
audible
continue.
now?
Yes, sir.
Actually, I am facing some technical issues. Yeah, yeah. Of course. Okay. So, coming to my scheme, that is the CP star cobalt mediated CH and NN bond activation. So we have developed isoquinoline molecules using N-tosyl hydrogen directing group. For this strategy, we have basically synthesized one cobalt catalyst by using a very well-known protocol which was published in the Advanced Synthesis and Catalysis. So we have synthesized the catalyst in our laboratory and also analyzed that catalyst by using the NMR spectroscopy. So we got one peak at 2.21, which belongs to the pentamethyl cyclopentadiene molecule, and we confirm that there is formation of the catalyst. So we use this catalyst for the synthesis of isoquinolines. So considering the prior art, there were several strategies which were reported in the literature for the synthesis of isoquinoline using various transition metals. So some of the directing groups here reported we can see on the screen. These were the directing groups which were used for the synthesis of the isoquinolines, but N-tosyl hydrogen was not used in the literature till our work. So we decided to utilize N-tosyl hydrogen as a directing group for such kind of transformation and doing the annihilation reaction with the internal alkynes using the cobalt catalyst. So our catalyst is the economic and versatile. Then the strategy is external oxidant free, because in most of the CH activation reactions there is requirement of the external oxidant. And basically our N-tosyl hydrogen as a directing group is the novel directing group we have used here. This scheme is also the scalable to the gram level, and it is having the wide substrate area. The substrates which we have used, they are also easily preparable. So we have optimized the reaction with the various parameters. That is, we have used several cobalt catalyst precursors. But also we have changed the different temperature conditions and different time conditions, and the optimized reaction conditions where we utilize N-tosyl hydrogen as a limiting reactant as 0.2 millimole. 2 equivalent of internal alkyne we required. Then the cobalt catalyst we required 10 mole percent. Silver salt 20 mole percent. Acetic acid 20 mole percent. HFIP as a solvent, and the temperature 100 degrees centigrade for 12 hours. So coming to the mechanism of this particular reaction, as we know that here initially we have started by the activating of the catalyst by using acetic acid. So we have activated the catalyst first of all, and then the catalyst or the cobalt from the catalyst coordinated with the nitrogen of the N-tosyl hydrogen directing group, eliminating the SiOH from the reaction. Then followed by the cyclometallation, there is insertion of the internal alkynes to the metal complex which have prepared in the reaction. And then after insertion, there is elimination of proto-demetallation of the particular metal catalyst, which giving the desired product, that is the isoquinoline here. So in this way, we have synthesized the isoquinoline by using CH activation and NN bond activation strategy. So we have synthesized several substrates by using this strategy, and you can see on the screen we got good to excellent yields for the isoquinoline derivatives, and we could synthesize up to approximately 25 isoquinoline derivatives by using this strategy. So this work has been already published in the Journal of Indian Chemical Society, which is the journal from the elsewhere. So these are my publications. I would like to acknowledge my guide, Professor B.M. Bange from Department of Chemistry, Institute of Chemical Technology, Mumbai, UGC, for the fellowship. Then my co-workers in my current college, then the BMB research group and organizers of the ICISSD 2025 for giving me opportunity to present my work over here. So thank you so much. This is my research group from ICT Mumbai. Thank you. Any questions are there?
Yes. Any question from audience? Okay, no question. Nice presentation, Dr. Deval sir.
Thank you, sir.
Next.
Hello.
Ah,
Hello,
yes,
am I
yes, yes, sir.
okay, sir. Sir, can I start? Hello.
Sir, you are
Am I
not audible,
audible?
sir.
Okay, sir. Okay, sir. Sir, is the screen is visible, sir?
Yes, 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 sir.
Okay,
Yes, sir.
sir.
Now you can
Good
start.
Okay, good afternoon, sir. My name is Dr. Shailesh K. Mandagude, that is Assistant Professor from GS Raisuni College of Engineering and Management, Nagpur. I have completed the PhD under the guidance of W.B. Gurnule. My topic is a new chelate resin to restore the harmful metal ions made in aqueous solution and isothermal studies. Just 1 minute, sir. This is the abstract of my research work. I have prepared the 2,4-dihydroxyacetophenone catechol and formaldehyde resin in the ratios 1:1 and 2 ratios. And that is this polymer, that is 2-HACA polymer, is prepared by the condensation polymerization. I have used the 5 metal ions, that is copper ion, cobalt ion, nickel ion, zinc ion, and lead ions in the different electrolyte concentration and wide range of pH and time interval. Now, introduction part. The polymer is a high molecular weight compound which is made up of large number of small chemical units. For example, here given that is ethene molecule, large number of ethene molecule, that is known as monomer, or when the ethene molecule are attached with each other to form the long chain polymer, that is known as polyethylene. If the number of repeating unit in the chain is called as the degree of polymerization. Now, polymer are classified on the basis of different ways as given below, that is on the basis of their occurrence. On the basis of their occurrence, polymer are divided into 2 parts, that is natural and synthetic polymer. On the basis of nature of monomers, polymer are divided into 2 parts, homopolymer in which the same type of monomer are present, and number 2, that is the copolymer in which the different types of polymers or different types of monomer are present. Next one, that is on the basis of structural polymer. Polymer is divided into 2 parts, a linear chain and cross-link. And on the basis of thermal behavior, the polymer is divided into 2 parts, thermoplastic and thermosetting plastic. Now, that is the introductory part. That is the polymer have the large number of practical application in electronic control, insulating material, protective adhesives, aerospace industries, because of
Shailesh,
their
please,
hello.
just a minute, sir. Shailesh, sir.
Yes. Yes, sir.
Time is our time is very lag. Please
Okay,
present
sir.
your work.
Okay, sir. I have prepared, that is the plan of work, my research work, that is synthesis, crystallization, and ion exchange properties. Now, I have prepared the 2,4-HCF resin, that is the polymer, by using the 3 monomers, 2,4-dihydroxyacetophenone, catechol, and formaldehyde. Now, this polymer 2-HCF is prepared by the condensation polymerization of using these 3 monomers. Now, that is first, that is the crystallization of this my polymer, that is 2,4-HCF. This is the graph that is plotted between the specific conductance and mini equivalent of the base. Now, this titration curve indicate the sharp stepwise increase in the conductance till the complete neutralization of all phenolic hydroxyl group. As the molecular weight of this polymer increases with increase in the 2,4-dihydroxyacetophenone content. Now, second one, that is the polymer, that is the, just 1 minute. So, UV visible spectra of polymer, that is polymer shows 2 characteristics band, 240 to 260 and 320 to 350. This observed position for the absorption band clearly indicate the presence of carbonyl group in the tercopolymer region belonging to the 2,4-dihydroxyacetophenone moiety. Next, that is the infrared spectra of my polymer, that is various functional group present in copolymer region were determined by using the infrared spectra. There are various functional group as the hydroxyphenolic COCH3 group, aromatic ring, CH2, that is methylene bridge, AR aromatic ring, that is CH2 AR bridge, and all the substitution in the benzene ring having the expected band frequencies are given, and observed band frequencies from this infrared graph, that is are here. Now, next one is the NMR spectra, that is the nature of proton. Different types of nature of proton are assigned or determined, calculated by using this NMR spectra, that is methylene proton, aromatic proton, methylene proton, proton of aromatic OH phenolic group, and methylene proton of aromatic CS2 aromatic group. Now that is the same photograph, that is the indicate the nature of crystalline structure, that is the crystalline nature of this polymer that is indicated by this same photograph. Now water play an important role in our body system. Nowadays the different contaminants are released to the wastewater, which rapid industrialization of human society, including the heavy metal ions, which are very serious and harmful to the human health. Among all water contaminants, heavy metal ions such as lead, cadmium, zinc, nickel, and Hg having the toxic properties can cause the severe health problem in animal and human being. And this harmful effect of cadmium also lead the number of acute and chronic disorder such as renal damage, hypertension, testicular atrophy, and skeletal malformation, anemia, and liver, kidney, and brain damages. The slow inhalation of copper causes the lung cancer. So the polymer, that is the chelating ion exchange process, is the powerful technique to removal of heavy metal from the environment. This chapter deal with the explore ion exchange properties, synthesize copolymer resin by batch equilibrium techniques. In chelating ion exchange study, metal ion uptake of the resin was determined at 3 different varieties. The variables such as different electrolytes and their different concentration, different shaking time, and different pH of the solution. For that, I have taken the 5 metal ions: copper, nickel, cobalt, zinc, and lead. Now for that ion exchange, I have electrolyte, 4 types of electrolyte I have used: the sodium nitrate, sodium sulfate, sodium perchlorate, and sodium chloride. Now 5 metal ions I have used, that is lead nitrate, nickel nitrate, zinc nitrate, cobalt nitrate, and copper nitrate for this ion exchange properties. Now these are the graph. In that is the first graph, I have used the sodium nitrate as a electrolyte. From this, the graph shows copper and nickel ions have the high uptake capacity as the concentration of sodium nitrate is increases. As the concentration of sodium nitrate increases, there takes place the high uptake capacity of copper and nickel ions as compared to the cobalt, zinc, and lead. Again, in second graph, I use the sodium chloride as a electrolyte. As the concentration of sodium chloride electrolyte increases, the copper and nickel have the high uptake capacity as compared to the other 3 metal ions. Now in third graph, I use the sodium perchlorate. In sodium perchlorate also, the copper and nickel have the high
Please
uptake
conclude.
capacity.
Sir, time is over. Please conclude.
Okay, sir. Okay, sir. Our fourth graph, that is the sodium sulfate. I have taken the electrolyte. As the concentration of electrolyte increases of sodium sulfate, the uptake capacity is less of all metal ions. That is distribution ratios of polymer and solution. That is the copper, nickel, cobalt, and zinc required the 5 hours for the establishment of equilibrium, whereas the lead ion required the 6. Okay. Now polymer 2,4-HSC have been condensation polymerization of 2,4-dihydroxyacetophenone, catechol, and with the formaldehyde in the presence of acid catalyst. By using the empirical data, empirical formula and empirical formula weight have been assigned to the polymer resin. The determination of molecular
Please
weight.
follow the time is
Okay,
assigned.
yes, sir. Yes, sir. 1 minute, sir. 1 minute. The determination of molecular weight of polymer resin have been carried out by the conductivity titration in non-aqueous media with the help of infrastructure. Various functional groups present in the polymer were determined. The spectra have been interpreted to study the various types of proton in the polymer resin. The exact morphology and structure of polymer resin sample was investigated by scanning electron microscope. This polymer is selective chelating ion exchange resins for the certain metals. Or for that, the polymer have shown the higher selectivity for copper and nickel as compared to the other 3 ions, metal ions, that is cobalt, zinc, and lead. Thank you, sir.
Okay, can you open your NMR spectrum?
Yes, sir.
Go back.
Yes, sir.
Okay. You see, aromatic bridge CH2 methylene is showing NMR value 6.0 to 6.5. Why these protons are more desilted?
Yes, sir.
Why these protons are more desilted? Actually,
methylene.
generally,
Yes, sir. Okay, sir.
Okay. Explain. Why these protons are more desilted?
Methylene proton. Okay, sir. Methyl
The value of
proton.
that proton is higher as expected.
Aromatic proton, that is unsymmetrical patterns, have the high values.
No, that is not an aromatic proton. That is a CH2.
It's
not actually aromatic.
Okay. Yes, sir.
Okay, sir. No problem.
Okay. Thank you, sir.
Next, Dr. Harpreet Kaur.
Well,
Dr. Harpreet Kaur,
Yes, sir.
are you here? Please share your screen and present yourself.
So his PPT is so I want to know whether PPT is visible.
No.
One minute.
अरे जीवन ये ताई दिमाग वाली कितने देखा हूँ मैं सोचा वाली देखी
So is it clear now?
No, madam.
No.
Now?
No, actually. Are you having
But
some
I'm sharing
problem?
here.
No,
Sir,
please share your
actually, in Punjab, there is some problem that government has stopped the network. I'm just trying my level best because उन्होंने ब्रॉडबैंड भी अब स्पीड कम कर दी है. मैंने पहले भी रिक्वेस्ट की थी कि मेरा पहले करवा दो. आई डोंट नो, मे बी उसी वजह से आ रही है नेटवर्क प्रॉब्लम कि मैं शेयर नहीं कर पा रही हूँ.
Okay, take the next presentation of next candidate. Madam, still
Sir,
then,
it is very
yes.
yes, sir. I
Till then,
know that,
yes,
but
please close all
I'm
the apps first, and
sharing
then,
the screen.
no, it is not visible.
But
Please
it is
reset your
visible to
device.
me.
Please reset device.
Yes, sir.
Until
It is
that,
visible to
the
me.
next candidate will present. Miss Manisha Golcha.
Yes, sir. Yes, sir. Am I audible?
Yes, madam.
Yes, you are audible.
Sir,
Can
now,
I see my screen?
Yes, start.
so I think it is now.
Sir, is my screen visible to you?
It's in progress.
It is visible, sir?
Yes.
Can I start?
Yes.
Okay, sir. A very good afternoon to one and all. And I am Dr. Manisha Golcha, Assistant Professor, Department of Physics, Brijlal Biani Science College, Amravati. And I am here to present my research work on the topic optimizing structural and electrical properties of ZNO-PS and ZNO-LDP thin films with ZNO nanoparticles. The motivation behind the research work is that the evolution and development of the civilization have always been associated with development of newer materials, simply because the advancement of society always create the need for the improvement in the existing materials. Same was the motivation, and we tried to create a new class of materials, that is polymer nanocomposites. The polymer nanocomposites are nothing but the composite materials that comprises of nanometer size inorganic nanoparticles, which are typically of the range of 1 to 100 nanometer, and they are uniformly dispersed in the fixed polymer matrix. In this piece of research work, the effect of ZNO nanoparticles in varying weight percentage, that is starting from 0.5 to up to 5 weight percent, we have prepared LDP and polystyrene thin films by solution casting technique. The prepared sample were characterized with XRD, FTIR, SEM, and also the DC electrical conductivity was investigated. Polymer inorganic nanocomposite thin films with ZNO
Madam,
nanoparticles.
please, madam, your presentation is not visible.
Sir, it is not visible.
No.
Actually, two screens are shared right now. That's why no one screen is visible.
Okay, initially it was visible, sir.
Yes, yes. Dr. Harpreet Kaur has also started sharing
So
his
because
screen.
of that, my screen was not visible.
Yes, yes.
You'll have to wait for a minute
Yes.
till I present my work.
Okay.
Because I have started, sir, actually. If she will start to present, then obviously my PPT will not be visible.
Okay, Dr. Manisha, continue.
Continue.
Sir, my PPT sharing has been stopped.
Yes.
No. It's visible.
No, now it is visible. It is visible now.
Okay, sir. I'm not able to see actually. Is it visible, sir?
Yes.
Yes.
Continue.
Okay. So I have prepared the polymer inorganic nanocomposite thin films with LDP and polystyrene with varying percentage of the zinc oxide nanoparticles in it. So sample were prepared by solution casting technique. In this, we have dissolved the LDP in xylene and PS was dissolved in toluene, and they were mixed with the help of magnetic stirrer with a heat of around 70 to 80 degrees Celsius. Then the melt was poured on the clean glass plate. It was allowed to evaporate on the room temperature, and then the films were washed with the ethyl alcohol and used for the further characterization. So here we can see that we have characterized with XRD. I have just quoted 0.5 and 5.8% of both PS and LDPE thin films because there was no significant change in the peaks. We can see that here the characteristic peaks of PS and LDP are present, and also the prominent peaks of zinc oxide, that is at 31.3, 34.2, and 39.5 are present, which shows that the presence of ZNO nanoparticles have not created any peak shift, and also there is no as such the broadening or increasing in the peak. So it suggests that the ZNO nanoparticles are incorporate in the composite form. So the peak's intensity in PS are found to be increased, which shows the more crystallinity. In same, we have characterized the it with FTIR, and here also if we compare with 0 weight percent of either LDP or polystyrene, we can see that the prominent peaks of both the polymers can be seen as it is. No shifting is there, but around 500, 400 centimeter inverse, we can see there is an increase in the hum, which shows the presence or incorporation of the zinc oxide nanoparticles in the substrate. After that, we have also did this scanning electron microscopy, and again I have quoted only the lower and higher percentage of doping, and we can see here that in this case lower percentage they are apart, and as we increase the weight percent, they get agglomerated. And I have done the DC electrical conductivity of the material. And during the DC electrical conductivity, I have checked the conductivity with varying weight percent. And I found that the conductivity is increasing in both case of LDP and PS. Here we can see that for 0 it is less, and it is increasing for LDP also and PS also. But as you can see that it is more found to be prominently effective in polystyrene as compared to LDP. So the reason for this increase in conductivity may be because of the tunneling characteristics, the distance in the closest separated points of the adjacent particle, is few nanometers. So the conductivity appears to be the result of electron transport between the nearest neighbor connections, while denote the dominating conducting elements across the inner particle tunneling distance. So I can say that overall conducting mechanism is because of electron transfer through the ZNO aggregations, and also maybe due to the variable range hopping. So I can say, sir, that during my research work, I was assuming that polymers are like insulators, but when we dope some material in it, we can tailor its properties. And obviously, these polymers can be more beneficial than other metal oxides or semiconducting, because it will give coin a new term known as polytronics, and it will be more beneficial because it will be simple, inexpensive, it will be environment friendly, no high temperatures will be required, and also the mechanical properties of the polymers that are lightweight, flexible, durable, can be recycled, can be monitored with the incorporation of the zinc oxide nanoparticles. So in this research, I found that the properties are enhanced. Also in the future work, I tried to study the sensing properties. As the result of DC electrical conductivity, I have seen that no sensing was such done at LDP ZNO composite, but PS ZNO nanocomposite shows room temperature sensing of ammonia in the case. So this is all from my side, and I am really very much thankful for all the members present over here and the organizer for giving me the chance to present my piece of research work. Thank you, sir. Hello.
Okay, any question? Okay, please next.
Thank you,
Dr.
sir.
Harpreet Kaur.
Should I start now?
Yes, yes. Share your screen.
Yes, sir. Is it visible now, sir?
Yes.
Okay, good afternoon to all of you. The topic of my presentation is synthesis of copper oxide polyaniline nanocomposites for potentiometric sensing of metal ion. I'm Dr. Harpreet Kaur, Assistant Professor from Punjabi University, Patiala. Introduction. Sir, is this? I don't think
Madam,
so.
actually PPT is not visible. Yes, now it is visible.
Okay, sir. Now it is visible, sir?
Yes.
Okay, introduction. As we know that core shell nanocomposites are spherical cores for particular compounds surrounding by shell. In comparison to single component counterparts, core shell possess better properties, and the enhanced properties depend upon the material of core and shell. So here I'm going to represent synthesis and its application. The synthesis of core shell nanocomposite. For the synthesis of core shell nanocomposite, 10% solution of aniline in 1 molar in ice cold condition and 0.2 gram of copper oxide is added to it, followed by addition of 5 milliliter of methanol and 1 milliliter of non-ionic surfactant Triton X100. The solution was agitated for half an hour by carefully maintaining the temperature below 10 degrees Celsius. Then 10 milliliter of 0.1 molar potassium persulfate solution was added drop-wise. which initiate the polymerization of aniline on the surface of copper oxide, and the mixture is stirred for 4 hours. Dark green color product is produced, as I have also given in the PPT. The product was analyzed by using various analytical techniques. The first is EDS analysis and FESM microanalysis. The elemental composition of the compound is 66% to 16% copper to oxygen, and rest is carbon due to the polyaniline. The morphology of compound is granule-like morphology, and the particle size as determined from the histogram is 68.8783. This is the average particle size of the prepared product. Then the FTIR analysis show that there are peaks at 534.27 and 587.5 centimeter inverse. These peaks may correspond to the copper oxide, while the peak at 1216 and 1294 centimeter inverse correspond to the carbon-nitrogen stretching mode of benzoate ring. The peak at 1491 and 1566.7 centimeter inverse correspond to the benzoid and quinoid ring of polyaniline. The UV visible spectra of the nanocomposite is also given. The two main peaks are at 331 nanometer and 481 nanometer. 331 nanometer peak correspond to pi to pi star transition of the benzoid ring, while the 481 the peak at 481 nanometer correspond to the pi to pi star transition of benzoid to quinoid ring. The other peak is at 241 nanometer, which correspond to the copper oxide. The DLS spectra analysis is also given here. The value of zeta potential comes 2.6 millivolt. The life scan of the then the membrane is prepared for finding the potentiometric application of the ring. The the cell is set up using the silver chloride electrodes as the reference electrode, and copper polyaniline membrane ring is prepared by the reported method. And it has been found that we have set up the cell by taking the internal solution of nickel ion as the 10 raised to power minus 2 molar, and with a fixed concentration, and varying concentration of outer solution 10 raised to power minus 8 molar to 10 raised to power minus 1 molar. It has been found that from the various instrumental techniques that the nickel ion is more sensitive to this copper polyaniline nanocomposite membrane. The potentiometric studies of this has been shown. It is again very sensitive to the sensory formed is very sensitive to the nickel ion as compared to the other ions. Then the effect of different internal solution concentrations, effect of pH, lifespan also has been determined. The lifespan of a membrane is 2 months. Then this membrane is used to detect the concentration of nickel ion in cocoa powder, and it has been found that in different samples the concentration has been sensed very even up to the 10 raised to power minus 5 molar. This application is also used to find in the lab for the copper oxide polyaniline nanocomposite based electrode is used as an indicator electrode for the titration of the copper sulfate versus EDTA. Sorry, nickel sulfate versus EDTA titration, and it gives a good effect. The results are shown in the screen. That's all. Thank you.
Yes. Any question?
Actually, I have very briefified this. If you have any question, then please.
Okay. If no question, please next.
No question, please.
Thank you, sir.
Proceed. Next, Dr. Prachi Bunde. Dr. Corman, please stop sharing your screen.
Yes, I'm trying, sir. Again, there is a network problem due to which, yes, I have stopped, but it is, yes, I think
Yes.
it is now.
It stopped.
Actually, yes, okay, okay.
Dr. Prachi Bunde. Last call, Dr. Prachi Bunde. Okay, go for next. Dr. Prashant Lihitkar.
Yes, sir. I'm hearing.
Share your screen and
Can
start.
I share my screen?
Yes, start.
My screen is visible to all?
Yes, yes, yes.
My voice is audible?
Yes, sir, you are audible.
Yeah.
Start.
Yeah. Thank
Start
you.
your presentation.
Good afternoon, everyone. Myself, Dr. Prashant Litkar from Lokmanya Tilak Mahavidyalaya, Bani. I'm going to present my work on green root synthesis of silver nanoparticles using marigold flower extract. So this is the outline or abstract of my work, where we have used a marigold flower extract. My voice is audible?
Yes, sir, yes. Continue.
Okay. So this flower extract was analyzed for the presence of different phytochemicals like alkaloids, flavonoids, quinones, sugars, and I have shown the phytochemicals which are present in the table. Then this extract is used as a capping agent to prepare silver nanoparticles. Okay. So the origin of problem is we know that the nanoparticles are known for their size and shape-dependent novel properties, and nanoparticles are also found to have the potential applications in diverse area. The traditional methods of nanoparticle synthesis that involves the various types of expensive and toxic chemicals, and using the green chemistry concept, we can avoid the use of these toxic chemicals that act as a reducing agent or capping agent, and sometimes some solvents are also used. Okay, so these nanoparticles which are prepared by using this green chemistry route are found to be biocompatible. The objective of our work is to prepare marigold flower extract in aqueous or ethanol medium. Then to analyze this plant extract for the presence of various phytochemicals. Then to use this extract for preparing silver nanoparticles. Analyze the silver nanoparticles for their presence by means of optical techniques, visible spectroscopy. Then to study the effect of various parameters like concentration of salt, type, time, pH on the size and shape of the nanoparticles. Then to investigate the mechanism of the formation of silver nanostructures. Then, as we know, why we choose the nanomaterials, as you know, the size of the nanomaterials that change the everything. Okay, and I'm going to not detail about this property that change at the nanoscale, as we all know. The most important thing is that by decreasing the size of the nanoparticles, hello.
Yes, sir, you are audible. Start. Continue.
Okay. So by decreasing the size of the nanoparticles, the surface to volume ratio is going to increase. That is the most important thing. We know the different methods to prepare these nanoparticles, which are very well known. One is the top-down method, where we can break down the bigger particles into a small size nanoparticles. And the second method is known as the bottom-up method, where we can build up the nanomaterials by putting atom by atom. Okay, and I have shown the comparison. So we have followed this bottom-up approach by forming the nanoparticles atom by atom or molecules by molecules. So why we choose the silver nanoparticles? Just a minute. I'm going to. So why silver nanoparticles we select? So you can see there are different applications of silver nanoparticles in biomedical area, and marigold flowers, which is also found to have different biomedical properties, like repels insects like mosquito paste. It is also used in different skin conditioners, and many more are there. So when we go through the literature, this literature says that the plant can be used as a source to get the different phytochemicals, like different parts, leaf, stem, fruit, rose, okay, root. So we all choose the marigold flowers, and we have prepared the extract. And by mixing the plant extract and the metal salts, different phytochemicals are present in the extract can reduce these metal salts, and we can get the nanoparticles. Okay, so I have shown this schematic, which is obtained from the source, which I have mentioned there. How do these phytochemicals helps in to get the nanoparticles of the metals. Then here I have shown the methods of preparation flowcharts. First, we have prepared the extract from marigold flower, and then by means of success method as well as by heating method. Then we have used this extract for preparation of the silver nanoparticles. Okay, silver nitrate used as a source of silver with 0.01 molar concentration. Here in the table, I have shown the analysis of different phytochemicals present in the plant extract. Okay, and the table shows that alkaloids, proteins, flavonoids, phenols, glycosides, and phenols are present in the plant extract. Okay, and basically the interaction of these phytochemicals with silver metal atoms that occur through various bonds. So therefore, we have also mentioned the functional group which is present in the different, it is general, it's not a specific actually. We are not able to analyze the different types of these phytochemicals or biomolecules. Okay, but what we understand that these phytochemicals, they are having different functional groups, and that functional groups helps to reduce and stabilize the nanoparticles. So here are the discussions, results and discussion. In the image, you can see the photo of silver nanoparticles for different ratios. Okay, so first sample bottle, which is of silver nitrate solution. Then the second bottle is of marigold flower extract, and other fours are the silver nanoparticles which are prepared using different silver nitrate to extract ratio, that is 1:1, 2:1, 3:1, 4:1 volume ratio. Okay, and the below figure will show the absorption spectra of these silver nanoparticles for different ratio. The peak at absorption maxima at 414 and 638 nanometer is observed increasing with increase of the silver salt concentration that we can see. Just a minute. Then absorption spectra for silver solution for 4:1 that show the maximum intensity after 24 hours. The marigold flower extract that show the absorption at 500 nanometer, which is redshifted in 1:1 ratio and disappeared in other ratios. The visual change in the color that I have mentioned from yellow to brown, they indicate the formation of silver nanostructures. Actually, for spherical nanoparticles, we observe one surface plasmon peak, but we observe two peaks, and that may be due to the different shapes of the silver nanostructures. Then here we have shown the effect of time on the absorption spectra for various ratios. Okay, A, B, C, D, that shows the absorption spectra for 1:1, 2:1, 3:1, and 4:1 ratio. Okay, so reaction time, which is found to be crucial parameter which affect the synthesis of silver nanoparticles. At lower concentration of silver salt, that is the figure number A, we observe the two SPR peaks at 420 and 640 nanometers. Initially after the 30 minutes, and then it disappears after 1 hour. And the absorption peak that is observed at 5 nanometer due to X-ray that found to be rate shifted. Then on increasing silver concentration, that is from 66% to 80%, that is in 2:1, 3:1, 4:1 ratio, the two SPR peaks are observed at 1 nanometer and 630 nanometer, increases its intensity with time. Then absorption intensity of two surface plasmon peaks found to be maximum at the highest concentration of silver salt, that is in the 4:1 ratio that you can see in the figure. This shows that more stability of the silver nanostructure.
Please, sir. Please, sir, conclude your presentation.
One or two slides. So this shows that more stability of the silver nanostructures at the maximum concentration of silver salt. Okay, and the two different surface plasmon peak, that is due to the formation of different shapes of the nanostructures. Okay, so here I have shown the references, the absorption peak or surface plasmon peaks for various shapes of the nanostructures from the other sources, and this phytochemical they use as the reducing reagents as well as the stabilizing or capping reagents. So here is the conclusions. Silver nanoparticles which are prepared using marigold flower extract by simple rule. Silver nanoparticles formation is confirmed from the color change of the solution. The silver nanoparticles formation is also confirmed from the optical investigations. The absorption spectra of silver nanoparticles shows that absorption intensity increases with an increase in the concentration of silver salt, indicates the growth of silver nanoparticles. Then two surface plasmon resonance peak at 420 nanometer and 640 nanometer in the absorption spectra, that may be due to the formation of different shapes other than spherical, rectangular or rod shape or nano plates, because we are not taken their microscopy study. So we have just proposed. So, and the effect of silver salt to marigold extract shows that the 4:1 ratio will be the most stable silver nanoparticles. So these are the references. And with this, I thank you, the organizing team, for giving me a chance to present my work. Thank you. Any questions, please?
Any questions from audience? Nice presentation, but it was too lengthy, sir. Okay, go for the next.
Okay, thank you.
Dr. Yogita Bodke.
Just I will do this.
Good afternoon, sir.
Share your screen.
Yes.
Start your presentation.
Sir, I'm audible?
Yes, you are audible.
Okay, thank you.
Share your screen.
Is it showing, sir?
No, not yet.
One minute, sir.
Yes.
Now, in my presentation, sir?
Yes. It's visible.
Okay, thank you.
Just publish this slide.
Yeah. So, good morning. Myself, Dr. Yogita Botke from Guru Nanak College of Science, Ballarpur. So the topic of my presentation is synthesis of an chalcone bearing the quinoline menthe. It's a green approach just by grinding the reactant and testing its antimicrobial activity. So this is the content of my presentation, that is the introduction, material and method, experimental one, results, biological screening, and result and discussion. So what is green chemistry? Already you know that we are synthesizing this chalcone by using the mortar and pestle and grinding the reactant without using the solvent, that is the ethanol or methanol. So this is the green chemistry concept towards the sustainable development. So this is the important of solvent-free reaction. Many reactions, you know that the Friedel-Crafts, aldol, and so many reactions can.
Madam, you are not audible. Hello.
Dr. Yogita ma'am, are you there? Sorry, she stopped sharing his screen. Let us go for the next.
Sir,
Dr. Shraddha Pandey.
Sir.
Dr. Yogita Bodke, are you here?
Yes.
Yes, I'm sharing my screen.
You please,
Now,
please continue.
so we synthesize the different quinoline derivatives, and by synthesizing the different quinoline derivative, we'll couple these reactions just by grinding these two. So this is the synthesis.
There must be
Mhm.
network issue.
No, there is some issue.
Yes. Issue with the network.
Quinoline derivative, aldehyde of quinoline. We also get the NMR peaks, and from the NMR peaks, we conclude that it's at the molecular formula having the 14 hydrogen, and we get the different peaks
Madam,
here.
madam, please share your slide.
I'm sharing the slides. Sir. Okay, sir. Okay.
Now it's working. Go ahead.
So we carry out the spectral analysis. We take the IR spectra as well as the NMR spectra of the only one compound. From that, we can find out that the molecular formula of that compound is observed with the related. These are some IR. These are some NMR spectra of the synthesized compound. These are some NMR spectra, and from after that we carry out the some biological screening of that compound, chalcones. So we are getting this antimicrobial as well as the antibacterial. We find out the antibacterial activity against the E. coli as well as the S. aureus, and we are getting the better zone of inhibition there. These are some results, and after that the conclusion is that the present synthesis compound that we derived the chalcone by without using the solvents like the ethanol or methanol, but just by grinding it in a mortar and pestle, and we confirm the characterize that compound by means of an IR and NMR activity. So the conclusion is that the newly chalcones which were synthesized without the solvents, we get the very good yield, and also confirmed by the spectral characteristic. So, and also we find out it is a very good antimicrobial agent. So, with this, I conclude. This is actually the synthesis picture of the chalcones having very red in color. These are some references, and this is, thank you, sir.
Okay, any question? Okay, next
Madam,
participant.
Madam,
Yes,
you
sir.
don't have used any control there while studying antimicrobial activities.
Yes, sir.
Do you have used any control?
And I'm not getting your question, sir.
Do you have used any control while studying antimicrobial activities? Or any standard drugs which is already is there in the market?
No, we are not comparing with any standard drug. We already do this activity with the synthesized compound.
Okay. Okay.
Thank you.
Go for the next. Dr. Shraddha Pandey.
Yes, sir. Am I audible, sir?
Yes, you are audible.
Okay. Can I share my screen?
Yes, sure. Okay, start presenting.
Madam, you are not audible.
Ma'am, you are not audible at all. Please do check your mic.
Unmute yourself.
Yes, sir. Yes. I unmuted myself. Sorry for inconvenience. Now am I audible, sir?
Yes, continue.
Yes,
Continue.
yes. Sir, I am Dr. Shraddha Pandey from Department of Physics, LAD and SMT RP College for Mumbai, Nagpur. I'm working as assistant professor in this department. And today the topic of my oral presentation is structural characterization of glasses prepared using biomass fly ash. This is an attempt to convert a bio waste into a source of silica. What is biomass and what is biomass fly ash? In starting, I'm going to present biomass ash can be explored as a source of silica for the glass formation. It is from best from west. Now, what is biomass? Biomass ash is obtained from burning of agricultural waste. In our region, there is a number of thermal power plants and sugar plants, factories also, and the waste material generated from these factories like sugarcane bagasse and rice husk, and this sugarcane bagasse and rice husk are used as a fuel in thermal power plant and generating the ash. That is the biomass fly ash. Now I exploring this biomass fly ash as a source of silica for preparing glass composites. As we can see, there is a number of biomass fly ash. The large variation in biomass, that is fuel, gives the variation in ashes also. In this particular study, I'm using bagasse ash and rice husk ash for the glass preparations. And this particular ash is procured from Purti Thermal Power Plant, Bela, District Nagpur. And for this glass preparation, why it is used for glass formation? Because the procure of silica, it is a more hazard for R also. And by using boric acid as a glass former and zinc oxide, along with these two glass formers, I am using sugarcane bagasse ash and rice husk ash for the preparation of glass sample, as the chemical analysis of biomass ash, both the type of ashes, concludes that it is having SiO2, that is silica content is more than 50%. That is, it is more suitable for using silica as for the glass formation. The method I have used to prepare the glasses, it is melt quench technique. That is, this is the glass furnace, and all the biomass fly ashes, rice husk and bagasse ash, is mixed with the boric acid and zinc oxide in proportion of 2:1, and by melting this in electrical furnace having temperature range about 1200, we can get the melt of glass. And this is the experimental setup for this glass production. And these are the glass sample prepared for the study. These are glass samples are prepared from sugarcane bagasse ash, and these are the samples are prepared from rice husk ash. Further, the formation, the structure of glass samples are studied by using the basic, using some basics like characterization, such as X-ray diffraction. So you can see these are the X-ray diffraction patterns of different glass samples I have taken here. There is no sharp presence of, no peaks are present here, and this shows the formation of glass. Why glass? Because glass is a super cool liquid and it is amorphous in nature. That's why it's showing, confirms the glass formation using XRD. And again, the FTIR shows the presence of silica that we are attempting, that is the biomass ash as a silica source. This peak position 420, 450 is showing the SiO stretching mode. Again, formation of boric acid is present here, and again the formation of boraxyl rings and hydroxyl group is also present there, which shows the formation or which shows the source of silica in bagasse ash. Against the density and molar volume is changing with, yes. Hello, am I audible, sir? Hello.
Yes, you are audible.
Yes.
Continue,
This
sir.
density and molar volume is inversely changing. That is, density increases with decrease in volume. It is because of the silica SiO bond formation is there, which gives increasing the packaging density, which gives the increase in density. That is, more dense structure is formed using the bagasse ash and rice husk ash. Some of the properties I have discussed here and studied here for the glass samples. These are the elastic moduli. That is, the stress or compressibility of the glass sample is, we can check with this study, that is the elastic moduli. And this moduli is showing the increasing trend. That is, as we increase the content of biomass ash, the moduli also increases. That means it's giving the strong structure. Again, along with this elastic moduli, I also I also studied some microhardness and Poisson's ratio properties using ultrasonic velocity, that is pulse echo method, using some pressure that at 4 microhertz range. And this is the micro hardness and Poisson's ratio graph, which showing micro hardness is also increases and Poisson's ratio with the content of increasing content of bagasse ash. As the Poisson's ratio is increases, that means the compressibility of glass sample is more and micro hardness will be less. This is the conclusion part. The X-ray diffraction pattern shows the presence of the amorphous nature of glass and silica. And again, density of glass structure increases with the decreasing volume, and ultrasonic velocity were measured at room temperature using the pulse echo method, which shows the increase in comparative stable structure of glass sample. And again, micro hardness of glass sample were also increased with the increasing of biomass ash contained. And thus we can use biomass ash as a source of silica for the production of glass samples. These are some references I have used for this particular study. Okay, thank you, sir. Thank you from my side.
Yes, any question?
Have you checked the strength of your samples in any laboratory?
Yes, sir.
Have you checked strength of your samples in any laboratory?
Yes, sir. I have checked in VNIT, and the ultrasonic velocity properties are checked in the laboratory, and from this I have obtained these results of micro hardness and Poisson's ratio, sir.
Okay. You are not mentioned the name of that particular laboratory where you checked.
Okay, sir.
Okay.
I will mention in future, sir. Okay. Thank you, sir.
Nice. Go for that.
Next.
Thank you so much, sir.
Good afternoon, sir. Excuse me, sir, am I audible?
Yes, ma'am.
Yes.
You are audible and your presentation is visible. Please continue yourself.
Okay, thank you, sir. Good afternoon, one and all. I am Ashwini Jaggal, a research scholar from Department of Chemistry, Karnataka Science College, Dharwad, pursuing PhD under the guidance of Dr. K.S. Katki. The presentation title goes by Environmentally Sustainable Synthesis and Multifaceted Biological Evaluation of Coumarin 1,2,3-Triazole Derivatives. Coming to the introduction part. So, COVID-19 showed how quickly health crisis can spread across the world. Similarly, antimicrobial resistance is a global health threat, making infections harder to treat. So therefore, by taking this as a sign of alarming sign, we have chosen certain heterocyclic moieties, which is coumarin and triazole, coumarin an oxygen-based heterocyclic compound, which is very commonly known for its various biological properties, such as antimicrobial, anti-inflammatory, and so on. Next, we have chosen triazole, which is coming to the azole family of heterocyclic moieties. Again, these are the pharmacophores which are having, which exhibit various biological applications. And I have used the Nobel Prize inspired click chemistry reaction, and I have shown represented it in the picture. So click chemistry reaction is catalyzed by copper metal. So that is copper azide alkyne click reaction, cycloaddition reaction, which is an efficient and selective approach for synthesizing these moieties. And I have chosen the hybridization technique, molecular hybridization technique, to go forward with this particular reaction. So the objectives of my work is to synthesize coumarin triazole using click chemistry application, then investigation of antibacterial efficacy against various bacterial strains. Anti-inflammatory activity was also gone through at the same time. And lastly, the antioxidant potential using the DPPH assay. After the biological evaluation, we carried out molecular docking studies to understand the binding interactions. And at the same time, lastly, we have carried out ADMET properties, that is adsorption, digestion related properties, to determine the drug likeliness of the synthesized derivatives. So directly coming to the scheme of my work. So here basically we have very basic reaction where we have taken the bromo derivatives of the coumarines, converted into azide, so which is the first requirement for a click chemistry reaction, which is an azide. Then I have taken methyl aniline, propaxyl bromide, terminal alkyne formation, and together using copper catalyzed using THF water system, we have got the derivatives. In total, I have prepared 7 derivatives and they are listed as below. So this is the schematic approach of my research work. Next, the characterization, all the characterization of the derivatives were done. I have only selected 8D this is the proton NMR, this is the C13, this goes the FTIR, and this is the ESI mass spectrum, electrospin mass spectrum. Then coming to the antibacterial activity. So we had tested the derivatives for 4 different bacterial strains, that is Staphylococcus aureus, Staphylococcus pyrogenes, Pseudomonas aeruginosa, and Salmonella typhi, and among which 8E, that is 5,6 benzofused. Here we have 8D, here we have 8E, which is 5,6 benzofused. So in that we have got almost taking the control drug, that is or the reference drug streptomycin. It was compared with streptomycin and we had got very good results for 8D compound. Next, coming to anti-inflammatory activity. So in different inflammatory reactions, diseases such as arthritis and all, these are certain examples of the inflammation reactions. And in order to check the anti-inflammatory activity of this derived compounds, I have shown the graphical representation, and the anti-inflammatory activity was the reference standard drug which was used was diclofenac sodium, and here 8E again, which is 5,6 benzofused derivative, showed highest IC minimum inhibitory value, that is approximately around 28.75 microgram per ml. Next, we have the antioxidant activity, which was carried out by DPPH assay, a very common assay to carry out the antioxidant activity, wherein 8D, which is a chlorine substitution at 7th position, showed excellent antioxidant activity compared to that of ascorbic acid, which was used as a reference drug. And this is the graphical representation. Next, coming to the molecular docking studies. So molecular docking studies was done to understand the binding interactions, the pi-pi interactions or alkyl, which has been represented here, as also the hydrophobicity, and all the interactions have been shown. So I have done the docking for PGDS. So PGDS is prostaglandin D2 synthetase, and DHPS, so that is a dihydropterate synthetase. So this was for 8D, it showed a strong binding affinity, that is minus 9.6 kilocalories per mole, and for 8C it was minus 9.8 kilocalories per mole, which brought us insights that this can be used for better biological activities. Then we have gone for ADMET analysis, wherein compound 8E and 8C showed high intestinal absorption. And these are the radar plots, also called as the spider charts, and moderate clearance and no blood-brain barrier penetration was observed. So here I have chosen the boiled egg model to check the biocompatibility or the drug likeliness of my synthesized derivatives, wherein again here 8E showed excellent bioavailability compared to the rest derivatives. These are the conclusion from the extensive biological evaluations. We could conclude that 8E could be a very good could make a very good potent future drug molecule. And by ADMET also, 8E and 8C demonstrated high bioavailability and optimal drug likeliness. And the future scope of my work would be to combination therapy by using the beta-lactams or fluoroquinones, or in combination to reduce the antimicrobial resistance. And I would like to I would like to give my gratitude towards Narsamma Arts, Science and Commerce College for giving me this opportunity. And I would like to thank the jury members for their kind patience. Thank you one and all.
Okay, any question from the audience?
Nice presentation.
Thank you, sir.
Can you please show me the reaction system once again?
Sure, sir.
What could be the kinetic of this reaction?
Kinetic studies, you're asking me, sir.
Yes, yes,
No
yes.
idea, sir.
What factor has increased the rate of reaction?
So in the matter of catalyst, you're asking me, sir?
Yeah.
Definitely, it should be it should be copper sulfate, sir, pentahydrate.
Okay, good. Okay, good. Okay, go for the next one. Miss Jayashree Solanki.
Am I audible, sir?
Yes, you are audible.
So, good afternoon, everyone. I'm Jayashree Solanke. I'm from Institute of Chemical Technology, Bhubaneswar, doing PhD under the guidance of Rambabu Dandela. So, today my topic of presentation is iodine TBHP promoted cross coupling of N-hydroxysulfonamide and disulfide to synthesize unsymmetrical thiosulfonates. So, this is my abstract. First, what is the thiosulfonate first? So it is the organic compound which is characterized by the functional group RsSO2R. So as we know that organosulfur compounds are very essential in medicinal chemistry, and it has biological activities. Especially we are talking about the thiosulfonate and drug discovery and material science also, which and some of the compound which I've mentioned here, useful in prostate cancer, estrogen analog, anti-cancer treatment, antiplatelet therapy, so and so on. So and the synthesis, moving towards the synthesis, traditional synthesis of the thiosulfonate. The traditional synthesis of thiosulfonates includes the oxidation of disulfide, sulfonyl hydrazide coupling, nucleophilic substitution of sulfonyl halide. But the traditional sulfonylating agent was unstable and expensive, and which are very odorous and having noxious smell, and which are not environmental unfriendly also. They are environmentally unfriendly. And a recent method also, like BTIB mediated synthesis of thiosulfonate, copper catalyzed synthesis of thiosulfonate, and water and polyethylene glycol 400 mediated synthesis of thiosulfonate, but which are again having problems related to requirement of metals, excess oxidant, and harsh conditions. As we know that thiosulfonates are very important and essential in organic synthesis also, like electrophilic. It is serves as electrophilic sulfonating agent and precursor for the sulfones and sulfonamide also. Sulfonamide is another group which is also a biological active, which is also biological active molecule. And so on. So here I mentioned some biological activities of thiosulfonate. Moving towards the methodology, here I mentioned the previous work, and here is the our work. So previously I've talked about the traditional methods, and this, nowadays we are using methods, and so there are so much problems handling that reaction. So moving on the reaction, we synthesized some starting material, to escape from these all these byproducts and toxic metals. So we have synthesized one starting material here using sulfonyl chloride and hydroxylamine hydrochloride in presence of weak base, and water methanol system 2:1. We have synthesized N-hydroxysulfonamide, which is our starting material. By using this starting material, we have synthesized the thiosulfonate using the N-hydroxysulfonamide, phenyl disulfide, and using the BHP, I2, and acetone as a solvent within 2 hours at 70 degrees centigrade. Here is the optimization table we have done so far. So we have used different iodine analogs like PIDA, potassium iodide, N-iodosuccinamide, tertiary butyl ammonium iodide. Everything we have used, but we got to know that iodine is giving more yield as compared to the others. And again, we have screened the oxidant also, TBHP, ditertiary butyl hydroperoxide, H2O2, cumin hydroperoxide, potassium persulfate, oxygen balloon we have used. We got TBHP, that we found that TBHP is giving more yield. Again, solvent screening also we have done with acetonitrile, 2-methyl THF, ethanol, toluene we have used. And the optimized solvent was acetonitrile. We have got 92% yield. So here the optimized reagent of the scheme, we have got more yield as compared to others. Using the optimized substrate and use that chemicals, we have synthesized these of some substrates, like 29 substrate we have synthesized. And as we can see, electron withdrawing group and electron donating group both are tolerated, but the electron donating group were giving more yield as compared to the electron withdrawing group. We have tried the aliphatic group also. So, but it was giving quite less yield as compared to the electron donating and some withdrawing group. So to confirm, and after that, we have draw the plausible mechanism. The mechanism is based on the literature survey and the GCMS data we have conducted. So in GCMS data, we have found this thionyl radical. On the GCMS data, we have predicted one plausible mechanism. So this is N-hydroxysulfonamide, and our reaction is went through a radical mechanism. So radical initiation starts here. We have used tertiary butyl hydroperoxide as a radical initiator. So tertiary butyl hydroperoxide and reaction of tertiary butyl and hydroperoxide produces iodide molecule, which involves in a reaction, and there's formation of nitrosulfonyl intermediate A. And again, tertiary butyl hydroperoxide radical get involved in the reaction, and there is formation of sulfonyl radical. And again, here at the left side, we have given the heat of disulfide molecule with TBHP. There is formation of phenyl sulfide radical, which again combines with this sulfonyl radical, and there is formation of our thiosulfonate compound. So, and this is the thionyl radical at 109 we have detected in GCMS data. For more confirmation, we gone through the H1NMR and 13C-NMR of all the derivatives. Out of this, I have took the one derivative to show. Here is the data of H1NMR. This methyl group, aliphatic group, comes here at shielded part. 2.43, and these are the aromatic region protons. 8 protons came here. And again, 13C data, the methyl group comes at 21, and these are some aromatic carbon, and it is CH3 carbon group. So, and after that, again, we have given some of our compound which are not up till they are not reported to HRMS data. And here we got the HRMS data of this compound at 312. And in a conclusion, we have developed the metal-free synthesis of unsymmetrical thiosulfonate. And direct, we have done the oxidative coupling of N-hydroxysulfonamide and the sulfide using iodine anti-BHP. We have got the good to moderate yield and broad substrate scope and functional group tolerance. And the mild conditions we have used and extended application to sulfonamide also. The radical pathway mechanism enables the efficient transformation. And the future works we have planned, like opportunities for the more optimization and exploration of new substrate. Acknowledgement. I would like to express my gratitude to Dr. Rambabu Dandela, my guide. I am deeply thankful to the CRG grant for providing me the funding, which enabled us to conduct this research. And I appreciate the essential support from ICT, IOC Bhubaneswar, and thanks to Narsamma College for giving me the opportunity to present my work. Here are some of my references, and this is the article which is published in Chemistry Select Pioneer Journal. And these are some of my research publication published yet. Thank you.
Yes. Any questions from audience? Okay. Next, Mr. Juhi Singh.
Yes, good afternoon, sir. Just give me a second.
Miss Juhi.
Yes, sir. Am I audible?
Yes.
Okay, just give me a second, sir. Is my screen visible, sir?
Yes.
Okay, so again, good afternoon, everyone. My name is Juhi Singh. I'm a research scholar in Department of Chemistry, Christ Church College, Kanpur, under the guidance of Dr. Meet Kamal. My topic of presentation is organic functionalized silica nanoparticles as reinforcing agents in polymer composites. So here's the abstract which I submitted. Basically, my research is all about creating silica nanoparticles from the rice husk ash. In this presentation, I'm going to explain one of the application of using the bio-derived silica as a filler in other polymer composites. So the fusion of organic functionalized silica nanoparticles, which I've obtained from the rice husk ash, it actually enhances the properties of the other polymer composites, such as it enhances the rigidity and the tensile strength of the polymer. Now, the organic functionalized silicon dioxide, which I have obtained from rice husk ash, also enhances the compatibility with the polymer matrix by modifying the surface with the specific organic groups. And now coming to the introduction part. Yes, so there is a significant replacement of conventional polymers like the bulk polymers. So over the recent decades, organic polymers and inorganic oxide composites have increasingly supplanted together to enhance their materialistic properties. If we talk about the advantages of inorganic fillers, so the incorporating inorganic fillers such as silicon dioxide brings several benefits, such as I already told you, enhance rigidity, superior thermostability, and also increase the mechanical strength of the polymer. So if we talk about the benefits of organic polymers, so they are very flexible in nature. They have an ease of processing, and they have the very crucial applications in the biomedical fields. Now, applications in various industries. These composites find extensive applications in industries such as automotives, aerospace, electronics, etc. Coming to the evolutions of the composites, so as the nanotechnology advances, the integration of this into the material science has revolutionized the development of hybrid materials. These materials combines together and give an entirely different and enhanced product which can be used in different areas. So if we talk about the industrial applications or the relevance with the industrial applications, the implications of nanotechnology and hybrid materials are profound for industrial applications. These materials offer durability, reduce its weight, enhance the proper performance, make them ideal for the sectors such as constructions, automotives, and electronics. Next, if we talk about the key feature, the one of the key feature is the increased interfacial area. So now, if we use the nano-sized organic fillers, it will enhance the interfacial areas of the original polymer composites. The incorporation of nano-sized inorganic fillers into polymer matrix significantly amplifies the interfacial areas, and this is very crucial because the larger the interfacial area, the better the interaction between the fillers and the polymer. If we compare it with the the bulk polymers typically exhibit limited properties due to their lack of significant interfacial areas, whereas in contrast, this unique structure of nanocomposites allows the greater performance enhancements, making them preferable for advanced applications in industries such as aerospace, automotive, and again electronics. Coming to the role of inorganic oxides, here I'm talking about silicon dioxides. Alumina oxides can also be used, but my research solely based on the silica, so I have taken this review. Inorganic oxide fillers are essential in the nanocomposites. They play a crucial role in the formation and enhancement of nanocomposites. They provide structural integrity and improve the various material properties, making them indispensable and advanced materials. Now, here I have mentioned three types of silica nanoparticles: the spherical silica, the layered silicates, and the nanotubes as a fillers. Now, the second property which I was talking about is well-ordered structure. Silica particles possesses a very decent, well-ordered structure. I'm talking about silicon dioxide nanoparticles, which contributes to their stability and effectiveness in various applications. Okay, coming to the recent studies on the silica polymer nanocomposites. So I have taken three sources. Like the first one is Altheus et al. From 2007. They focused on the development of transparent polymer nanocomposites incorporating functional inorganic nanofillers. These materials exhibit enhanced optical properties and can be used in coatings, displays, and optical devices. Next, I have reviewed Zhu et al. 2008, which explored the preparation of processes, properties, and potential applications of silica composites. Their findings highlighted the improved mechanical strength and thermal stability of these materials. Next is sol gel synthesis, on which I'm currently working. So Cremina et al. 2013 also examined the sol gel synthesis method for creating silica-based materials. This technique allows for the precise control of the material properties. Coming to the preparation of silica particles, here I have mentioned three methods, in which out of these three, I have used two methods and gained two different types of silica particles. The first one is wet chemical route. Silica can be prepared through this route, which includes the precipitation of silica as a silica gel. Actually, we do the acidic precipitation of sodium silicate solution, followed by the neutralization with the acid. Then we filter it, dry it, and we can get the good yield of amorphous silica, which is characterized by the high surface area, making them suitable for industrial applications. Second route is the fumed silica route, thermal route, which I have not tried. The thermal route for silica preparation involves the production of fumed silica through the hydrolysis of silicon tetrachloride in a flame. The next route is the extraction from plant, on which my whole PhD based on. The silica can also be biologically derived from the plants. Here I have used rice husk ash to create the silicon dioxide nanoparticles. Firstly, we extract the ash from the rice husk, then followed by the typical what we can say alkalization, then followed by the calcination, and at the last we'll gain the semi-crystalline silica particles. Just give me a minute, sir, please. Yes. Okay, here I have shown one of the figure which shows the modification of silica. Next, I have taken one diagram in which we can see that here the metal can be silica or aluminum, whatever, with the hydroxy linkage, and it can be modified with the use of hydrolysis, condensation, or the self-condensation to gain a better modified siloxanes products.
Excuse
Now,
me.
coming to
Excuse me.
the biomedical application, is it visible, sir?
It is visible, but your time is over actually.
Okay, I'm just concluding. This is
Please
the
conclude.
yeah, biomedical applications. Here I have taken two biomedical applications, that is drug delivery and the cancer gene therapy. Last, challenges in the silica polymer composites. So there is one agglomeration issue. Actually, what happens due to the presence of hydroxy bonds, it forms the hydrogen bonding, which restrict it from. Actually, it reduces the uniform dispersion of silica within the polymer. The next three are the poor compatibility with the polymers, viscosity reasons, and the need for the surface modifications. Here are some of the references which I have taken help from. Acknowledgement, I would like to thank my supervisor, Dr. Meet Kamal, Professor, Department of Chemistry, Christchurch College, Kanpur, for her guidance, and this conference, ICISSD 2025, for giving me this great opportunity. Thank you, sir.
Okay. Any question from audience? Yes. Next. Miss Kanchan. Miss Kanchan Belsare. Next, Miss Khushbu. Miss Khushbu Jaiswal.
Yes, sir. Am I
Miss
audible,
Khushbu
sir?
or Miss Kanchan?
Miss Khushbu.
Okay.
Am I
Yes.
audible, sir?
Yes, yes, yes.
The screen is visible.
Yes, visible. Okay.
Okay. Can I start?
Start. Yes.
Okay. Good afternoon, respected jury members, esteemed colleagues, and my dear friends. I am Ms. Khushbu Santosh Jaiswal, a research scholar under the guidance of Dr. N.D. Gawade sir from J.S. Tompe Arts, Commerce and Science College, which is affiliated by Santa Gadge Baba Amravati University. So today I am presenting my research on the four component synthesis of polyhydroquinolines under catalyst and solvent-free conditions. So this study focuses on an eco-friendly, cost-effective, and high-yielding approach to synthesizing biological significant polyhydroquinolines. So coming to the introduction part, polyhydroquinoline are widely used in pharmaceutical industry as a calcium channel blocker, cardiovascular drugs, and anti-cancer agents. However, their conventional synthesis involves toxic catalysts and organic solvents, leading to waste generation and environmental hazards. So our objective is to develop a sustainable catalyst-free and a solvent-free synthesis method that aligns the green chemistry principle. So coming to my abstract point, our study focuses on green and efficient synthesis of polyhydroquinolone using a four-component reaction, that is multi-step reaction. So the process is catalyst-free and solvent-free, making it simple and high-yielding. So the reaction follows novel condensation, Michael addition, and cyclization, ensuring sustainability and aligning with green chemistry principles. So material and methods. The reagent used in this synthesis include aromatic aldehyde, dimidone, ethyl acetoacetate, and a weak acid-based salt. So the reaction is carried out at 100 degrees Celsius in a steel tube under continuous stirring And TLC is used to monitor the reaction progress, and the final product is purified through crystallization. So this is the mechanism of my reaction. The aldehyde react with ethyl acetoacetate to form a beta-enamine intermediate, and the nucleophilic attack by diamidone leads to conjugate system formation, and the weak acid-base salt donates an amine, promoting intermolecular cyclization to form the final polyhydroquinoline structure. And the product was final by IR and 1 proton NMR. So the synthesis polyhydroquinoline product were characterized using IR and 1 proton NMR spectroscopy. So IR spectroscopy confirmed functional group showing peaks at 3,335 centimeter inverse for NH band and 1,670 centimeter inverse for carbonyl group, and proton NMR peaks at 4.10 parts per million for methylene, and methane 7.18, 7.19 parts per million. And the reaction yielded 70 to 80% product for various aldehydes. The melting points ranged from 246 degrees to 252 degrees Celsius, further validating purity. Our result demonstrates the method's efficiency in achieving high yielding without using catalyst. So, coming to the application part, polyhydroquinoline have a significant pharmaceutical application, as we mentioned before. So, as pharmaceutical application as antihypertensive, anti-cancer, and antibacterial agents. Additionally, this green synthesis approach aligns with sustainable chemistry by reducing hazardous chemical uses and minimizing waste. So, the concluding part is we developed a simple, cost-effective, and green synthesis polyhydroquinoline, high productive yield. Then this approach eliminates hazardous catalysts and solvent, making it a sustainable alternative for pharmaceutical application. So, this is the reference of my talk. Thank you very much. So, I would like to thank jury members and Narsamma Arts, Commerce and Science College, Amravati.
You check your compound for any specific activity? Hello.
Hello.
Hello. Have you
Hello,
check any specific your compound
your
for
voice is
specific activity?
breaks, sir. I can't.
Have you check? Yes. Am I audible? Have you checked your compound for any specific activity? Hello. Hello.
Actually, she is not getting your voice, sir.
Okay. Okay.
Let us move for the next.
Okay. Next, Mr. Onkar.
Am I audible, sir? Hello?
Yes, yes.
Yes, sir.
Okay. Good morning, good afternoon, everyone. My name is Omkar Yogesh Kare, a undergraduate student representing my review article on synthesis and characterization of iron doped silver nanoparticle under the guidance of Ms. Harshal Kherde, who is the assistant professor at PUP College, Luni. I thank my college and also Amravati College for giving me chance to represent my work in international conference in science and sustainable development. That's my introduction. Now head to the review article. The synthesis and characterization of iron doped silver nanoparticle. I choose this topic due to the current relevance of nanoparticles in upcoming future. The iron doped nanoparticles have gained the attained due to their enhanced properties and versatile application, especially encrypting with them with iron nanoparticle, with silver ones, enhancing their magnetic, optical, and catalytic properties, making them important for valuable in medicines, environment science, and electronics. Before using them in such industries, it is important to properly synthesize and characterize them. So, this state my review article name, a comparison study on synthesis on characterization of iron doped silver nanoparticle. I studied 37 review articles, research papers to find out the great, cheap, and sustainable method for synthesizing nanoparticles and characterize them. Let's dive into it. For those who are the new in the field of nanotechnology, let me give a basic introduction. The nanoparticles are the one-dimensional, ultra-small particles about 1 to 1000 nanometer small, which have unique property due to their high surface area and quantum effect. So they can be used in medicines, electronics, and catalysts by doping them with different elements, enhancing their properties such as magnetic, optical, catalyst, leading into the productivity in their applications. Not only, but also the magnetic properties of iron make them the special for drug delivery, MRI techniques, and also in biosensing, optical imaging, and photocatalyst for environmental applications like water treatment, air purification, and many more. That's all about the nanoparticles. In the start, to achieve all of this, we have to properly synthesize them. An ideal nanoparticle, according to application in chemical, pharmaceutical, or lab industries, there are many methods of synthesizing nanoparticles. Let's dive into the diverse approach for controlling properties. The chemical reduction method involves the reduction of silver ions in iron precursor, strongly reductive agent like NaOH. It allows to previously control the optical size and comparison, mainly used for the industry for large-scale production. The second one, the sol gel method, involving the hydrolyzing and condensing the metal precursor to form a gel network, result into the nanoparticle with controlled morphological and optical properties. The third one, the green synthesis method, an ideal and eco-friendly approach uses biological sources like plant extract, bacteria, fungi to reduce metal ions into desired metal complexes. In my case, the iron doped silver nanoparticles are there. The fourth one, laser abreuation method, uses a high energy pulse to vaporize the iron silver nanoparticles, leading to the formulation of nanoparticles. My presentation highlights some underrated methods like co-precipitation, electrochemical, hydrothermal, microimmersion methods. But these are underrated due to their flaws and unusability in the formulation, especially iron doped silver nanoparticles, or I can say they are not so efficient as I previously discussed in methods. After we successfully synthesize our silver nanoparticles from green synthesized method, it is important to characterize them. The most common and reliable techniques include XRD, SAME, TAME, FTRI, and some underrated unreplicable include XPS, motion power spectroscopy, dynamic light scattering. These are the results that we obtained during uh, during the green synthesis of our silver nanoparticles. The XRD graph. The method of iron doped silver nanoparticles analyze crystal phase composition, lattice structure to give the advantages compared to the XPS, which is mainly providing the binding energy, oxidation state, and not so good surface analysis. The second one, the phase transition that occurred during the XRD graph is 38°, 44.5°, and 64°, indicating the conformation of silver nanoparticles, and these additional peaks indicating the doping of Fe alloy formation has been occurred. The second technique which we used is TAME. Transmission electron microscopy give a visualization of nanoparticles including their shape, size, and structure. we compare the mass spectroscopy, which only provides the chemical and electronic state information of our molecules. The 10 images gives a shape, size, contrast. In our results, the shape is cubic, size is 20 nanometer, uniform and light and dark area indicating the conformation of iron doped silver nanoparticles has been successful. The third one, Fourier transfer infrared spectroscopy. It gives the idea about the functional group detection surface modification between the iron nanoparticles and silver nanoparticles during the application, during the operation. Compared to dynamic light scattering, it gives only idea about the particle size measurement in liquid suspension and distribution based on their light buoyancy of them. Now moving to the next slide. The iron doped silver nanoparticles have large number of applications, but they are selective ones. But there are selective ones that I mentioned in my seminar. The antimicrobial treatment, the common and regular one, the drug delivery, mild reagent but underrated, cancer therapy, the innovative and future appearance. The drug delivery. The magnetic properties of iron doped silver nanoparticles make them ideal for drug delivery where they can work with the drug molecules to deliver an active drug ingredient in the specific tissue. In cancer therapy, the iron doped silver nanoparticles mainly show cytotoxic effect on the cancer cells, resulting into the increasing the effectivity in chemotherapeutic drugs. And some of the small but not most important applications like environmental science for solving pollutant problem with the silver nanoparticles, iron doped silver nanoparticles, such as water purification by removing heavy metals and degradation of dyes, soil reduction by degrading the petroleum and hydrocarbons content in the soil. For air pollution control, the iron doped silver nanoparticles must act like a catalyst to convert and filter the remove the harmful gases in particle to form the result into the improving air quality. Final, our conclusion. We compare the different ways of making the iron doped silver nanoparticles, including chemical, green synthesis, hydrothermal method, in which the green synthesis stood out of the eco-friendly option for the reducing the toxins. Byproduct will be maintaining the good nanoparticle properties. Doping with the different ions affected their characteristic transition metal dope involve catalytic activity properties. The techniques like UV visible spectroscopy, XRD, TAME, and FTRI help to analyze their structure, size, and its accessibility in our field, highlighting them how synthesis and doping methods can be optimized to improve the nanoparticles used in catalyst medicines and sensing. But the last one is innovating for the greener future, sustaining nanotechnology for a better tomorrow. Thank you.
Okay, nice presentation. Any question from audience? Yes, any question? Okay, last presentation, Miss Roshni Rathod.
Yes, sir. Just
Miss Roshni.
Yes, sir. Audible? My screen visible? Hello. Hello. Sir, am I audible?
Yes, yes.
Okay. My screen is visible, sir?
Yes.
Yes, sir. Okay. Good afternoon, all. My name is Roshni. research scholar from Chemistry Department, the Institute of Science, Dr. Homi Bhabha State University. Sorry. Pursuing PhD under the guidance of Dr. Vishal Banewar sir. And my topic is phytochemical analysis and protox activity of system diurenum. Phytochemistry. Oh, 1 second. Phytochemistry, that is a phytochemistry study bioactive compounds found in a plants. These natural chemicals play crucial role in a medicine, nutrition, and agricultures. Many modern medicines, like some natural products, are derived from the plant-based compounds. And that is a phytochemical analysis is the scientific process used to identify and qualify the various bioactive compounds in a plants. Phytochemical analysis is the two types of. That is the first one is a qualitative analysis is the determines the presence or absence of a phytochemicals using chemical test. And second one is quantitative analysis measures the exact concentration of a specific compounds using advanced techniques like HPLC, GCMS, spectroscopy, and chromatography, others. There is natural products. Natural products are a bioactive compound derived from plant, fungi, bacteria, and marine organism. There is a use in a nutraceutical and medicine and cosmetics also. Majorly source of modern drug discovery and traditional drugs. There is a natural.
50 मध्ये ऍड केलं होतं कोबाल्ट हे
Yes,
पूर्ण
sir.
वेट काढलं होतं ना आता परत 350 मध्ये त्यात मेटलचं टाकून
तुला माहिती असेल
कोबाल्टचं अमाऊंट माहिती होती किती घेतलं
Hello.
सांग ना कोबाल्टचं मास किती
58
Yes, sir. Types of natural products in a medicine. Plant-based natural products, it's the phytochemicals, example alkaloids, flavonoids, and terpenoids. There is a second one, microbial-based antibiotic like a penicillin and streptomycin. Third one is a marine-based, that is a anti-cancer compounds, that is a didymic bean and bryocytins. Fourth one is a animal-based like a propsolin and nanolins. Medicinal high impact of a phytochemistry. There is a on a natural products. First one is a disease prevention that from anti-cancer, anti-inflammatory, and antioxidant effect. Second one, drug discovery. Many modern medicines are plant derived from a natural products. Metabolic and human health supports a digestion, immunity, and weight management. There is a some list medicinal natural products of a phytochemicals. There is a alkaloids. It medicinal uses pain relief, malaria treatment, cancer therapy, and blood pressure controls. Second one is a flavonoids. There is a medicinal use as a antioxidant, anti-inflammatory, and cardiovascular health. Third one is a terpenoids. There is anti-malarial, pain relief, cancer treatment, and digestions. Saffron is used as a hormone balance and cholesterol reduction. Glycosides also help for heart health and natural sweeteners. My aim is to identify phytochemical in a system diurenum fruit and evaluate their protox toxicity. There is a system diurenum is also called as a day blooming jasmine and common name of Dimka Raja. They belong from family as a Solensis and genus is a system diurenum. There is a tropical shrub found in India, Southeast Asia, and America. Known for its fragrant white flowers that bloom during the day. Importance there are used in a traditional medicine and phytochemical research. Rich in natural bioactive compounds used for human support and anti-inflammatory benefits and also bone health. There is a composition of a phytochemical in a system diurenum like a vitamin D3. It supports a calcium absorption and bone health. Second one, alkaloids possess antimicrobial and medicinal properties. Flavonoids is a help for the antioxidant and anti-inflammatory effects. Glycosides potential cardiovascular and metabolic health. Saffronins also strengthen immunity and regulate cholesterols. There is a morphology. System diurenum is a woody shrub that grows up to 3 to 4 meters tall with elongated. And their leaves is a pale green folds The plant produces dark purple to black berries. Medicinal high impact of a system diuretic. First source of vitamin D3. It helps calcium absorption and bone strength. Used in treating osteoporosis and rickets. Second, anti-inflammatory and antioxidant properties, rich in flavonoid and alkaloids. Protects against oxidative stress and chronic disease. Third one, potential antimicrobial activity, effect against bacteria and fungi. Helps in treating infection and wounds, matlab healing process. Immunity and metabolic health, saffronese glycosides are boosting immunity. Traditional medicine uses in system diuretic uses Ayurveda and folk medicines for treating bone disorders, and second one for skin conditions and infection. And decoctions used for the pain relief and fever management. Here literature survey of system diuretic other species. There is a experimental sections in our lab. Some extracts of a seedy fruits. Here is a FTIR of extracts. There are some peaks in their phenolics range is a 3,200 to 3,000. FTIR graph is shows the hydrolytic stretchings, that is a 3,200 to 3,700 cm inverse. And second, flavonoids, there is a 3,000 to 3,800 cm inverse, that is a hydroxyl stretchings in their presence. Fourth one is a terpenes, there is a 2,800 to 3,200 in between. And last one is the alkaloids. There is a 2,500 to 3,500. There is a NH stretching in theirs. HPLC extracts. There is a mainly present is a alkaloids. Sir. Protox activity of alkaloids. There is a 3 alkaloids in there: cotinine, non-nicotine, and nicotine. Introduction, there is a protox activity. Protox is a computational method for predicting toxicity of phytochemicals. Helps assess the safety and adverse effects of chemical and natural compounds. Uses of machines learning the activity models. Identifies the toxic compound early in a drug discoveries. There is a methodology. So I find the protox software. There is a any phytochemicals or alkaloids, there is a structures and their toxicity find from these softwares. And results of protox, first is a cotinine and their toxicity class. Toxicity class 1 is a highly toxic, and there is a second less toxic, and there is a class 6 to non-toxic, and cotinine is the first belong for class 4. This is a predicted LD50 is equal to 1604 mg square. LD50 is belongs to more LD50 is a less toxic, and less LD50, lower LD50 is a more toxic. Like example, LD50 is equal to 200 mg per kg, like a very highly toxic. And second one, LD50 is equal to 5,000 mg per kg is a less toxic. There is a some cotinine belongs from class 4. Second, nicotine is a belonging for class 1, that is a highly toxic.
Next.
Ek minute, sir. Result of protox. And here is a conclusion. And future scope is a experimental validation and toxicity studies, pharmaceutical bioactive compounds from the system diuretic fruit. Thank you.
Okay. Any question from audience?
No question, sir.
Okay.
Sir, Dr. Prachi Bonde, Dr. Prachi Bonde and Dr. Kanchan Belsare, two students, two
No,
participants have
both are absent,
not
sir.
presented. Yes, sir. Okay.
Principal Dr. Tekade sir is here.
Yes.
Sir, presentation is over. Please conclude the session, sir.
Yeah, sure. So I appreciate the research work of all the participants as well as their presentation for this international conference. And thank you, both the juries, Dr. Amit Raul and Dr. Siddharth Wagmare, for this for the assessment of these presentations of this session. Thank you to all thank you to organizers for giving this opportunity to chair this session. Thank you very much. I declare that this session is over.
Thank you, sir.
Thank you, sir. Thank you so much.
Thank you, sir. सर पोस्टर प्रेजेंटेशन स्टार्ट हो रहा है अभी?
Thank you very much, sir, for your valuable remarks. Thank you all your active participants in this session. We appreciate the hard work and dedication that gone into this presentation. Our judge will now delegate and select the best presentation which announced during the closing ceremony. I am very thankful to Principal Dr. Tekade, Dr. Wagmare, and Dr. Yaul for this cooperation. And also, I am very thankful to all speakers and participants. Thank you very much. Next session will start immediately.
Very good afternoon to one and all. Myself, Dr. Mangesh Tihile, Department of Chemistry. Welcome you all. Now, we are going to conduct a poster presentation session on behalf of Srimati Narsamma Art, Commerce and Science College, Kiran, Amravati, and Association of Chemistry. Welcome you all to the presentation session of research papers at the International Conference on Innovation in Science and Sustainable Development. We are honored to have with us Professor Dr. Gunwanta Kurade as a chairperson of the session. She is a professor in chemistry at Vijnan Mahavidyalaya, Malkapur. Also, he is a member of Board of Studies in Chemistry. Welcome, a warm welcome, sir. We also have Dr. Sachin Manohari as a jury for this session. He is a professor in chemistry at Adarsh Mahavidyalaya, Dhamanda, Delhi. Welcome, sir. Also, we have Dr. Mithun Lunge, sir, as a jury for this session. He is a professor in chemistry at Jagdamba Mahavidyalaya, Achanpur. A warm welcome to you, sir.
Thank you, sir.
Both the judges are going to evaluate the session. Let's give them a warm welcome. This session will feature total 14 poster presentations, each lasting for 3 minutes. After each presentation, there will be a 2-minute question answer session where our judges and an audience member can ask a question. Our judges will evaluate the presentation based on their technical content, presentation, skill, and overall event. With the permission of chairperson, I would like to invite First speaker of this session is Professor Dr. Anita Bodke. Professor Dr. Anita Bodke. Are you there? Okay. Now, she is not available here. Next one, Dr. Ved Patki. Dr. Ved Patki.
Dr. Patki.
There, Dr. Ved Patki. I think
Absent.
Dr. Ved Patki is also not available here. Now, may I call the next speaker of this session, Ms. Kanchan Belsare. Ms. Kanchan Belsare. Now, next speaker, Madhav Kendre sir. Madhav Kendre. Okay, I think they will join us later on. I call the next speaker, Kunal.
Hello, am I audible, sir? Kunal here.
Kunal is there?
Yes.
Okay.
Yes, sir. Yes. Hello, am I audible,
Yes.
sir?
Yes.
Yes. Let me share my screen, sir.
Kunal Dawle.
Yes. Is it visible, sir? Hello.
Yes, visible. Yes,
Yes.
Can I start? Hello.
Yes, sir.
Good afternoon, respected jury and respected audience. Thank you for giving me the opportunity to present my research at the prestigious International Conference on Innovation in Science for Sustainable Development, that is ICISSD 2025. I am Kunal Davale, along with me my colleague Pooja Thakre, and we do research under Dr. Ganesh Kale sir in CSIR National Environmental Engineering Research Institute, NEERI, Nagpur. Today I am presenting my research and innovative approach to energy from the plaster of Paris waste. This is not only addresses the pressing issue of construction and demolition waste, that is C&D waste management, but also explores the potential of transforming waste material into sustainable energy source. Let me walk through the introduction, electrochemical reactions, news highlights of the POP waste pollution. Hello. Hello.
PowerPoint presentation is not visible, sir. Please open the file.
Sir, it's open. Actually, it's open, sir. It's visible now, sir.
No, your main window is visible. Here we have some files. Your main file is not open. I one more time.
Is it now visible, sir?
मैंने तो पहले बोला था तुमको जितना सीधा कभी कभी सीधा सीधा दिखता है लेकिन आते नहीं हाँ सर
Wait, sir, I will check.
यहाँ से तो लेफ्ट कर दो
screen is not visible sir
Yes, sir, I'm trying. Actually, here there is a screen is sharing. There is a notification, sir. But why don't
विंडो शेयर करने में कौन क्या
extra?
उसको बोलना शेयर स्टॉप शेयरिंग
Sir, is it visible now?
yes now it is visible
Okay, sir. I
Go
will
on.
start again. Good afternoon, respected jury and respected audience. Thank you for giving me the opportunity to introduce my research at the prestigious international conference on innovation in science for sustainable development, that is ICISSD 2025. I am Kunal Anil Devle, and we do research under the guidance of Dr. Ganesh Khare sir in CSIR Niri Nagpur, that is National Environmental Engineering Research Institute. Today I am presenting my research, and that is innovative research on how energy is generated from the plaster of Paris waste. This study not only addresses the pressing issue of construction and demolition waste, that is C&D waste management, but explores the potential of transforming waste material into sustainable energy source. Let me walk you through the introduction, that is the abstract introduction, electrochemical reaction, news highlight of the POP waste pollution, that is interesting prototype design, novelty of the setup, what is new in this, what is the innovative in the setup and design, uh, key research finding, that is result and discussions, and followed by the conclusion and references. uh, as we are moving towards the circular economy from the linear economy, we have to manage the waste using the various techniques. As we faces the crisis of climate change, we need to think about every possible way to create energy or alternative source of energy. Our solid waste, including the construction and demolition waste like POP waste, is a very good source of energy, sir. Like plaster of Paris represents a large fraction of total construction and demolition waste generated by the society. Construction and demolition waste, sir, it is made up of gypsum, concrete, plaster, and many plus 60 mm like solid rocks. It will be used in the road construction, but there is a burden on the landfilling, sir. A study indicates, that is the one NCL study, sir, National Chemical Laboratory study, indicates that the each dental and orthopedic hospital approximately generates the 7 to 8 kg of POP waste. POP waste is dumped at many sites and it is not recycled as the cost of recycling is very high. Therefore, the main objective of this work was utilize the POP waste, that is the plaster of Paris waste, for the energy generation using the simple concept of electrochemical or galvanic cell. As we are moving towards the electrochemical reaction, in electrochemical, hello? In electrochemical reaction, plaster of Paris, which is primarily consists of the calcium sulfate, partially dissolved in aqueous medium. This dissociation releases calcium ions and the sulfate ions into the solution. The presence of these ions facilitates ionic conductivity and plays a crucial role for in the internal circuit and contributing to the electrical that is electricity generation. At anode, water sulfate and the sulfate sorry water and the sulfate ions are reacted, water molecule splitted and oxygen is released, and along with the H2SO4 is formed. So at the cathode, stainless steel, that is calcium ions from the calcium sulfate and water are involved. Calcium ions react with water to from the calcium hydroxide, and H2, that is hydrogen, is released. So according to the news highlights, in the news highlights that every year government the initiative to ban the POP, and in fact it's a good cause, but somehow it is not completely banned. So in the first news highlights, sir, there is a it's it's take the heavy damage to the flora and fauna of the river and take 5 to 6 years completely dissolve. Means if we collect the POP and dump in the river, it will take the 5 to 6 years to completely dissolve. So, sir, it maybe it affect maybe it affect the human health, like it causes the diarrhea, cholera, and the typhoid in humans. Coming to the interesting design, sir. In the interesting prototype design, sir, C8, that is the when the graphite rod. The graphite rod is wrapped up. That is the coupled with the agar-agar plus the KCl or the NaCl based the salt bridge, and this this coupled with the CaSO4 based electrolyte and SS electrolyte, that is the stainless steel electrolyte for the electrical energy generation and harvesting of the H2 generation. Maximum voltage we obtain as 1 volt obtained in the simple cell, and electrolyte we add such as the water only for the every 24 hours. So novelty in this setups are utilization of waste contributes to the waste reduction and the circular economy. As we recycle and the reuse, this is the concept of the circular economy. The process is scalable in the Indian environment, and this is the green and the environmental techniques. Based on the coming to the result and discussion, that is the key research finding. Uh, the different electrochemical combinations such as the CaSO4 into 2H2O, which some of which where we use in some cases salt bridge is used, salt bridge is not used. Salt bridge is consist of mainly agar-agar and the KCl or the NaCl, and the electrolyte we use as the water.
Hello. Hello. Am I audible?
Is there any issue?
Yes. Your voice have been break. Please repeat.
Nal, are you there?
Yes.
Yes, Kunal sir.
Am I audible, sir?
Yes, yes. Are you done?
Hello, am I audible?
Yes, you are audible.
Yes, actually, there is problem, sir. Sorry.
Okay.
So
Kunal.
coming to the result and discussion, sir, there are the yes, sir.
Yes, yes. Continue.
Hello.
Yes,
Okay, no
continue,
problem.
please.
Okay. So coming to the result. Yes, yes, sir. Coming to the result and discussion, sir, the three cells were connected in series in the voltage of 3.2.9 volt was obtained, and there is a CaSO4 into 2H2O, that is calcium sulfate. We use uh, water as a electrolyte medium, and there is no salt bridge, and we take the voltage of 0.7, and in the another CaSO4 into 2H2O, we use the salt bridge plus water, and take the voltage of 1.0 volt. Another way, we perform the experiment on the CaOH by 2, that is calcium hydroxide plus the calcium sulfate. We use the salt bridge and electrolyte is water. That gives a voltage of 1.56, sir. But using the CaOH by 2, as the CaOH by 2 is hygroscopic nature, so the voltage will drop very easily, and it will means it will down to the 0.7 or 0.6 volt. So this this study was stopped by us, and CaSO4 into 2H2O with KCl using the CaOH by 2 electrolyte use, we take the voltage of 0.48, and we continue the study using the CaCl2 as a 10% CaCl2 and a 10% using the CaCl2 with salt bridge and without salt bridge. We use KC as a salt bridge and take the voltage of 0.84. So as per the data of the electrochemical results, we measure the current of 10 milliampere as the 10 and highest current, and then we for we inclusion, sir, the many challenges during the how the stability is depend on the way parameters like moisture retention, degradation, and salt bridge moisture retention. So after we perform the moisture retention test, it will be less than the 30%. So it will shows the good results, sir. And then coming to the conclusion part, in the conclusion part, the feasibility study shows the utilization of POP waste generates electricity. And additional, additionally, the hydrogen oxide along with the calcium hydroxide and the sulfuric acid was generated at the ambient temperature and pressure. So, coming to the references, there are many cells like Bird cell and 1837 Goldenberg, the scientist, uh, using a plaster of Paris barrier to separate the copper sulfate and the sulfuric acid. They use this, but completely plaster of Paris was the till now no one has been used. So had been used. So early dry cell 1886 and the modern dry cell, they use only the plaster of Paris as the medium to separate the copper sulfate and the sulfuric acid solution. So through this work, sir, I am aim to highlight how the otherwise discarded material like POP can repurpose to contribute to clean energy production, aligning with the broader goals of environmental sustainability and the resource recovery. So this is all about the this waste generation from plaster of Paris waste, sir. Thank you very much. Hello.
Very nice presentation.
Thank you very much, sir. Actually, sir, before
Yeah.
the role of the salt bridge in this. So, like the salt bridge, like take the example of the water flowing through the pipe. Salt bridge is like the open wall, smooth water flows. That is the steady current and the higher voltage. No salt bridge, that is blockage. Water slows down and the low voltage. So this is all about the salt bridge. Salt bridge is needed, sir.
Thank you, Kunal. Is there any question from the audience?
Yes.
In your result and discussion, you are predicted that three cells were connected in a series and a voltage
Yes, sir.
about 2.9 volt was obtained, 2.9 volt. Can you tell me how much amount of that plaster of
Yes,
Paris
sir.
generated?
Yes, sir. Yes.
How much amount of volt? Kunal sir? Audible?
Hello.
Yes, sir.
Hello.
Huh. You are audible now.
Hello. Yes, sir. Please ask questions.
Can you tell me how much amount of that plaster of Paris, suppose 1 kilogram
Yes.
of plaster of Paris, how much amount of voltage is generated?
Okay, sir. Basically, sir, we do the calculation for 1 ton, and for the 1 ton, it should be the 1 kilowatt is generated as per the standard temperature and the pressure value, as per the STP conditions, sir.
Okay.
Hello.
Thank you, sir. Sir, please next.
Actually, sir, we are consulted with one of the Gausha in Nagpur. So they like our project and they said ki it's good and we are doing this for the waste generation to the waste to electricity.
Your work is very nice.
So,
Sir, Kunal sir, thank you
okay,
so
sir,
much.
thank you very much.
Next one is
Thank you, sir. Thank you.
Miss Mehjabin R. Mujawar.
Next participant is Mehzabin. Miss Mehzabin, are you there? I think she is not available with us. We'll proceed for the next one. Miss Nikita Atram.
Yes, sir. Am I audible?
Yes, you are.
Okay, sir. Give me 1 second. Is my screen is visible, sir?
Yes, madam.
Okay, sir. Thank you for this opportunity. Here I am Nikita Atram presenting my poster. My topic is groundwater quality of Dharni Taluka, the malnutrition center of central in India. And we are started for this topic. So basically, my research is about to assess the water quality by microbial method to find out E. coli and fecal coliform. Am I audible, sir?
Yes, yes.
Hello, sir. Okay, thank you,
Go
sir.
on.
So basically, my research is about to assess water quality by microbial method to find out E. coli and fecal coliform, which is responsible for diarrhea disease, and to post-monsoon season were determined in this research. So introduction, as everyone knows that water is a very important source for the human and animal purpose, and the water quality refers for the physical, chemical, and biological characteristics. But contaminated water is a global problem affecting millions of people, and waterborne diseases like cholera, diarrhea, dysentery impact millions of people. So my focus is on young children under age 5 because they have an underdeveloped immune system, which making them more reliable to infections caused by E. coli and fecal coliform contamination. And waterborne diseases like diarrhea can quickly lead to sub-dehydration, nutrition loss, which is a leading cause of malnutrition and child mortality. So my objective is to assess the post-monsoon water quality from various villages of Dharni talukas. So material and methods. The total 50 villages were taken from Dharni taluka, means 50 locations, and from which 6% source. There are some sources, that is hand pumps, dug wells and bore wells. 6% from hand pumps, 66% from dug wells, and 26% from bored wells. 100 ml polypropylene narrow mouth container was used to store the water sample by grab sampling method, and is and transported to a lab within 24 hours by using ice box. So method used for this microbial method which is used is MPN method, is used to identify E. coli and fecal coliform also. So to perform this MPN method, volume of water sample is added to added to a lactose broth which is kept in the test tube and incubated at 37 degrees Celsius for 24 to 48 hours. After that, it changes to pink or red in color, which means fecal coliform is present in that water. After the result come out, positive results come out, then loopful of water sample is streaked into EMB agar, that is eosin methylene blue agar. The plates are incubated at 37 degrees Celsius for 24 hours. Then you can see in the pictures metallic green colonies appears, which means E. coli is present in this sample is confirmed. So this is materials methods I have used, and we got result, and the result of the samples from 50 samples in the graph shows from 50 samples 23 samples positive with fecal coliform, from which 18 samples is positive with E. coli, which means 46% of sample positive with fecal coliforms and 36% of sample positive with E. coli, which means the coliform contamination is an indicator of potential water pollution from human or animal waste. So conclusion of this study highlight need more improvement in sanitation, hygiene and water treatment in Dharni Taluka to reduce groundwater contamination, and adopting better waste management, water purification system and public awareness program, and also help to prevent more waterborne disease and malnutrition in children. So we can also use biosand filter, charcoal sand filter in a villages area as a reasonable rate. And these are the references. Thank you. Hello, sir. Sir, hello.
Yes. Thank you.
Okay. Thank you, sir. These are the
Very nice
references.
presentation.
Thank you, sir.
Hello.
Hello.
Am I audible, sir? Miss Nikita, ma'am.
Hello.
Have you
Yes, sir.
detected some other bacterial strain along with this too?
Hello, sir. I'm not able to hear you. Please, will you please explain? Repeat your question.
I am saying, have you detected some other bacterial strains along with this too? Or you have not checked it?
Accidentally, I also found Staphylococcus aureus, S. aureus.
Okay.
Accidentally, but my focus is on E. coli because my focus is on diarrhea disease, which is a major problem in Dharni, and actually Melghat region is also very famous for malnutrition purpose.
Malnutrition,
My
yes, right.
focus is on E. coli, which is responsible diarrhea disease, and fecal coliform, which is come from human waste and animal waste, which I have explained in result and discussion.
Okay, thank you.
Thank you so much, sir.
Thank you, sir.
Good.
Sir, should I stop sharing my poster?
Yes, ma'am. Yes, ma'am. It's over.
Okay. Okay, thank you so much.
Next participant is Dr. Abdul Wajid.
Yes, sir. Am I audible, sir?
Yeah.
Yes, I am sharing my screen.
Yes.
Sir, is the screen is visible to you?
No.
Not yet, sir.
Hello.
Yes, I'm trying to share the screen.
Hello, sir.
Is it visible, sir?
Right, sir.
Can I
Again,
start?
sir.
Okay. Good afternoon, everyone. This is Dr. Abdul Wajid, Assistant Professor, Department of Chemistry, Shri Shivaji Arts, Commerce and Science College, Akot. I am here to present my research work titled Shift-Based Ligand and its novel manganese, cobalt, nickel, copper metal complexes, their synthesis, structural characterization, and biological activities. So these are the contents: abstract, introduction, experimental section, results and discussion, conclusion, and finally the references. We know that the study described the synthesis, characterization, and biological study of novel chip-based ligand and its transition metal complexes. Particularly, the ligand was obtained by condensation reaction between 2-hydroxy-5-nitrophenyl methanol, abbreviated as HNPM, and 2,4-DNP. The complexes of the ligand have been
Majid sir.
prepared by
Hello.
using different metal acidates. Huh, sir?
Majid sir, your contents are not visible. Your
Okay, my
screen that
contents are not.
your contents are not visible. Your poster is not visible on the screen.
Okay.
Hello, sir.
हाँ sir. हाँ ma'am.
Yes.
Sir, I am Payal Kadu. Sir, whether today is my presentation or not.
Ma'am, your name is not listed in for this session.
Okay, sir. But can you permit me for present today?
You can ask to the convener of this conference or the organizers.
Extremely sorry, ma'am. Actually,
Okay, sir.
over and it is already crossed the limit of time. So we are also in hurry to shuffle up these sessions.
Sir, am I audible?
Therefore, we are extremely sorry.
So Ajit sir, you are audible, but your screen is not visible.
Okay. Can I try from other device? You can start the other presentation.
Next one. Okay.
Okay. Thank you, sir.
Mangesh sir, please call the next one.
Abdul Wajid sir, are you there?
Ajit sir trying from another device.
Okay. Till then, we'll go for the next one and
Next one, yes.
give some little bit time to Abdul Wajid sir if he will be able to present his presentation. Okay. Next one is Priyanka, Miss Priyanka Patil.
Hello.
Miss Priyanka.
Hello.
Yeah.
I'm audible.
Yes. You are audible. Share your screen.
Yes, sir. Sir, I have seen my poster. Hello.
No, ma'am. Your poster is not visible yet.
Yes, now visible.
Hello.
Yes,
Visible, sir?
visible.
Yes.
Yes.
Go on.
A very good afternoon, sir. Myself, Priyanka Vinayak Patil, PhD student of SP College, Chandrapur. Poster presentation on groundwater hardness induced hair fall in Chandrapur district, central India. Introduction. Hair is essential part of the human personality, and it is essential part of the self-confidence and self-esteem. Hair fall or alopecia is one of the most common distressing disorder by all peoples for all age group. The various internal and external factors external factors contributing to hair fall, the quality of water used for hair washing, it is important distressing the degree of hair fall. Long term use of the water having high levels of porosity, charge mineral like magnesium, silica, iron, calcium weakness the hair follicle roots and shaft, leading to hair dry and damages. The main objective of to ascertain the contribution of hardness in season, material and methods. A total 500 individual from rural areas of Chandrapur were identified as a solution from sample 28 128 hair fall individual comprising of the different age groups 15 to 25, 26 to 35, 36 to 45, 45 years were identified to collect the sampling method and analyze for various physicochemical parameters. APA to the results. So the pH, conductivity, total both the 100 in some rural areas, the total hardness is 86.71 in some rural area. Total hardness was above the permissible in rural area. May pose to hard area minimum value 0.12 plus minus 1.43. Along with the discussion and conclusion, this study shows that hard water contain an excess amount of calcium and magnesium could make the hair dry and breakages, leads to the hair thinning and hair fall. Calcium is the main ingredient in hard water settle on the scalp in the form of the to and thank you so much. Hello.
Yes, madam.
Thank you. Thank you, Priyanka ma'am.
Am I audible?
Yes, yes.
Yes, sir. Thank you so much. Okay.
Is there any other
Ajit sir, please wait for 1 minute.
Yes, sir.
Okay, sir. Okay.
Mithun sir, continue.
any other component from the water responsible for the
Yes, sir.
hair fall or not?
Sir, according to in winter season analysis, only one parameter, sorry, alkalinity and calcium and calcium hardness are main responsible. Both are responsible for hair fall, sir, in winter season only. And like total hardness, pH, conductivity, they are desirable limber responsible for hair fall.
Okay, thank you.
Within sir. Okay, thank you so much, sir.
Wajid sir,
sir.
you
Okay.
can share your screen now. You can
Yes,
continue
yes.
now.
Okay.
Sure. I close, sir?
Yes, ma'am.
Okay, thank you, sir.
Sir, is my screen is visible?
Yes, go on.
Yes.
Okay. Hello, good afternoon, everyone. This is Dr. Abdul Wajid, Assistant Professor. I am here to present the research work titled Sheet-based ligand and its novel manganese, cobalt, nickel, copper metal complexes, their synthesis, structural characterization, and biological activities. So these are my contents: abstract, introduction, experimental section, results and discussion, conclusion, and references. The particular ligand was obtained by condensation reaction between 2-hydroxy-5-nitrophenyl methanol, abbreviated as HNPM, and 2,4-dinitrophenylhydrazine. After the preparation of the ligand, different metal complexes have been prepared by using particularly acetates of manganese, cobalt, nickel, and copper under reflux condition. And the compounds were identified by different techniques, just like FTIR, NMR, thermogrammetric analysis, UV diffuse reflectance spectra, and magnetic susceptibility. The main focus on the screening of different antibacterial activity against some clinically important bacteria, just like E. coli, S. typhi, S. aureus, and so on, as well as some important antifungal activities. So this one is the introduction of the topic. The transition metal complexes have been prepared, are particularly interested due to their variable oxidation states, which allow them to participate in redox reaction also. So this one is the preparation of the ligand, so abbreviated as HNMP DNP, by using 2-hydroxy-5-nitrophenyl methanol with 2,4-DNP under reflux condition. And after the preparation of the ligand, different metal complexes have been prepared under different conditions. So this one is the analytical data of manganese, cobalt, nickel, copper, their color, time of reflux, and elemental analysis. This one is the NMR data. Okay, NMR data and IR spectral data. Okay. So this one is the IR peaks, and finally the microbial activity data against 4 different bacteria and 2 antifungal activities against A. niger and C. albicans. The complexes show very good antimicrobial activity because of formation of metal oxygen metal ligand bonding, and definitely the table show the data, and these are my references. Thank you very much, sir.
Thank you, sir. Have you characterized prepared chip bases on the basis of spectroscopic data?
By using IR, NMR, thermogrammetric analysis, magnetic susceptibility data, XRD, etc.
No, I am not asking for your complexes. I am asking for the ligands that you have prepared.
So sound is interrupted.
Hello, may I audible?
Audible, sir.
आपने इसका कैरेक्टराइजेशन किया है क्या?
Pardon, sir? Sorry, not audible, sir.
Okay. Mithun sir, you may ask.
सर.
Yes, sir.
आपने जो एंटी माइक्रोबियल एक्टिविटी स्टडी की,
जी सर,
वहां पे आपको गुड रिजल्ट्स मिले कुछ बैक्टीरियाज में.
हाँ.
ओके. तो आपने कुछ स्टैंडर्ड ड्रग के साथ कुछ कंपैरिजन किया है क्या उसका?
नहीं, ड्रग्स के साथ तो अभी नहीं किया सर, कुछ प्लानिंग है, एंटी कैंसर का प्लानिंग है मेरा.
ओके
सर.
ओके, थैंक यू.
ओके.
Please.
Thank you all. Next participant is Miss Rinku Soni.
Yes, sir. Am I audible, sir? Hello.
Ma'am. Yes, yes.
Okay,
Continue, please.
I'm sharing my screen. Is my screen visible, sir?
Yes.
Just a minute, sir. Just a minute, sir. Yes, sir. Sir, myself Rinku Soni from Chaudhary Bansilal University, Bhiwani, Haryana, from India. Sir, I am presenting today my poster entitled as Synthesis, Characterization and Anti-Cancer Evaluation of 1,2,4-Triazolo 4,3-B pyridazine derivatives. Sir, in this study, mainly we have focused on the three factors. That is, first one is that we will synthesize such type of compounds only which have biological activity or they are useful for the community. Second one is that we will focus on the green chemistry principles. That is, we will use only those oxidants or those chemical reagents which are not harmful to our environment. That is, we have focused on minimizing the metal oxidants. Instead, we are using in our study hypervalent iodine reagents which are less toxic as compared to metal oxidants. And third factor is that we have focused on minimizing the organic volatile toxic solvents, and instead we are using the water as a green solvent which is commercially available also. So in this study, we have synthesized the 1,2,4-triazole derivatives and also carried out their anti-cancer activity. Hello?
Sir, please unmute yourself.
Yes, continue, ma'am.
Ma'am,
Okay, sir. Okay, sir. This is the abstract, sir. In brief, I am telling that we have synthesized the 1,2,4-triazole derivatives. 1 minute. Which have been recognized as a promising framework with potential anti-cancer activity. As spotted by the previous studies, building on this background, we designed a series of 1,2,4-triazolo 4,3-B pyridazine derivatives to investigate their structure-activity relationship and optimize their anti-cancer properties. In total, we have synthesized 15 derivatives of 3-aryl, 6-phenyl, 1,2,4-triazolo 4,3-B pyridazines in excellent yield. And their structure was confirmed by their characterization data, that is proton NMR, carbon 30, mass spectrometry, and FTIR. Their biological activities were predicted using the Pass Online tool, which indicated the potential anti-cancer properties. To further assess their efficacy, the synthesized triazoles were evaluated for anti-cancer activity against the MCF7 breast cancer cell line. Additionally, molecular talking studies were performed to analyze their interactions at the adriamycin binding site of the non-reductase 2 having the PDB ID 4ZVM protein. Introduction. Cancer, which has been recognized as the severe health ailment after cardiovascular disease, which and has caused the millions of deaths every year. Drug resistance and side effects are major causes that increase the demand for novel and potential drugs in medicinal chemistry. And it has been found that heterocycles and hybrids have been used as potential anti-cancer candidates. A series of 1,2,4,4,3-B pyridazines were synthesized via the intramolecular oxidative cyclization of corresponding hydrazone derivatives in aqueous medium, utilizing the IBD, that is iodobenzene diacetate. These compounds were assessed for their in vitro cytotoxicity against the Vero cell line and their anti-cancer efficacy against the breast carcinoma cell line. The cytotoxicity demonstrated that most compounds induced a dose-dependent reduction in cell viability with higher concentrations, generally yielding greater cytotoxic effects. Notably, compounds bearing 2,5-dimethoxyphenyl, 2-furyl, 2-pyridyl, and 3,4,5-trimethoxyphenyl substitutes exhibited the significant anti-cancer potential with GI50 values of 44, 22, 44, and 22 microgram per ml respectively. Additionally, the interaction of these potent compounds with the oxidized quinone reductase 2 NQO2 enzyme was investigated through molecular docking studies. All the potent compounds exhibited one or more hydrogen bonds with the amino acid residue of the reported enzyme NOQ2 with negative binding energy, consistent with the experimental outcomes. Molecular docking study as well as the biological anti-cancer assay suggest that the compounds are potent candidates and further optimization is needed to improve the efficacy. Now, results and discussion. At first, we discussed about how we synthesize the compounds, the methodology used. In the first step, to synthesize the targeted compounds, in the first step, we reacted the acetophenone with glyoxylic acid and hydrogen hydrate under refluxing condition to obtain the corresponding pyridagenone. And then this pyridagenone was treated with excess of POCl3 to convert into corresponding chloro derivative. And then this chloro derivative was reacted with hydrogen hydrate under refluxing conditions again to obtain the corresponding hydrogen. And this hydrogen was then reacted with different kind of aromatic aldehydes in ethanol under refluxing conditions for 2 hours to obtain the different kind of hydrogen derivatives. And then finally, these hydrogen derivatives were intramolecularly cyclized to obtain the corresponding triazole derivatives in excellent yield in aqueous medium using the hypervalent iodine reagent IBD and at room temperature. And these compounds, the structure of all these compounds was confirmed by their spectroscopic data, that is proton NMR, IR spectra, and mass spectrometry, and carbon-13. The spectral data of one of the compound labeled as 7A is given here. In this compound, whose structure is shown here, we found in the proton NMR spectra, we found the for three protons of methoxy group. We found the chemical shift at 3.93 and a singlet was obtained, and all other aromatic protons were obtained in the aromatic region, that is 6 to 8.56 chemical shift region. And also in the carbon-13 spectra, we found the peak corresponding to the different carbons. And similarly, in the IR spectra, stretching frequency was found for different functional group like enhancing stretching frequency and C double bond and stretching frequency data is given here. And similarly, for this compound having the molecular mass 302, M+1 peak was obtained as 303. And similarly, for other compounds, spectral data was found, and which confirmed the structure of all these compounds. Now, anti-cancer activity of synthesized compounds. Synthesized compounds were then checked for their anti-cancer activity, and we found that out of total 15 compounds that we have synthesized, 4 compounds were having the more potent anti-cancer activity. That is the compounds labeled as 7K, having the furan group as a substituent, and 3,4,5 trimethoxy group substituted compound, and 2,5-dimethoxy phenyl substituted group, and the pyridine substituted triazole derivative. These all 4 compounds were having the GI50 value very close to 10. Our standard drug adriamycin was having the GI50 value less than 10, and our compounds were having the GI50 value 22 and 44, which is very close to adriamycin. And also a cytotoxic study were done against the Vero cell line for these compounds, and it was found that with decreasing concentration of the compounds, cytotoxicity was also decreasing. Also, molecular docking studies of these compounds was done with the using the NQO2 protein, and it was found that our synthesized compounds were having the negative binding energy with the amino acid residues and were having at least one or more hydrogen bonds, which was according to our experimental results obtained. And in conclusion, we have synthesized a series of 1,2,4 triazolo 4,3-B pyridazine derivatives via oxidative cyclization of pyridazinyl hydrogens in aqueous medium at room temperature. The use of hypervalent iodine reagent as sole oxidant and water as solvent makes the synthetic procedure green. The structure of synthesized compounds was assigned using NMR, FTIR, and mass spectrometry. The anti-cancer activity against the MCF breast carcinoma cell line was investigated, and among all the 1,2,4 triazolo 4,3-B pyridazine derivatives, compounds having 2,5-dimethoxyphenyl, 2-phenyl, 2-pyridyl, and 3,4,5-trimethoxyphenyl at 3 position of triazole were found to be most potent against the MCF7 cell line. Acknowledgements. We acknowledge the CSIR New Delhi for providing the financial support in the form of Junior Research Fellowship. And we also thank the chairperson, Department of Chemistry, Chaudhary Bansilal University, for providing the facilities in the department. We also sincerely thank HAU Hisar and Guru Jambheshwar University of Science and Technology Hisar for sample analysis. We would also like to acknowledge Anti-Cancer Drug Screening Facility, Advanced Center for Treatment, Research and Education in Cancer, Tata Memorial Center, Navi Mumbai, Maharashtra, for providing results of anti-cancer activity on breast carcinoma cell. Thank you, sir. These are the references. Hello, sir. Hello.
Rinku ma'am.
Haan ji, sir.
Yes. Thank you. Thank you. It was a very nice presentation.
Okay, thank you, sir.
Is there any question from the audience?
Madam,
Haan ji, sir. Yes, sir.
you have synthesized about 15
Yes, sir.
derivatives.
Yes, sir.
You have not mentioned what is R. R is
Sir,
all
R
of
is here
aromatic
aryl group.
aryl groups.
Actually, space problem. That's why. Maybe sir, मुझे ध्यान नहीं रहा होगा. Sir, ये R is the here aryl group. Different kind of aromatic aldehydes we have used, and we have also used the heterocycles.
Okay.
Yes,
None
sir.
of these aliphatic.
No, sir.
Okay.
Every one was aromatic. Every
Okay.
compound was. Yes, sir.
Rinku ma'am.
Yes, sir.
In your scheme.
Yes, sir.
In the second step, when
Yes,
you
sir.
treat your compound 3 with POCl3,
yes, sir.
What type of medium you have used? You have not mentioned there.
Sir, we have not used any medium here. Medium.
Okay.
Sir, we directly use this pyridazinone, and then POCl3 was added drop by
added
drop. Sorry,
in
sir.
excess.
Sir, slightly ethanol was added. Only 10 ml, sir. 10
Okay.
ml ethanol. Yes, sir.
And the second question is, what type of softwares you have used for the molecular docking?
Sorry, sir.
For molecular docking purpose, which
Yes, sir.
softwares you have used?
सर ये मोलिकुलर डॉकिंग के लिए सर एग्जैक्टली मुझे याद नहीं आ रहा. वो काफी दिन हो गए हमें मोलिकुलर डॉकिंग करे हुए. सर क्या सर डिस्कवरी स्टूडियो. यस सर. डिस्कवरी स्टूडियो करके है सर, उससे किया हमने.
अच्छा.
यस सर.
ओके, थैंक यू.
ओके सर, वेलकम सर.
नेक्स्ट वन प्लीज.
Thank you, sir. Thank you, ma'am. Next one is Sachin Chaudhary.
Hello.
Yes.
Sir, my voice is audible?
Yes.
Yes, sir.
Yes, sir. Sir, and my slide is visible?
Yes, yes.
Okay. So, good afternoon to all the dignitaries present here. My name is Sachin Dhanpal Chaudhary, a research scholar from Institute of Science College, Nagpur. So, My title for project poster presentation is Engineering a Synergistic Interface Zinc Indium Sulfate Decorated to a Copper BTC MOF for efficient recalcitrant in die. So moving toward the abstract of this research work, this study involved a novel photocatalyst that is uh, zinc indium sulfide decorated on copper BTC MOF synthesized via in situ method with varying zinc indium sulfate concentration, that is 10%, 20% loading and 30%. So the purpose of loading is it enhance the degradation of recalcitrant dyes such as methylene blue under visible light. The composite benefit from zinc indium sulfate has photocatalytic properties and high surface area of copper BTC MOF, facilitating the effective dye adsorption as well as degradation. Now the background and concept of my topic is as the textile. We know that India is one of the larger producer of textile industry. So textile industry wastewater is a big problem because dyes pollute rivers and lake. These dye don't break down easily, block sunlight in water bodies, and are toxic to marine life and human. So traditional method like chemical treatment or filtration have drawbacks such as producing more waste or being expensive. So this is a new hybrid material uses sunlight to break down dyes efficiently, making it more sustainable solution. So this is the schematic diagram of my synthesized scheme. That is a single step salvothermal method was used to fabricate the composite. Zinc indium sulfate was decorated on copper BTC MOF at different loading, that is 10%, 20%, 30%. The process involved stirring, sonication, salvothermal treatment at 120 degrees Celsius for 24 hours, then washing, and last is drying. So the morphological analysis of the synthesized catalyst was done by using same images. These are the same images of my synthesized catalyst. This is the same images of copper BTC MOF, and these are the different loading of zinc indium sulfate on the copper BTC MOF. The structure of copper BTC MOF is octahedral. This is the octahedral structure which is shown by using the same analysis. Now next is the characterization. The synthesized novel material was characterized by UV-DRS, FTIR, XRD, and Raman photoluminance properties. So by using UV-DRS shows the how zinc indium sulfate affect the light absorption. Next is the XRD. XRD confirm the presence of zinc indium sulfate. Then Raman shows the change in the value of intensity of D by intensity of G ratio, indicating the deoxygenation of carbon due to zinc indium sulfate. Then FTIR verify the functional group and structural changes after adding the zinc indium sulfate. This is the FTIR spectra of synthesized material. Now, then photoluminance indicate the zinc indium sulfate lower the PL intensity. Here see the intensity of PL graph of synthesized material was lower due to adding the different percentage of zinc indium sulfate loading. So this reducing the recombination of photo-generated charges, which improve the photocatalytic performance. This analysis, all the analysis confirm the successful synthesis and properties of the composite material. Now next is after synthesize the material, we analyze we perform the degradation experiment. This is the degradation experimental setup of methylene blue dye degradation. We can degraded methylene blue dye with the help of our synthesized catalyst, and observe the reading with the help of UV light. See the spectra. After 30 minutes, after 30 minutes, the second composite CUM-Z2 minimize the absorbance peak of methylene blue. Then we also conduct various experiment, that is the initial dye concentration, then wait, initial dye concentration. Wait, sir. Initial dye concentration, then catalyst dosage also recorded. Then zinc indium sulfate decorated and copper BTC MOF is composite material made of zinc indium sulfate and copper BTC MOF. Its role in dye degradation is it to enhance the breakdown of dye molecule in wastewater. Here the photocatalysis zinc indium sulfate absorb the light and generate reactive species like electron and hole, and that break down the dye molecule. Then copper BTC MF has a large surface area, helping trap dye molecule near the catalyst for better degradation. Then the combined effect of the synthesized material improve the efficiency by enhancing charge separation, preventing the recombination of electron and holes, and increasing the dye interaction with the catalyst. So this is all about my research topic. Thank you. Thank you, all of you. Hello?
Thank you, Sachin, sir.
Yes, sir.
Thank you.
Thank you, sir.
Is our study limited only methylene blue dye?
No, sir. We can use this material for a real analysis dye also, from textile dye also. But we can, the study is not complete. That's why I am not included in the PPT.
Okay, okay.
Yes, sir.
Thank you.
Okay, thank you, sir.
Now,
Can I stop this
go
sharing?
for the next one. Yes, sir.
Yes, sir. Thank you, sir.
Next.
Thank you, sir. The next participant is Miss Subin Amrit. Miss Subin Amrit, are you there? Okay, I think she is not available with us. We'll go for the next participant. Miss Sohi Gilmar.
Yes, sir. Hello, sir. I am audible.
Ma'am?
Yes, sir.
You are audible. Share your screen and go on.
Yes, sir. Sorry.
Yes. Okay.
Yes, ma'am. Just enlarge your image.
Hello.
Yes. Just enlarge your document and go on.
Is it okay, sir? Okay. Sir, it is in PPT form. Sorry, PDF form.
Yes. Can you enlarge? Otherwise, you can go on. No issue.
Okay, sir. Okay. Thank you, sir. Good afternoon. I am Vaishnavi Gidmare, presenting my poster as a PhD candidate in chemistry under the supervision of Professor ICISSD. Phosphorus modified cytosine, another pseudosane composite, sustainable, transparent, bio-based flame retardant coating for cotton fabric is the title of my presentation. Flame retardants are any chemicals added to manufactured materials such as plastics, textiles, and surface coatings to inhibit, suppress, or delay the production of flames and prevent the spread of fire. Synthetic and natural polymers are now essential in wide range of industries, including industrial, furniture, and housing, due to technological advancement and improved production capabilities. Concerns about fire safety have increased due to the widespread usage of this synthetic material, especially
textiles, polyurethane foam, and plastic. The increased risk is demonstrated by thousands of fatal fire events that occur worldwide each year. According to the estimates from the Health Organization, that is WHO, 1,80,000 people die as a result of fire each year. The CTIF World Fire Statistics Report states that in 2022, fire-related incidents were responsible for 26,000 deaths with over 3.6 million fires registered annually, resulting in over 7 million injuries. According to the latest data from the NCRB, that is National Crime Records Bureau, 13,729 people died as a consequence of fire incident with over 12,000 of deaths occurring in residential buildings. The terrible pattern underscores the urgent need for enhanced safety protocols as demonstrated by the nation's recent big tragedies. Uh, these events highlight the severe consequence of insufficient safety procedures and the vital need of handling fire threats in many countries. The installation of sophisticated fire alarm systems and the use of flame retardant technologies are the two primary approaches that researchers have investigated to satisfy these needs. While conventional sensors, including smoke and infrared detectors, frequently have limitations that cause warning signals due to delayed fire alarm sensors and made to immediately identify fire threats. Conventional flame retardants have proven successful in reducing the fire risk, especially those on phosphorus, nitrogen, and halogen. They also provide serious health and environmental risks. Flame retardant based on halogen in particular emit toxic smoke and hazardous chemical that pose major risks to public health and the environment. More eco-friendly non-halogen flame retardant material are being developed as a result of this concern. The objective of the study is to create a bio-based flame retardant material with the goal of enhanced flame retardancy, better mechanical properties, moisture resistance, real-time fire detection, and environmental benefits. This work focuses on preparation of bio-based flame retardant material composed of banana pseudostem. I have done a comparative study in which banana pseudostem is coated in cotton, and also chitosan banana pseudostem cotton, phosphorylated banana pseudostem cotton, and phosphorylated chitosan banana pseudostem cotton are prepared and flame test is done to the material. All the composition has different ignite. The phosphorylated chitosan banana pseudostem cotton has an ignite time of 150 seconds, which is behaving more prominent as a flame retardant material. And its limiting oxygen index is 48 with 2 centimeters of charge. And the prepared material is characterized by using various analyses such as SAME, XPS, EDX, showing the presence of carbon, oxygen, phosphorus, and nitrogen. Thermogravimetric analysis of control code and phosphorylated chitosan banana pseudostem cloth data shows that control cotton cloth is stable at low temperature, but it decomposes quickly at higher temperature. But the prepared material is having stability at higher temperature, hence it can sustain fire at higher temperature and thus ensuring more free time. It is notable because in comparison to standard options, flame retardant can control environmental issues and increase fire safety. The primary objective of this emerging discipline is the creation of sustainable material that provide effective flame resistance and fire alarm in a shorter amount of time. A delay in lightning that might give people more time to flee and stop the fire from spreading. Green chemistry principle must be incorporated into flame retardant design in order to progress the field and ensure compliance with environmental regulation. Also, using bio-based material with better fire system safety alarm can make fire detection and response system more dependable and responsive. And evaluating the health consequence of traditional and bio-based flame retardant. Aim of this study is to create bio-based, safer, more affordable, non-toxic, and incredibly effective fire retardant materials for use in cutting-edge fireproof application. Thank you. Hello.
Yes, thank you.
Thank you.
Is there any query? Vaishnavi ma'am,
Yes, sir.
how you characterize your material?
Sir, I have characterized it by using XPS, EDX, EDX, that is elemental mapping. Also, I have done TGA and also had same images, same
Oh,
analysis.
thank you.
Yes. Thank you, sir.
Next one. Yes, sir. Miss Monali is there?
Yes, sir. Am I audible?
Yes, ma'am. Please go on.
Good afternoon, sir. Can I share my screen?
Yes. This one is the last presentation of our session. Monali Lohkare, ma'am.
Yes, sir. Good afternoon,
ma'am.
respected dignitaries. Good afternoon, respected juries. Myself, Monali Lohkare. I'm from Digital Biyani Science College, Amravati. I'm pursuing PhD under the guidance of respected Dr. Narendra Shahare, sir, who is the Professor and Head Department of Botany, Digital Biyani Science College. I'm presenting my research work under the title of Diversity and Isolation of Endophytic Fungi isolated from the medicinal plant Clitoria ternate. Here my abstract is, endophytes refer to bacteria, fungi, actinomycetes, and algae which spend their whole life cycle in the symplast or apoplast region of plant. Endophytic fungi are the fungi that live within the internal tissues of plant without causing apparent harm to their host. They have been known to play a crucial role in enhancing plant growth, nutrient uptake, and resistance against pathogens. These fungi are known to be produce biologically active compounds that can be used for medicinal purposes. That is, the Clitoria ternata is a high quality protein-rich legume plant having a very significant medicinal value used as a traditional Ayurvedic medicine for several human diseases from centuries, like memory enhancer, nootropic, anti-stress, anxiolytic, antidepressant, anticonvulsant, then transcleaning, and the sedative agent. Here in this study, I have isolated 9 different fungal endophytes have been identified from the leaves and stem tissue from the Clitoria ternate plant. From the 3 different areas of Amravati district, likewise Loni, then Akoli Road, and Shirazga. These 3 sites are decided to collect the plant material. From the endophytic fungi, namely Fusarium species, Carula renata, Diplodia species, Cladosporium species, 3 different species of Aspergillus, Penicillium species, and Alternaria species are isolated. Aspergillus species and Fusarium species abundantly isolated from the stem and leaf of Clitoria ternate plant. In this study, further evaluations of the research is in progress. The outcome of this study will demonstrate the potential of endophytic fungi from medicinal plant as a source of novel bioactive compounds for drug discovery. Finding of this research contribute the knowledge of plant-fungal interaction and offer potential insights for future biotechnological application in various fields such as sustainable plant growth, medicine, agriculture, and ecological maintenance. The keywords of my abstract is endophytic fungi, Clitoria ternate plant, medicinal properties, Fusarium species, Aspergillus species, and Diplodia species. Now I come to the material and method. For this isolation, I'm following the material method from collection of plant material from the different localities of Amravati district. These are the young and healthy plants. Then again, sample for isolation of endophytic fungi are performing the surface sterilization process with the help of chemical sterilant by using sodium hypochlorite 4% to 5% sodium hypochlorite, 70% ethanol, and the double distilled water. And for isolation, I'm using a nutrient medium, that is the PDA, potato dextrose agar, which is freshly prepared in the lab. Then inoculation method and isolation method will be performed for the isolation. Here are the result of my research. There are the 9 different species of fungus, Fusarium, Diplodia, Aspergillus, Penicillium, Cladosporium, isolated from the stem of Clitoria, and Carvularia lunata, Alternaria species, Aspergillus species, another Aspergillus species. I have shown some pictures of my fungal isolates. So these are some photos I have mentioned. The conclusion of this, to find out the different types of strains of fungi which have the different types of medicinal properties which are used to give potential for the plant. So the study has revealed a rich and varied microbiome associated with these medicinal plant. The finding indicate the endophyte fungi play a crucial role medicine in the plant health, potential enhancing in resistance to pathogen and environmental stressors. The identification of various fungal species through morphological and microphotograph technique, further identification on the species level will be done on a molecular level. The ecological role of these endophytes warrant further investigation, particularly in the context of their potential application in agriculture, medicine, and the biotechnology. Moreover, this research underscores the significance of preserving natural habitat, as the discovery of endophytic fungi may be closely linked to the ecological vitality of the Clitoria ternate populations in Amravati. Further studies should focus on the exploring the interaction between these endophytes and their host, as well as their bioactive compound, which could be hello. Can you hear me? Hello.
Yes, ma'am. Continue, please.
Yes, yes. Thank you. Which could be lead to the discovery of new neutral products, natural products with pharmaceutical potential. Ultimately, the insight gained from this study contribute to the broader understanding of plant-fungi relationship and the ecological dynamics of the endophytes in medicinal plant. The main motto of my study is find out the novel bioactive compound which are used for the formation of different drugs, because this is the highly medicinal plant, highly protein-rich plant. So because of these reasons, I have selected this plant. These are the number of medicinal properties. That's the high quality protein-rich legume, but it has in before study, glyotides is the bioactive compound which is isolated from this plant. So it has the different types of medicinal properties. So my focus on this research is to find out the different exact endophytes which used to form this particular bioactive compound. And these are some references. Thank you so much.
Yes. Is there any question?
Can I stop my share screen, sir?
Yes, ma'am. Thank you.
Thank you so much.
Hello.
Yes.
Sir, can I show you my electrochemical setup for 30 seconds?
No, sir. We are running so late. There
Just
is a
30 seconds.
session for the
Valedictory, I
conclude.
know, sir.
Yes. Kurari, sir.
Sir.
Over to you, sir.
Thank you. Congratulations to distinguished researchers of poster presentation. Research work of all participants is really appreciable. Now, behalf of Narsamma Art, Commerce and Science College, I am thankful to jury Dr. Manohare sir as well as Lunge sir. I am also thankful to organizer for giving me chance to chair this poster session. Thank you. Now I declare that this poster presentation session is over. Thank you. Thank you very much.
Thank you, sir. Over to you, sir. Mangesh, sir.
Yes, sir. Thank you all for your active participation in this session. We appreciate the hard work and dedication that has gone into each of the presentations. Our judges will now declare the select and best presentation, which will be announced during the closing ceremony. I am very much thankful to Dr. Purade sir, Dr. Manore sir, and Dr. Lungi sir for their cooperation. And also, I am very much thankful to all the speakers and participants for their active participation. Thank you very much all. Now, let us take a short break before proceed for the valedictory session. Very soon, within 2 or 3 minutes, we will join again for the valedictory session. Thank you very much all. Thank you so much.
Thank you, sir.
Thank you.
ये शुरू हो गया लगता है वैलिडिक्शन।
जल्दी आपका नाम आए।
मेरा नहीं आएगा, कैसा आएगा?
हमारा तो नहीं आएगा, पर मैंने
नहीं, तेरा आ सकता है।
हमारा कहाँ से आएगा?
क्यों नहीं आएगा? स्टूडेंट्स में
स्टूडेंट्स कैसे देंगे? पोस्ट ग्रेजुएट वाले हैं ना उसमें।
I welcome all the dignitaries here. Please, dear friends, I am honored and happy to have the opportunity to anchor the valedictory session of two-day international research and academic event, that is International Conference on Innovations in Sciences for Sustainable Development. I also request Honorable
Dr. Sikan Kalekar Sarji to please chair this function. A special and esteemed guest is Dr. Madam Manisha Kodape to please accept the request and be on the guest chair, please, madam. I also request all the frontier team of this conference ICISSD 2025, Honorable IQOC Coordinator Dr. Chandrasekhar Savarkar, Head of the Department of Chemistry Dr. Sikan Bansod, please come on the dais. Dr. Mahendra Singh Pawar, Organizing Secretary, Professor S.P. Deshmukh, Dr. Atish Maldure, please, sir. Actually, this particular event is a notable event in the history of our Srimati Narsamma Arts, Commerce and Science College, Amravati, because this is an international event. And in this particular event, more than 550 participants were engaged in various working committees as well as registered participants. And the registered participants in all the categories are 475. And around 259 abstracts were published in the form of manual, and so many abstracts, late abstracts will also be published along with this in the e-copy. I request Dr. Atish Maldure, who is convener of this grand event, grand success event, to please felicitate Honorable Chairman of this particular function, Dr. Sikanji Kalekar, by offering him a memento, a short slipper, and a sapling. Please. Please, beta. Dr. Srikanji Kalekar is a well-known personality of our institute, and he is honorable member of Senate of Sant Garge Baba Amravati University, Amravati, and he also worked as a supporter to the college always. He always guide in various areas of the institutional governance, and he is also the member of Srimati Narsamma Shaikshanik Trust, Amravati. He is an executive member. Thank you very much. Then, Honorable Member of Management Council, Madam Dr. Manisha Kodape. I request Madam Smita Suryanshi to please come on the dais and honor Madam Dr. Kodape by offering a sapling, short report, and a memento. Please, madam. Madam Kodape is having 20 years of experience, 3 UG and around 17 years PG at Sant Garge Baba Amravati University, Amravati. She is presently working as associate professor in the department, and she has many achievements. She was previously at JD Patil Sarvotkar Mahadhyalaya, Daryapur of Amravati district. Her area of research is synthetic organic chemistry, green chemistry, and phytochemical analysis. She has a vast research experience. Thank you, Suryanshi, madam. Thank you, Kodala, madam. Please. Then, I request Dr. Shankar to please come on the dais and please offer a sapling and a memento to Dr. Chandrasekhar Savarkar, who is coordinator of ICISSD of our college. Please. Sapling. I also request Dr. Narsamma to please come on the dais and welcome Head of the Department of Chemistry, Dr. Srikanth Bansal. Actually, it is a welcome as well as the honor to the team who were frontiers of this particular conference. Then I also request Madam Pathak, Gayatri Pathak, to please come on the dais and honor Dr. Mahendra Singh Phalar, who is organizing secretary of this particular grand event. Please. It is a welcome as well as the honor from the college. Then I also request Dr. Gayatri to please come on the dais and honor Dr. Atish Valgore, who is convener of this grand event. Memento, please. Thank you very much. I request all the members, participants, the teachers, and non-teaching staff, and many persons who have actually helped for the success of this particular grand event, because 550 participants or to collect the 550 participants is not a joke. Since I think this is an online display program, I think so. I request if there is a Shraddha Thakare for her opinion about this particular conference.
Good afternoon, sir. Am I audible?
Yes, sir.
Good afternoon, everyone, respected dignitaries, esteemed guests, fellow attendees, and all delegates. I am Ms. Shraddha Thakre, a research scholar in physics department, Narsamma Arts, Commerce, Science College, Amravati. I'm honored to review the Innovation in Science for Sustainable Development ICISSD 2025 that has come to successful conclusion. On behalf of my organizing committee, I would like to extend our heartfelt gratitude to each and every one of you for making this conference a resounding success. Over the 2 days, the conference features engaging keynote addresses, inside panel discussion, and research presentation in both oral and poster format. This session, held in online mode, provide a platform for a scholar and professional to share cutting edge research and explore innovative solutions for the sustainable scientific development. Topic covered from nanotechnology, green chemistry, renewable energy resources, and environmental sustainable to advancement in material science and their industrial applications. The diversity of research showcased the interdisciplinary nature of scientific progress towards sustainability. The conference provided a platform for attendees to connect with the industry leaders, engage the provoking discussion, and further meaningful collaboration. Hello. First and foremost, I would like to express my heartfelt gratitude to the conference organizers, sponsor, and volunteers for their tireless effort in making this conference resounding success. Your dedication, hard work, and attention to detail have not gone unnoticed. To our esteemed speaker, I would like to thank you for sharing your knowledge, expertise, and experiences with us. Your presentation were informative, engaging, and provoking, and we are grateful for your contribution to the conference. To our delegate, I would like to thank you for your active participation, insightful questions, and engaging discussions. Your enthusiasm and passion for the sustainable development are truly inspiring, and we hope that this conference has provided you with a valuable insight, new connections, and renewed motivation for pursue your goal. As we conclude this conference, I would like to reflect on the key takeaways from our discussion. We have learned about the latest advancement in science for a sustainable development, including innovative technologies, best practices, and successful case studies. We have also discussed the challenges and opportunities facing sustainable development and the importance of the collaboration, innovation, and collective action in addressing these challenges. As we move forward, I urge you to all continue the conversation, connections, collaboration that we have started here. Let us work together to harness the power of science and innovation to create a more sustainable, equitable, and prosperous future for us. In closing, I would like to thank you all once again for your participation, enthusiasm, and commitment to the sustainable development. Let us work together to create a brighter, more sustainable future for all of us. Thank you.
Thank you, Shraddha. Thank you, Vijay.
Thank you, sir.
I think this was the opinion through online mode. If anybody is interested to put his opinion, his or her here, then he will also be welcome. Please. कोणाला बोलायचं असेल तर प्लीज. I think Professor Dr. Vasudev Gurnode is there in the meeting. I think so. Online meeting. Who is a continuous source of inspiration as well as a tremendous source of energy behind this conference. And if sir is there, please sir. Gurnode sir आहेत का त्याच्यामध्ये? ठीक आहे, it's okay. If he will be available, then we will call him later. I request one of the participants, Dr. Nandakishore Gawade, to please come. And he is also one of the jury's members. I request him to please come on the dais. Please.
Chairman of this valedictory session, honorable persons present, honorable persons present on this dais, Dr. Kiran, Dr. Manisha Kolake, Dr. Bansod sir, Dr. Pawar sir, Dr. Atish Malgure, convener of this international conference. So I think the grand success of this international conference is that it is not only the discussion, but in these 2 days, I observed all the sessions. I have gone through the inauguration, and I have gone through the resource persons invited talk, and I have gone through the presentation. In one of the session, I am a jury of that oral presentation session. So each and every participant, online participant in this conference, have presented their work in a fantastic way, and the participants are from all the domains. It is not from the chemistry background, it is also from pharmacy background, it is from biology background, it is from physics background. So I think that is the success of any conference. It is not numbers of participation, but that participants are totally get involved in that all the processes, and throughout I can see that all the participants are also present online and they are attending this validation session. I think such conferences in such a one of the small college in Amravati, at a district place, should be organized and should be it is a motivating such organization of such conference is motivating for all of us faculties, all of researchers, and all of the students because the participation, the part of every faculty, the part of every non-teaching faculty, the part of every researcher, the part of every student is important. And I have seen in last 2 days, I have seen all these communications and connections and all the coordination in this team. Thank you for becoming me a of the session, and I am thankful to organizers and my friends on sitting on the dais, all belonging to the chemistry and of the dais. Most of them are familiar with me, and I am also familiar with them. So thank you very much, and I give plenty of wishes, best wishes to the colleges, and in upcoming year, this college must be flourished and get higher degrees of achievement in upcoming future. Thank you very much.
Thank you, Dr. Gawade, for your comment. I request Dr. Umesh Khandekar, Head of the Department of Chemistry, please come on the dais. I welcome you. Dr. Gawade, I want to extend your comment. Actually, it is the beauty of this particular international conference that many of the maximum number of participants were present through online mode. Means normally it happens, the participants are just logged in and they are just putting only the login and they are getting interacted and all these things. Thank you very much for your comment. Then I think Gurulore sir, it's okay. I request, since I already have yes said here that more than 550 participants and more than 475 registrations were there, and abstracts also, and around 169 oral and the paper presentations were there, and among that, the oral presentations by the researchers and the teacher participants were there, and since this was a competition kind of thing, therefore there is a rank, no doubt. And there is also a rank for the poster presentations among all the categories, including UG, PG, then teachers and other researchers. For the purpose to work for this rigorously, that is the Head of the Department of Industrial Chemistry, Dr. Umesh Khandekar. I call you, I request you to please come on the newer the mic to present his what you say, result. Please, sir.
Good evening, all of you. Honorable dignitaries on the dais and participants. It's my great pleasure to announce the winner of the oral and poster presentations at the International Conference on Innovations in Science for Sustainable Development. Sir, total 40 participants were presented their research work in oral presentation section, while in poster presentation section there are total 10 participants. After careful evaluation of our expert judges, we are delighted to announce the following winners. Winners from oral presentation category. The third winner, Miss Nikita Vyavare. She is working for her PhD degree with the Department of Chemistry, Savitribai Phule, Pune University, Pune. Miss Nikita Vyavare. The third prize goes to Miss Nikita Vyavare. The second winner for the oral presentation, Dr. Prachi Bonde. She is assistant professor at Indira Mahavidyalaya, Kalam, Yavatmal district, Maharashtra. And the first winner for poster presentation, Miss Pratiksha Gaikwad. She is working for her PhD degree at Uttar Maharashtra Institute of Engineering and Technology, Pune. Now come to the poster section. From poster sections, our judges impressed by the quality of poster presented, and we are pleased to announce the following winners. The winner of third prize for the poster presentation is Miss Vaishnavi Gitmare. She is a research student from Bajaj College of Science, Wardha. The second prize goes to Mr. Kunal Dhawale. He is a research scholar from CSIR Nagpur. While the first prize goes to Miss Rinku Soni. She is from Chaudhary Bansilal University, Prem Nagar, Bhiwani. She is also a research scholar and working for her PhD degree. Congratulations to the winners. We congratulate the winners on their outstanding research work and presentations. We are also thankful to all the participants for their contributions to the conference and for making it success. The winners will receive certificates of excellence to their personal email. So once again, congratulations and thank you very much. Thank you.
Thank you, Dr. Khandekar. I also congratulate all the winners and the participants on behalf of this event as well as the college. As we know, we have a person from the Management Council of Sant Gadge Baba Amravati University, Amravati, and I already have introduced her that she has a 20 years of experience, 17 plus year in PG and 3 in UG, and she is a hardcore researcher. Her topic of research is synthetic organic chemistry, fluorescent molecules, green chemistry, phytochemical analysis, and she has a vast research experience also. And without wasting of time, I request Honorable Dr. Madam Manisha Kodape to please guide us. Please.
With a due respect to Sant Gadge Baba, dignitaries on the dais, Chairman of this valedictory function, Dr. Shrikant Kaikar sir, ICISSD Director Savarkar sir, Dr. Bansal sir, Dr. Pawar sir, Dr. Khandekar sir, convener of this conference, international conference, Dr. Maldure sir, and comparing this session by Dr. Vajpayee sir. Thank you for such a nice introduction, sir. In front of the dais, all the dignitaries, researchers, delegates, faculty members from this institute. First of all, I just want to congratulate the organizer for the grand success of this event. As it has been discussed, while discussing with the Maldure sir, he said that more than 500 students, participants from all over the country, and not only the country, but outside the country, they have registered as well as they have participated. These students, I mean, in oral presentation also, The presentations were from the abroad students were there. So I think this is the grand success for this international conference. More than 5 resource persons, they have on the international platform, they have delivered lectures. And all the delegates, participants, they are inspired by this talk, by these sessions. I'm very sure that by listening to the resource persons from the yesterday, all the participants and the delegates, they are inspired and now they are ready to chase the balances, whatever challenges that will come for the sustainable development. Maybe for this event, it will be helpful for all the delegates to collaborate with one another by doing interdisciplinary collaboration. As somebody has rightly said that there are participants from the different disciplines, different subjects, they have participated and shared their ideas. Being a person of a chemistry, what I think is sustainable development is all about, and what should we gain from the such kind of conferences. One thing that we will do, that we can gain a knowledge and we can give a process so that there should not be any hazardous things that will be give a bad impact on the environment. So we should develop our own methodology. We should develop a process that will minimize the environmental hazards. And another thing, as we are in the 21st century and we are facing the challenges in front of us is for the sustainable development, maybe it's considering the renewable energy, maybe it's management of waste management or diversity conservation and many more. One thing that we can do, whatever problems are there around us, we should find out solution on that. And that is the purpose with which I think this international conference is organized. I hope you had a very good time. All the delegates, they have interacted with the resource persons also. And you might have gained many ideas to do research and contribute to the sustainable development in future. I am very grateful to the organizer for inviting me on this occasion. Actually, I wanted to come to the inaugural function, but because of some unavoidable circumstances, it is the request of Dr. Atish Maldure sir that you have to come to the valedictory function at least. So I am here. I am really very grateful that the organizers have given me this chance to share my ideas on this occasion and given me an opportunity to witness this grand success of international conference. And I congratulate all the delegates, participants, the others who have contributed for the successful organization of this event. Thank you very much.
For your blessing, and there is no doubt to assure you about extending the future collaborations with the many institutions and the persons. Definitely the challenges of 21st century, especially, it will be definitely accepted. We also have noted various and a variety of ideas to this particular conference and the presentations and all these things. Thank you very much. I request one of the key persons behind this conference, Dr. Dinesh Satangi, please come up. And I also request Dr. Pawar to please felicitate him by offering a sapling as well as a memento. Please, sir. And Dada, please. And I. Please. Now I request. I will be the key person behind each and every event of the college and the institution. That is IQAC coordinator. I request Dr. Chandrasekhar Savarkar to please guide us with your special words.
Dignitaries present on the dais and all the dignitaries and participants of the dais. A very good evening to all of you. Being IQAC coordinator, Vajpayee sir said that I am the key person in all the events of this college. This is not very true. Everybody in this college is the key person for something happening good in this college. I am just noted in that way, but the fact is something different. It is a teamwork. It is always a teamwork. Our management and the principal has been always the constant source of inspiration for all of us to do something good, to do something new. So, on behalf of the institution, I welcome all of you to this valedictory function of this international conference. It is with immense pleasure and deep sense of fulfillment that I stand before you today as we conclude this remarkable international conference on innovations in science for sustainable development. This conference provided a wonderful platform for convergence of brilliant minds for collaborative learning and growth. This international event was the culmination of 2 days of fruitful deliberations, knowledge sharing, and research presentations by educators, industrialists, and researchers from all over India and abroad also. 475 plus delegates have participated in this conference. Over the past 2 days, we have witnessed an enriching exchange of knowledge, thought-provoking discussions, and research presentations that highlight the pivotal role of science and innovation in shaping a sustainable future. Each session has reinforced the importance of scientific innovations in addressing the global challenges of sustainability. The insights shared by our esteemed speakers and researchers have provided new perspectives and directions for the future. The conference has been successful in providing a platform where the interaction of diverse viewpoints created a reservoir of knowledge capable of sharing the future of sustainability. A true sense of collaboration was visible during the working and conduct of the conference. We live in a knowledge economy where the acquisition of knowledge gives a competitive advantage. With India's average age being much below than that of the other countries, we must make use of the talented youth that we have to meet the goal of global dominance, which is the struggle we face in present day. Sustainable growth, sustainable development calls for empowering minds, and this particular conference will have met this purpose. As a IPSC coordinator, I am immensely proud of the role our institution has played in facilitating this dialogue. Quality and education and research is the cornerstone of the progress at platforms like this conference. These conferences serve as a catalyst in fostering academic excellence, collaborative research, and impactful solutions for the society. I extend my heartfelt gratitude to our chief guests, keynote speakers, panelists, and all the presenters for their invaluable contributions. Your expertise and commitment to scientific progress have truly enriched this event. A special thanks to our organizing committee, technical team, volunteers, and support staff whose hard work behind the scenes has made this conference a grand success. To our participants, I commend your enthusiasm and engagement. Your discussions, questions, and collaborations have made this conference a vibrant platform for learning and networking. I encourage you to carry forward the knowledge gained here and apply it in your respective fields for the betterment of the society. An event of this dimension cannot happen overnight. So this started slowly months in advance. Then I would like to take this moment to thank the very motivated and dedicated Department of Chemistry and the research committee members who made this conference immensely successful. If time is money, then today you have spent millions for us. Thank you all for making this conference possible. As we conclude, let this not be an end, but a new beginning. Continue our pursuit of sustainability, growth, science, and innovation. Let us remain contributed to translating ideas into actions that benefit both present and future generations. Once again, thank you all for being part of this journey. Wishing you all success in your future endeavors. Thank you.
Thank you, Savarkar sir. Being an ICSC coordinator, Dr. Savarkar has focused on the issues of his interest with ICSC. As many things are there behind his many fine ends during his speech. Thank you very much, sir. I request our patron and honorable member of Senate of Sant Garge Baba, Amravati University, Amravati, and a person from our key management who always used to just interact with each and every people in the college with various aspects, and he is the chairman of today's valedictory function, Honorable Dr. Srikanji Karikar. I request him to please guide us, sir. Please.
At the outset, I pay my homage to Ma Saraswati, Sant Gadge Maharaj, and Narsamma, whose name is given to this campus. The persons sitting on the dais today is Honorable Chief Guest, Dr. Manisha Kodape Madam, who is the Honorable Member of Management Council of Sant Gadge Baba University, Dr. Dinesh Kumar Satangi, Dr. Chandrasekhar Savarkar, Dr. Srikant Bansod, Dr. Pawar sir, Dr. Srikant Deshmukh, Dr. Atish Maldure, all the dignitaries of the dais. First of all, I congratulate all the winners in poster presentation as well as in the oral presentation. I will also congratulate all the participants who have participated online or offline in this international conference. I will also congratulate all the organizers and the persons and brains behind this successful event. The person who is front warrior is Dr. Atish Maldure, but his army, I know, a front warrior cannot fight without the support of his army, and the army is sitting in front of me. Therefore, I congratulate each one of this institute, maybe principal and maybe a class 4 person, because each and everyone has contributed to the grand success of this event. Friends, 2-3 things I would like to present in front of you. I don't know whether you are marked it yesterday or not. every event, every inauguration event, it starts with the lighting of the ceremonial lamp. Normally, that lighting of the lamp is carried out either with the help of a matchstick or with the help of a wax candle. Yesterday's event was slightly different. Anybody has noticed the difference? For lighting the lamp, one lamp is provided to the guest. This should be the spirit of such international conference. In Hindi, we call it as Jyot se Jyot Jalai Chalo. One lamp lighting all the other lamps with the hands of dignitaries on the dais. This should be the spirit of such type of the international conference. I hope that after deliberations of 2 days, this spirit of knowledge, this lamp of knowledge has enlightened the minds of every participant and enlightened the participants who are from other states and from other countries. And this spirit of knowledge in chemistry, innovations of chemistry, will give the fruitful research. The topic of the, sorry, I forgot to congratulate one more agency, that is the Association of Chemistry Teachers, Mumbai, who has sponsored this event also, and who is, I think, the main body of the chemistry teachers in Maharashtra. So, on behalf of the management of this institute, I congratulate the office bearers of Association of Chemistry Teachers also. Today, the topic of this conference was innovations in science. From yesterday, you are hearing many deliberations on this topic. I will focus on only one word, that is the innovations. Innovations will mean something new, new molecule, new process. I have one more idea about innovation. Some new use of old things. A process is established in chemistry. Can we use that process for some new product? Madam is expert in biosynthesis of plant products. So various alkaloids, glycosides, all these things, they are started from a precursor. And normally we try to develop such type of product from any process in the laboratory. It happens in the plant naturally. We try to imitate that process in the laboratory, and we try to cut down the number of steps so that it becomes economical. So any old product, any old process, giving rise to some new result, giving rise to some new product, it is also the innovation. I'll give you a simple example. All of you know the name of aspirin. Aspirin, chemical name is acetyl salicylic acid. It belongs to the group of salicylates. So it is a pioneer analgesic antipyretic drug. It was nowadays, and later on, newer and newer analgesic antipyretic drugs were invented, and due to some of the adverse effects of salicylates, the use of aspirin as an analgesic antipyretic drug has declined. But over the course of time, nowadays nobody will use aspirin as an analgesic. What is the use of aspirin? Aspirin is nowadays used in heart diseases. Aspirin is nowadays used in heart diseases. So this is a classical example of one product which is very much familiar to us, which was used for some other purposes. Can we focus our knowledge on such type of the things that we can have new use of that particular product? Many chemical processes are there, many chemical products are there, many plants are there. I'll give you one more example. You know, pimpri. It contains piperine alkaloid. It has got some old uses, classical uses. Some 2 months back, I attended one conference in Vidyabharati College. The person who has presented his paper has worked on some novel use of that paper. What was that novel use? That paparin can be used as a bioenhancer. What is bioenhancer? Bioenhancer is a material, is a drug which increases the bioavailability. Bioavailability means the biological availability of that particular drug in the body. Normally we say that we take 500 milligrams of some drug. That entire drug will be available, but biologically available drug means the drug that mixes with the blood and then it is ready to produce its therapeutic effect. Bioenhancers are such drugs which can increase the bioavailability. And what is the advantage of this bioenhancer? It can reduce the dose of potent medicaments. The example that person has quoted was that there is an anti-tubercular drug, rifampicin. Its normal dose is 450 to 600 milligrams one time. Such 3 tablets or 3 capsules per day. With this invention, we can call it as a new use of an old drug. With this innovation, the dose of rifampicin has been reduced to 200 milligrams per day. 200 milligrams. What it has saved? It has saved the cost of the medicine. It has saved the patient from the adverse effects and toxic effects of the drug. So can we contribute? It is not necessary that we should just focus on inventing new molecules. We should focus on inventing new process. If we focus on any new use of the older things, old wine in new bottle, we can say, but it is true. Old wine in new bottle will also fetch a good value. If that bottle is good, if that bottle is attractive, then old wine will also attract the good value, good price in the market. Similarly, if you can focus on getting such type of innovations, other part is the sustainable development. If we focus on this, we can save the nature also, we can save the environment also. So, in fact, I am not that great to give you the advice, but I just like to give the direction. If we can think in this direction. Second thing is spoken many times that so many number of the participants, so many number of the speakers, keynote speakers, all the things. But I think personally that the success of any event should not be counted quantitatively by the number of participants. We have adopted online hybrid mode and online as well as offline mode. That can be one of the reasons why the number of participants are so much increased. I will try to focus on another thing. Nowadays, all of your teachers, you know that we are focusing on the outcome-based education. When we organize such type of conference, initially, before the conference, we should be able to define the outcomes of this conference. What we are going to achieve from this conference. And at the end, there should be analysis. There should be analysis, qualitative as well as quantitative analysis, that whether we have achieved. Because the international conference should not be only to add a figure in the cap of the institution, to add one point in the NAC report of the institution, to give some of the certificates to the participants. This is another part. But what is the outcome? If this conference has ignited the minds of some researchers and it is going to give rise to some of the patents, the patents which will be commercially viable, which will really help for the sustainable development, then I will say that such type of the conferences, such type of the international conferences are fruitful. And therefore, I will appeal the organizers that you can do such type of the exercise. So whether we have, what were our targets, whether your targets were only in terms of quantity or quality of the conference also, and analyze on these targets, on these outcomes, whether we have achieved these outcomes or not. Because this will help us to arrange other conferences in future also. I'll not take much of your time. On behalf of trust management of this institution, I will assure you that now the chemistry department has organized such type of the conference. If any other department comes forward to organize such type of the conference, the seed capital for organizing such type of the conferences will be definitely given by the management on refundable basis, definitely. So again, once more, I congratulate all of you and wish you all the success. Thank you very much.
Thank you. Again, sir, I should not leave the opportunity to tell you that we have a routine system of having lightening the lamps by providing a lamp to others. And the result is a grand success of this international conference and many more happenings for the betterment of the college. Every day and every moment is a new step. In terms of the language of research, we can say new research. And we follow the steps in making something new in the college. Even as a small part of the events, all the living bodies under the roof of Mata Narsamma act for do something new. Even though the conference was in hybrid mode, online participants also have shown their keen interest through the online mode. Now, as Honorable Kadikar sir has honored with the words that Army head of the international conference, that is Dr. Madhure, I request Mr. Kanwaran to please conclude the valedictory function through his words of thanks. Please.
Mata Saraswati, Sant Garge Baba, and the Mata due to which we all are here in Srimati Narsamma. The name with her, we started our trust, and before some years, the name started of our college. The name of her. Because she donated this land for the academic purpose, this broad purpose. Here, they started a college, and we get opportunity to teach the students which are nearby to us, which comes from the this society, this poor society. The maximum students of our college will become from the economically poor, not socially poor. We can say this is the economically poor, because they are all are capable to do everything, but they are only financially weak. So we all are get opportunity due to this Srimad Narsamma Mata, and so firstly I express my gratitude towards her. Here, as a convener, respected esteemed dignitary speakers, delegates, colleagues, students, and dear participants. It is a great honor and privilege to stand before you as the convener of this esteemed international conference. The success of this conference would now several individuals and organizations. I extend my deepest gratitude to our esteemed speakers, panelists, and session chairs for sharing their and inspiring us with their knowledge. I sincerely appreciate the efforts of their expertise, uh, the efforts of our organizing committees, sponsors, and institute partners whose direction has made this event a grand success. here, when we think about to organize a conference, because management is our parent body. So with the blessing of them, we started our journey. So first blessing is comes from the our management and then our honorable principal. So when we meet with our management members, they appreciate and motivate us to organize this conference that increases our energy to organize such this event, international conference in hybrid mode. So I thanks to all my parent management members who gives this opportunity to us to organize this conference. I thankful to Sri Kiran sir who gives some guidelines here that how to organize or how to what are the objectives of the conference. We are trying our best in the future. Rajesh Chandranpal sir, who stay with us in every moment of this conference. In the situation of illness, he also stand with us with start from the morning. Today, he unable to come due to high fever. So I express my sincere thanks towards him. Then I express my sincere thanks towards my departmental members who are two heads, Dr. Srikant Mansur sir and Dr. Umesh Khandekar sir, with my colleagues and friends, Dr. Mahendra Singh Pawar, Dr. Srikant Deshmukh sir. So they also support in every moment and stay with me. Because to organize any kind of conference or any event, the many pains are come with this. So to handle this, because success will be seen, the pain not seen. So when we try to organize, because our college is a small college, we are not that kind of name that the entries or all the things come on the name. We are trying to achieve that goal, but we are not in that situation or in that position. So the first our target is to achieve the 200 registrations. Out of that 200 registrations, the minimum 100 from the teachers and 100 from the research scholar or students. So this is our first target. And by the blessing of all the teaching and non-teaching staff, because the subject is not a boundary line, because every subject person who is cooperate, every non-teaching person is also cooperate to achieve this goal, and we achieve the more than 475 registrations for this conference. Because you also seen some yesterday, many of the faculties is come here. This is come here. They all are come here due to only love. We are not any kind of power. So this is our achievement. This is our goal that we achieve this achievement because more than near around 100 teachers they join offline. Many research scholars from the other universities also they have come join here because they all are known this conference is hybrid mode. So I thank to all these participants who show their love to all of us. I also thankful because here we have some fixed pay adult teachers. Their dedications are made possible to organize this conference. All departments, not here I am not taking only the name of only department because all the departments show dedication here and the ad hoc teachers also dedicatedly involved in all the things. Also our junior college teachers they are also involved here. I break the protocol and try to speak in Marathi. मित्रांनो, या ठिकाणी आपण हे जे काही यश प्राप्त केलेलं आहे, आता काल जे आपल्याला भाषणामधून सर्व गेस्ट हे सांगितलं की कोणत्याही कॉलेजला, कोणत्याही महाविद्यालयाला 200 रजिस्ट्रेशन प्राप्त करणे हे एक डिफिकल्ट टास्क असतं. आपल्याकडे कोणत्याही पद्धतीच्या पॉवर नसताना, कोणत्याही पद्धतीच्या आपल्या मागे बॅकबोन नसतानाही फक्त प्रेमाच्या भरोशावर हे सगळे रजिस्ट्रेशन आउटसाइड द कंट्री नियर अबाउट 5 कंट्रीज मधून आपल्याकडे पार्टिसिपंट इन्व्हॉल्व झाले. काही जणांनी किती आपल्याकडे प्रेझेंटेशन सुद्धा दिले. त्याचप्रमाणे देशातल्या वरच्या म्हणजे जम्मू पासून देशाच्या खालच्या टोकापर्यंतच्या प्रत्येक पार्टिसिपंटने या ठिकाणी रजिस्ट्रेशन केलेलं. त्यामुळे हे सगळं जे 475 जे आपलं टार्गेट आपण अचीव केलं, त्यामध्ये आपण सगळे लोक आहात. हे फक्त मी एक या ठिकाणी एक काम इनिशिएट करणारा होतो, परंतु हे सगळी मोठी शक्ती होती आणि हे सगळं क्रेडिट या सर्वांचं आहे. त्यामुळे या ठिकाणी माझा मुलगा रोज एक गाणं वाजवतो. मी त्याला जेव्हा शाळेत सोडतो, तो एक रोज गाणं वाजवतो आणि तेच गाणं या ठिकाणी साथ चले तो जीतेंगे हे जे गाणं आहे ते गाणं तो रोज वाजवतो आणि तेच या ठिकाणी की आपण सगळ्यांनी सोबत चालल्यामुळं आज ही जीत आपण हासिल केली. थँक्यू ऑल.
With the permission of chair, I declare that this valedictory function is over. Thank you very much. फोटो काढा. आजा आता मराठीत चालू या फोटो काढा. झाले का?